Hello everyone, welcome to BYJU'S Exam Prep. Hope you guys are fine. So come on guys, join the session fast. Okay. So guys, ready? Good morning everybody. Alex, Swapnil, good morning. Guys, share it on your all your groups fast so that we can start the session. Be fast. Good morning. I'm good, Swapnil. How are you? Okay. So guys, today we'll be starting hydrology and irrigation as you already know. So I guess you are ready for it, right? So today we'll be starting that. Before that, let me tell you that there is a mega workshop which will be going on 15th of Jan at 12:30 p.m. If you are a 2024 aspirant, then you can attend this workshop. Super fine. Good. Fine. And this Maha Marathon, as you know, it's a non-stop Maha Marathon of 8 hours. Sometimes we have more than 8 hours also. It's a 15 days complete revision series going on. Good morning, Rakhi. Good morning, Kom. Everybody, good morning. Guys, share it with all your friends. Be fast. Just let me tell you, Swapnil and everybody, Lisa, everybody, that there is an all India open mock test for GATE 2023. You can give anytime, anywhere, any place from 10th Jan to 16th Jan. You register yourself so that you can know what is your rank as compared to all the other aspirants who are preparing for the GATE examination. Okay. Next, there is a test series of BYJU'S Exam Prep which offers full length mock test, subject test which can also be given. Okay, and what are the features of it? It's also mentioned your rank, analysis, detailed solutions, everything. Okay, last you can join my Telegram group, and for GATE preparation ebook link is in the description. Okay, so guys, ready? Come on, guys. How's the Josh? Come on. How's the Josh, guys? Tell me fast. How's the Josh? How's the Josh, guys? Faster, faster. Ready, everybody? Ready? Faster. Ready, everybody? Really high. Good, good. Okay. So, guys, hi, sir. Josh is at speak. Good. I was missing Arun only. Where is Arun today? Fine. So, good morning, Prince, Ayushi. Okay, everybody whom I know, basically every day they are present. Okay, guys. So, shall we start? Okay. So, first we'll be starting engineering hydrology and then we'll be moving towards irrigation engineering. Good morning, everybody. So, first engineering hydrology, then irrigation engineering, and I have made it like that 4 hours around for hydrology and 3 hours around for irrigation. That's more than sufficient. Okay. So let's start then. Let's start today's session. Okay. So first we will be starting from what? We'll be starting the hydrological cycle. Okay. You already know when we say hydrology, hydro means water and logy means study of science of water. So basically in this hydrology, we study the science of water. Now, what happens in hydrology? In hydrology, we talk about the occurrence, circulation, and distribution of water on the earth and its atmosphere. Okay, now you already know that whenever we want to start, because let me tell you, hydrological cycle is a dynamic cycle. Okay, like you know na कि मुर्गी पहले आई थी क्या अंडा? First the hens, chicks came or the egg came. Nobody knows that. Okay, similarly, from where does this hydrological cycle starts? Nobody knows that. Anybody know? When first chicks came or first egg came? Come on, tell me. Do you know that? With scientific reason? No, I don't think so. If anybody, you can comment and tell me. Similarly, hydrological cycle is a dynamic cycle. It's a never-ending cycle. When the earth was formed, from that time the cycle is going on. The only difference is the water is converted into various phases. That's it. That's it. Okay. Now, knowledge abhi just start hua beta. Just now it started. Okay. Now, so we'll start this. First of all, what will happen? First of all, what will happen? We will start from the oceans. Now, if you will say, ma'am, why you started from the oceans? You can start from anywhere. But for study purpose, I have to pick up a point. So I started from oceans. Now, you know, when oceans are there, as you can see in this diagram. So oceans are there. So in oceans, water is there. Okay. So now there will be a sunlight. From childhood we make sunlight like this, and now also we make it like this, somewhat like this. Okay, this is our sun. Now what will happen? The sun's solar radiation will strike the oceans. What will be happening? Evaporation will be happening. So what will happen? Evaporation will take place. These evaporated water will go what? Will form clouds. Clouds will go condensation, and we will lead to, it will lead to precipitation. Now, precipitation, it will happen on the oceans. It will happen on the oceans. Precipitation will happen. What will happen? Wind will also blow. Hawaii. Okay. So, you can say wind is will be blowing. So, what will happen? It will take the clouds with it towards the land. It will shift it towards the land. So, what will be happening in the land? Now, in the land also precipitation will take place. But what happens in the land when precipitation takes place? Before that precipitation reaches to the Earth's atmosphere, it vaporizes back. It evaporates first. Secondly, when the precipitation takes place, some amount of water gets collected in the trees, gets collected in the rooftop of the buildings of your homes. This happens. Guys, you tell me, when you drive, when the rainfall is over, now no precipitation is there, and when you drive your scooty or bike or anything, two-wheeler basically, so what happens when you drive it and when you pass it from the trees? Although there is no precipitation currently, but then also you get the splashes of water. Yes or no? You get the splashes of water and you're like, Pani kahan se gira? From where the water is coming? That is the intercepted water. The water, that's first of all, the trees and plants are the natural obstructions, and the water is retained. So that is the interception. Yes, interception loss. Secondly, when we talk about in the buildings and all, generally, you know, whenever there used to be you can say when we used to be small in a sense, when we used to be a kid, when the water used to get deposited, you can say, or the significant amount of water used to be there in the terrace and all, we used to jump and splash it out. So that water which used to get collected, that is also an intercepted water, but that residential area, homes, buildings are created by us. So that is an artificial interception. Okay, there's other things. Then what happens? What you get next is, you know, gadha, depression, storage, ditches. How can you not know when you are here in India? Okay, and we are proud of it, because when you drive your bike and it's like tick 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 tick, it has a different sense of, you can say, happiness. Yes or no, Swapnil? Because we get ditches, and specifically in rainy season, it's so cool, right? So in these ditches and all, water's there. In the rivers, water of precipitated water comes. So that is what? That is the depression storage. Next, coming further, a part of the water gets infiltrated into the ground. Okay, the vertical movement of water into the soil. The vertical movement of water into the soil is termed as infiltration. Okay, so after all these losses, one more is there. What is there? When plants prepare their food, the roots takes water, okay, and the leaves prepare the food. Now, obviously, everybody know that plants prepare their food by the process of photosynthesis. Photo means light, synthesis means making. You know that, right? Photosynthesis. So now what happens is, during the opening and closing of stomata, during the preparation of food, certain amount of water is lost from the leaves of the plant. So whenever you see, you can see the droplets of water in the leaves. That is what? That is what? That is transpiration. So you say that the plants transpire. So that is what? That is transpiration. Okay, so after all these losses, interception, transpiration, evaporation, infiltration, even what happens, you see that basically we have two more things. Ma'am, what are the two more things? One is the seepage, or you call it as prompt interflow. Prompt interflow. And the second one is the base flow. What happens when the water penetrates inside the ground? When the vertical movement of water is there, what will happen? There will be difference of head. Head means generally we represent energy in terms of per unit weight. So energy per unit weight is termed as head. So now what happens when there is difference of head? Difference in energy, water moves from one point to another. Water actually seeps. So that is known as prompt interflow. But why does it known? You called it seepage, that we understand. But what do you mean by prompt interflow? Actually, when this water seeps, after a few days, few hours, you can say it joins a nearby river streams, whatever is there, it joins there. So it is known as prompt interflow. While you can say long continuous flow which is taking place below the ground level, that is the base flow. You call this flow as delayed flow also because it take this base flow take years to go and meet the nearby rivers or streams. So that is why there is another name for base flow, that is delayed. And after all these things are there, after that the net quantity of water which flows, which runs, that is known as the runoff. Okay, so in the whole hydrology, the only thing which we are concerned about is the runoff. Okay, any doubts till here? Will you take OCF marathon? I guess Joshi sir would have taken it, beta. Okay, so that is known as what? That is known as runoff. Okay, now coming further, you know hydrological cycle already told you. Now comes to the residence time. Average time which is taken by the water molecule. Okay, how much time the water molecule take to pass through a particular phase of the hydrological cycle. To pass from one phase, how much time does that particular water molecule takes? That is known as residence time. That is known as residence time. Now coming further, catchment area. Remember, they can write catchment area, they can write basin, they can write watershed. Everything means the same. So what happens? That area from which the water drains to the nearby rivers or streams. If you can see, this is the area from which the water drains into the nearby rivers or streams. This is known as what? This is known as one catchment area because this portion area contributes to this river. This portion of the catchment area contributes to this river. So this is one catchment area. Okay. Similarly, here there might be another one which will contribute. So this will be second catchment area. Second catchment area. And the line which separates, so you can call it in a fashionable manner, demarcates. So the line that demarcates one catchment area from the another, that is known as what? That is known as ridge or ridge line. And there's one more name of what? Generally we call it ridge line. So that line which demarcates means separate one catchment area from the other. So this line is known as, I'll write it also, ridge line. This is known as ridge line. Okay, now how can you forget the water budget equation? You know, mass of inflow minus mass of outflow is equal to change in storage. If the density of inflow water, remember, generally we say mass of inflow water minus mass of outflow water is equal to change in storage mass of water. These basic things you guys forget. Watershed line. Very good. Both are on very good. Good morning, Girish. So now what happens? If the density of inflow, outflow and change in mass. Everybody's density is same. So we can say volume of inflow water minus volume of outflow water is equal to change in storage. See, in the question, you guys get confused. One hack I'm telling you, guys get confused whether the storage is positive or whether it is negative. So generally you should know that when inflow is more than outflow, storage is positive. Now the question comes is, basically what happens, generally they don't mention like this. They will say the decline in the storage level of water. That means the storage has decreased. So there will be a negative side. The increase in the storage level of water, that means storage is positive. So these words you have to take care of. Okay. And inflow, you know, inflow like some water comes and some precipitation can there. So that is inflow. Outflow, you have, which are the outflow? You have seepage, you have evaporation, you have transpiration. What else, guys? Some amount of water withdrawn, n number of you can say outflow is there, infiltration is there, so that is change in storage. This is the whole thing. Okay, and generally we say precipitation minus evaporation minus runoff minus transpiration, what else, minus groundwater flow is equal to change in storage. Now what they can do is, if they want to ask you in 1 marks, what they can say, they can write all these, they just mingle up with minus, plus and all those things, and you have to correct the basically take the correct answers. So the trick is PERT G. PERT G. So precipitation, by the way, you know the simple logic, so I don't think there is any hack which I should tell you. Precipitation, evaporation, runoff, transpiration, groundwater flow, that is equal to change in storage. Okay, clear? So we'll deal this question along with evaporation. Simple question is there. So any doubts, guys? Faster, faster. So this is the water budget equation. Now we'll move to the next topic, that is the precipitation. Any doubts still here? No doubts? Purging. Yes, correct. Okay. Now we'll be talking about precipitation. Generally, I told you before also, when you see your Google weather forecast, you can open it now if you don't believe me. Open it now. It never tells rainfall. Okay, it never tells rainfall. You can open it now and it will tell you, let us suppose 40% chances of precipitation today, 50% chances of precipitation today. Ever you see, you will see that they write it precipitation, they never write it rainfall. You guys can check it out yourself if you won't believe me. So what happens is, when you talk about precipitation, there are various forms of precipitation. Out of that, rainfall is the predominant form of precipitation as compared to the other ones. Now rainfall, you say that the water droplet size varies from, I am telling you, tell me whether it is correct or not, 0.5 mm to 6 mm, correct or not? Yes, we report rainfall in terms of depth. 0.5 mm, the size of the water droplets varies from 0.5 mm to 6 mm. Yes or not? Lisa, everybody. Correct? Now, how come, how come the people know that, if you see specifically when we are talking in English, so basically what will happen, you should, if you read a newspaper, they write heavy rainfall. In Hindi, whenever you listen to the news channel, मूसलाधार बारिश हुई, तेज बारिश, heavy rainfall. How come they know that it is a heavy rainfall? Means, were they standing in the rain? Okay, fine, I'm getting hurt, so it is a heavy rainfall. No, technically not. So everything what they say, it's like तेज बारिश हुई, हवाएं तेज हुई, मूसलाधार बारिश, everything what they were saying. So basically that is scientific, logical, that you should know. What is that? If the intensity of rainfall is 0 to 2.5 mm, that day rainfall you call it light rain. 2.5 to 7.5, generally in place of 0 you write it actually trace. Okay, you can write 0. In some books you will see 0. In some books you will see traces of rainfall. Okay, and when the intensity of rainfall is greater than 7.5 mm per hour, you call it as heavy rainfall. Simple as that. Now, drizzle. Guys, you specifically those who watch match and all. You would have seen in the anchoring whenever the rainfall is not there. Okay, rainfall is there, then the match is postponed. Even when drizzling and all come, what will happen? The field becomes slight wet. Okay, the ground becomes wet. So that is the reason you guys have seen that people run with some sort of you can say cloth, or you can say some sort of sheet to cover the area, to cover the pitch. Yes or no? And you see that drizzling comes, so the match is postponed or the match is shifted for the second half. I'm just telling so that you can relate. The commentary word drizzle you guys would have seen, you had heard of. Okay, and in the basically in this, whenever you see it in the television, it comes like that only. So due to drizzling, the match has been shifted for the next day, or the match has been shifted for the second half. So this word drizzling is, it's not a rainfall. Whenever you when you travel by your, you can say by a two-wheeler and all, you see that some sort of water is coming. Okay, but it's not that you become wet. So drizzle is when the size of water droplets is less than 0.5 mm and intensity is less than 1 mm per hour. Somewhere I'll write wrong also so that I can know where you are guys are sleeping or you're not. Toss delayed due to wet outfield. Toss delayed due to drizzling also you can say. Okay. So intensity less than 1 mm per hour. So that is the drizzle. Now, okay. Now talking about hail. In Hindi we call it ole. Yes or no? So when it strikes, you're like, it's paining, because when you go in that thunderstorms, generally hail occur when the vertical currents during the occurrence of thunderstorms only you get the hail. So hail is basically lumps of ice. Lumps means like in Hindi we call it dilla. Okay, so basically it's the lumps of ice. Generally the size is more than 8 mm. So you call it as hail. Okay, and this occur during the time of thunderstorms when vertical currents are high. Now, generally students get confused in glaze and sleet. There's glaze and there is one thing which is sleet. Now, both are almost similar. There is a one in local language, gargiri. Yeah, you can say that. Correct. So now, maximum students get confused in glaze and sleet. When rainfall or drizzle, anything, comes in contact with ground, remember, comes in contact with ground at 0 degrees Celsius or at sub-freezing temperature, then what you get is termed as glaze. Similarly, when you talk about sleet, when rainfall or drizzle comes in contact with air which is at 0 degree or at sub-freezing temperature, then what you get is termed as sleet. So generally you guys get confused. When it is ground, it is glaze. When it is at air, which is at 0 degree Celsius or sub-freezing temperature, then you get sleet. Clear? And you call sleet as frozen raindrop of transparent grains. Frozen raindrop of transparent grains. Okay, so this you should know. Now, and glaze you call it as freezing rain also. So these were the basics. Now let's come to the numericals. Before that, let's discuss some terminologies. Okay, so we have daily rainfall, the rainfall data which is collected for a day, that is daily rainfall, that is collected for 24 hours. Annual rainfall, the rainfall data which is collected for 365 days, that is what, or for a year, you call it as annual rainfall. Now two things which maximum students get confused: average annual rainfall, and the other one is normal rainfall. So guys, tell me, average annual rainfall is the rainfall data of 30 years or 35 years? 30 years or 35 years? Come on guys. Average annual rainfall is the rainfall data, average of annual rainfall data of the last 35 years. While normal rainfall is the data, very good. No, Lisa, normal rainfall it is 30 years. Average, generally students get confused and they can ask you in MSQ pattern questions also. Normal rainfall, rainfall data of the 30 years data. Okay. Now normal rainfall can be for a day, can be for a month, like September. If I'm saying September, so September average for the last 30 years. Okay. So it can be for a day, it can be for a month, it can be for any day. Okay. Now let's talk about index of wetness. Index of wetness, IOW also you write. How much rainfall took place in that particular year divided by annual average rainfall, that is the rainfall average of annual rainfall data of the last 35 years into 100. Now guys, tell me one thing. Index of wetness, if it is 60%, how much is the deficiency? How much is the rainfall deficiency? Rain deficiency, I've written rainfall deficiency. How much is the rainfall deficiency? Come on guys, faster, faster, faster. 40%, you know percentage means 100. So if that day rainfall or that year the rainfall took place, index of wetness comes out to be 60%. So the deficiency of rainfall for that particular year is 40%. Correct. You guys know that. Okay. Now let's talk about drought. Drought we call it sukha. What we call it in any other state language people we have guys, our drought. Generally we call it in Hindi sukha, right Arun? Girish, everybody. So now what happens? Flood we call it bar, drought we call it sukha pad gaya. So drought also we have three different types: meteorological drought, or you call it as meteorological drought, hydrological drought, agricultural drought. Now meteorological drought. What do you mean by meteorological drought? When the deficiency is more than 25%. When more than, see guys, generally numericals are not there, but generally you leave these topics, okay, because you think kaun padega isko. But let me tell you the truth. The year when it is asked, jis saal puchega, after that from every year everybody will study. But what about the students who appeared for this year? So that is the reason, since MSU pattern are there, you have to study this. So more than 25% deficiency you get, you call it as meteorological drought. Then you have rain deficiency and the type of drought. This I am giving you in the tabular format. They can give you in the statement format. That's it. That's the only thing which they can do. So rainfall deficiency 25% greater than that, 25 to 50% greater than 50%. So the type of drought, this is normal drought. This is moderate drought. And this one is the C. Okay, so this comes under meteorological drought. Now, hydrological drought, if you call it. One more thing, let me tell you. Less than 25%. Yeah. I've written greater. Less sign should be there. I'll write it down. That will be better. Less than 25%. Correct. Correct, Girish. What I was saying, if the probability of occurrence of drought, if probability of occurrence of drought in a region is 0.2 to 0.4, what do you call that region? Come on guys, what do you call that region? If the probability of occurrence is 0.2 to 0.4, what do you call that region? Come on guys. What do you call that region? Nobody knows also. Drought prone area. And when it is greater than 0.4, greater than 0.4, only greater than, you call it as chronologically drought prone area. Okay, chronologically affected area. This is less than only now. I don't know. I'm asking to you guys. I don't know. Tell me, this is less than or greater than? Girish told it should be less than. What about the others? Lisa, Dinesh, everybody. Prince, it should be less than or greater than? Tell me fast. Less than, greater than? Less, greater than. Less. Fine. Before this chapter ends, you have to tell me. Okay, now we have to talk next about, this was regarding meteorological drought. Now talking about the hydrological drought. If you see, the level of water in rivers, streams has decreased because of excessive use of water. That time the drought you get is termed as hydrological drought. That time what you get is termed as hydrological drought. Agricultural drought, deficiency of moisture which is required by the crops. If there is a deficiency in the moisture, deficiency in the moisture content which is needed for the growth of crops, in that case what you get is agricultural drought. Okay, greater than 20 हो तभी तो meteorological drought होगा. That's the thing, na. No, we are talking about the classification. See, I give you two, less than, greater than. Everybody you have to tell me. 5, 6 students are only telling. Now, based on this, we have an aridity index, which we call it as AI, which is potential evapotranspiration minus actual evapotranspiration divided by potential evapotranspiration. Now, this terms I will discuss because there is a different chapter for this. So I'll discuss there. Just now remember this, that this is the aridity index. Okay, or if you want, let me, because we haven't dealt evaporation and all. So let me deal that. Then I'll tell you what is potential, what is actual. Okay, so this part, because there's a different chapter, we will discuss that. Now, aridity index, as already told you, 0 to 25 percentage, 25 to 50 percentage, 50% more. Already you know what is the type of the droughts we get it. Clear? Okay. Now, just by looking at this, what you can see, what I'm going to teach you, just by looking at it, guys. Don't look what I'm writing. Nobody knows. Oh my God. Double mass curve. Is it? When you have to check the inconsistency. What happens if somewhere you were getting a graph like this, suddenly you got like this. You're like, kuch to gadbad hai daya. Something is wrong. So for checking the inconsistency, we go for double mass curve. Correct, Arun and Girish. So now what happens here, when who told mass curve? Means mass curve you talking about, that is accumulated rainfall time. Here you have mass on both the sides. Okay, so this we use it whenever there is inconsistency. Inconsistency meaning, I guess you guys know, whenever you say that some cricketers are there, guys, everybody just understands from the cricket. So like, sometimes the cricketer scores 0, sometimes he scores 100. Then next match he's out at 0, next match again 50. हाफ सेंचुरी सो यू से दैट ही इज नॉट अ कंसिस्टेंट प्लेयर चल गया तो चल गया नहीं चला तो फिर कुछ नहीं बोल सकते यू से इट इन हिंदी राइट राइट अरुण लीजा एवरीबॉडी वी से लाइक दैट okay and then we say like initially you used to call Surya Kumar that he is something like this. Now everybody says what a player Surya Kumar is. So what do you think? You just check the form. You say now this player is in form, this player is consistent, आएगा तो 50 मार के ही जाएगा. You say like that. So what is that? You talk about consistency. Like if I say that you guys are giving the mock test, it's not like that you scored 0 or 70. It's like every paper you score 50, 60, 70, like that. So I say that you are a consistent performer. But if you see inconsistency, kabhi 0, kabhi 100. So that is the inconsistency we talk about. Okay. So that is the inconsistency we talk about. Now, why this inconsistency happens here? Because when the rain gauge is an equipment which is used for the measurement of rainfall. When the rain gauge is shifted from one place to another, or the nearby rain gauges have shifted, natural calamities like flood or drought have occurred, and number of reasons could have been there. So now what will happen? when you want to check the consistency, whether it's consistent or not, or whether you have to you have to do the correction, what you will be doing, you will calculate, or basically you will take out the accumulated annual rainfall of the station X, where you are seeing that inconsistency of rainfall data is there. And nearby to that rain gauge, 5 to 10 rain gauges would be there. You will take the average of those rain gauges and you will plot it on the axis, or you can say it on the x-axis. You will plot it on the reverse chronological manner. Reverse chronological manner means latest at first and the oldest at the last. Now, why do we do this? Anybody can tell me why we are plotting it in a reverse chronological manner, like first 2022? I want the answer for this. Anybody? Generally, we believe that currently what are the readings which we are getting, we have an advanced techniques equipments. So whatever reading we are getting is accurate, less error as compared to the readings which we have got in the earlier years. Recent trends technically latest, yes, Devanshu, very good. Oh, Devanshu is also there. Okay, fine. So now let us suppose after 2019 the data comes like this. See, you will be plotting the cumulative. Accumulated, cumulative means the same. So you can say from 2019 you will be seeing what after 2019 you are seeing in the inconsistency in the record. Actually it should follow this pattern, but it is following this pattern. So what you will say? This is the corrected one and this is the actual one. So what do you say? Corrected precipitation at station X is equal to the initial precipitation into MC by MA. MC by MA is the correction ratio. This names you should know because these are the topics which are untouched. They haven't asked from these topics. Okay, and MC is corrected slope and MA is the actual slope. Okay, so this is the double mass curve. N number of times in A, J, ESC gate, inconsistency of record, double mass curve. Inconsistency of record, double mass curve. Okay, now when you talk about rainfall, basically what you happens when we talk about it, network densities, we have the magnitude of rainfall, the topography, the accuracy we talk it about. Okay, so you should know all these terminologies if they talk it about. Okay, man, addition or omission of rain gauge can also cause this. Yes, addition, omission can also cause this, or shifting of nearby rain gauges can also cause this. Okay, now coming next, rainfall. Rainfall is measured by pluviometer, ombrometer, hytometer, rain gauge, rain gauge. Some people say everything means the same. Okay. Now what happens here? As Lisa said first, now or anybody said that time, that generally, see, I can, from my home, if let us suppose the mall is 10 kilometers, I can say 10 kilometers. I can say 10 into 10 raised to power 3 meters. Which is the one which quickly you understand? 10 kilometers or 10 into 10 raised to power 3 meters? Which one you quickly understand? 10 kilometers? Okay. So same phenomena. Rainfall you can represent in meter cube, you can represent in hectometer, you can represent in centimeter cube, n number of units. But I say, कल बारिश हुई, yesterday rainfall took place and it was 2.5 centimeter. Immediately it will strike to your mind because you know the scale, 2.5 centimeter, you will say, oh, this much rain. So generally it's not hard and fast, but for understanding point of view, depth appears to be easy. So that's the reason rainfall you represent in terms of depth. Okay. Now when you represent in terms of depth, you assume that uniform depth is there along the catchment area, and that is the reason we represent in terms of depth. Okay. Now when you know that when we install this rain gauges, okay. And one more thing, while we requirements, every requirements you should know. What are the requirements? That the ground should be leveled, it should not be undulating and all, the ground should be leveled, okay. What else? The fence area, open fence area of 5 into 5 or 5.5 into 5? 5 into 5 or 5.5 meter into 5.5 meter? I'll only write open fence area of at least 5.5 meter into 5.5 meter. 30 meter, 30 meter. And one more thing, no object should be near to the instrument more than 30 meter or 2 times the height of the obstruction, whichever is more. And we do the fencing, and it should not be placed very low, otherwise floods and all will come, very high, otherwise the effects of wind will come. Okay, so these are the basic requirements which you should know when you install rain gauges. And you know types of rain gauges, we have non-recording rain gauges, which is Simon's rain gauges. Now it's obsolete, we don't use this, but it used to be there. Recording rain gauges, we have tipping bucket type. Names you should know, that's it. Weighing bucket type, and last one is float type, or you call it as natural siphon type. Out of all the recording rain gauges, let me tell you, the one which is used on prominent basis is natural siphon type. Basically in inaccessible areas and all, where you cannot go every time. What pain? What pain you are getting, beta? So float type, or you can say natural siphon type. So this is what the recording rain gauges. Out of this, the prominent basis we use float type. In India, we record rainfall at 8:30 a.m. every day. Now I'll ask you one general question. Tell me. Let us suppose today's what date? 11 January. Okay. Too much pain regarding what, breakup? So tomorrow was 9th January. So let us suppose 9th January morning 6, or you can say morning, I'll say from 10 a.m. to 11 a.m. rainfall took place 2 centimeter. Example I'm taking. 5 p.m. to 6 p.m. rainfall took place 1 centimeter. 10th January rainfall took place from 4 a.m. to 5 a.m. again 1 centimeter. So the total rainfall is 4 centimeter. One question, guys, for you all. When suppose Yashu will go at 10th January at 8:30 a.m. to check how much amount of rainfall is there in the non-recording rain gauge, it is 4 centimeter. So that rainfall is of 9th January or 10th January? 9th January or 10th January? 4 centimeter rainfall is of 9th January or 10th January? Come on, guys. 9th January or 10th January? No, that is for 10th January. Before 8:30 a.m., whatsoever rainfall you are getting, that is for 10th January. Okay? 10th. Fine. Okay. So now talking about the optimum number of rain gauges, we have the optimum number of rain gauges also we have to talk it about. I'll take a slide. So we have to talk about the optimum number of rain gauges. Simple formula is there, and based on that numerical is there. That's it. Nothing more than that is there. Okay. So let's talk about it. Just a minute. I'll add a slide. So if we talk about optimum number of rain gauges, how much amount of rain gauges should be there. And you know now, as per the Indian Meteorological Department or IMD, and basically and World Meteorological Organization, you know that all the rain gauges which you have, 10% of that should be of recording type minimum, at least means kam se kam. Okay. Now what happens is, you know the formula, n is equal to cv upon e whole square. E is the allowable error, cv is the coefficient of variation, cv is known as the standard deviation divided by average precipitation into 100. Okay, and e is, you know, the allowable. This, remember, one thing I'll tell you, you guys might be making mistake in your mock test also. Sometimes they ask you optimum number of rain gauges, sometimes they ask you additional number of rain gauges. So when they ask additional number of rain gauges, then if n was initially there and capital N you got, so additional will be n minus small n. So read the question properly what it is asking you. Okay, now guys, solve this question. 4 rain gauges is given to you. It is asking you find the optimum number of rain gauges, non-recording and recording both. So guys, let's start. First, calculate the average precipitation. 100, 120, 140, 80 divided by 4. How much it is coming? How much it is coming, guys? N minus n mean Haj. Come on, tell me the value. 110. Standard deviation. And don't you think that they can't ask such type of questions because they're giving you virtual calculator. N minus 1, 4 minus 1. From here you will get the standard deviation. Now how much it is coming? Anybody? How much it is coming standard deviation? $27.69. Everybody is getting the same? If I'll write it here. CV is equal to sigma n minus 1 p bar into 100. Everybody is getting the same standard deviation? Dinesh, everybody? Yes or no? 20. Everybody, Arun is getting different. Just check it out, guys. Girish, 25.81. Two people are 27. I don't have an answer with me. 25.81. 25.81. Alek. Again calculation mistake beta. 25.81. P bar is 110 into 100. So it comes out to be 23.46. So n will be, n is equal to CV. On my head it is not coming, na, e square. So how much it will be? 23.46 divided by allowable error 10%. Generally it is 10% only. Divided by 10 whole square. It comes out to be how much? 23. It was coming 23.46 only, na? Uh, 0.46 something it was coming. Okay. So 23.46 divided by 10 whole square comes out to be 5.5. So you can take it as 6. So out of 6, 10%, that is 1. So 1 will be recording and 4 will be non-recording. Okay. Calculation, I guess you guys would have done it correctly. I'm assuming it. Okay. Okay. And what is the additional number of rain gauges required? Additional Additional, this is 5 will be the recording type. 5 will be recording. 5 will be non-recording, 1 will be recording. That then it will make 6. Additional, how much it is required? N minus n, 6 minus 4, that is 2. Okay? Now, coming further. Okay. Tell me the answer. See, I know you don't know the number of rain gauges. Okay. Based on your common sense, you can solve such questions. Number of rain gauges which is given to you. Na is given to you in what? Arid zone. Arid means dry. NB is tropical. And number of rain gauges here is flat region. Come on, guys. Tell me fast. Based on your common sense. Totally based on your common sense. That's it. Obviously, arid, what we will do, there is little or no rainfall. So the number of rain gauges will be more in the hilly areas, mountainous areas, then flat areas, and the last for the arid areas. See, it is asking Arsalan, this one you are talking about, Arsalan. This question you are talking about, number of rain gauges one, hydrometeorological stations one. So number of rain gauges, arid means it is asking how many number of rain gauges are there at each positions. You know, in hilly areas we have to, per kilometer square, we have to apply more number of rain gauges. The density is more as compared to flat regions, as compared to arid area. Because C option I'll write it when you can't see. Na is greater than Nb is greater than Nc. Okay, so we see that the number of hydrometeorological station will be more for the tropical, then flat, and then arid. Arid because little or no rainfall. Okay. Now coming to the estimation of missing rainfall data. Now what happens? Let us suppose I told Arun that Arun, you have to go at 8:30 a.m. in the morning and record the rainfall data. And Arun was busy talking to somebody whom he likes. Okay, or might be some bro that today we after gate examination we will do this fun, that fun, and he forgot that ma'am told to get 8:30 a.m. data. Or let us suppose he goes, but sometimes he records, but that data got missed. So that case, Arun will say, ma'am, what should I do now? Then I'll say, no, Arun, wait. We will take it out by the estimation of missing rainfall data. Now, what do you do in this estimation of missing rainfall data? Basically, we have two methods, you know. Okay, let us suppose A, B, C, D or 1, 2, 3 you can say. The precipitation is PA, PB, PC, PD. And the normal rainfall is NA, NB, NC, ND. Now let us suppose I want to calculate the precipitation in 2021 for at station D. So now what will happen? First I will check it out. The normal rainfall at station D, all the other normal rainfall data should be within 10% variation of normal rainfall at station D. Normal rainfall means past 30 years rainfall data, average of it for station D. So 0.95 ND, 1.1 ND. If every other values fall in this region, PD, or you can take it as PX for the unknown one, PA plus PB plus PC by 3, or you call it like this, P1 plus P2 dash 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 PM divided by M, which you see it in the books. Okay, when the normal rainfall at station X is within this variation. This time only sleeping. So while sleeping also he records and then he forgets where he kept the data. Okay. So this was one estimation as already written, not more than 10%. And when it is more than 10%, then this method is known by one name. See, once a gate question has been come in 2015, it didn't bother you calculate this. They have directly written use normal ratio method. So if they write normal ratio method, you just go by that, this one. In the previous one, it is arithmetic mean method, and this is the normal ratio method. Okay, your mind will work around. Don't take too much of stress. Okay, and when you're in the library, go out for some time, take fresh air, meditate too. Being in the library for the whole time, that I don't advise. Come on, guys. Okay, so just tell me this one. The double mass curve technique is adopted too. C and D option you can't see. Let me tell you, to find number of rain gauges required, C option, and D is to estimate the missing rainfall data. Check the consistency. It is the consistency. Okay. Come on, Arun, go and grab a cup of tea, beta. Come on. This is the question I was talking about. Very, very, very good question, I'll tell you. Before exam, practice this question and go. How? Let me tell you. Normal annual precipitation values is given to you. 780 mm. Come on, guys. Start to solve if you know, and if you don't, listen to me. 850 mm. 920 mm. And 980 mm. Now, in the year 2013, QRS were operative, but P was not. Using the normal ratio method, the precipitation at station P came out to be 860 mm. The precipitation at Q and R were 930 1010 mm. Now what? Remember, always and always, although it is asking you precipitation at station S, but the one which was missing was P. So always and always the missing one will come here. Don't write S here. Maximum students make mistake. Beta, read in the question, it is given that P was not operative. So you will write it here, PP, NP by 3, PQ by NQ, PR by NR, PS by NS. This will be the one. Not PS here. That will be incorrect. Okay. Now solve this. No tea, drink green tea. Yeah, well, he should drink green tea. That's cool. But generally we engineers prefer tea. Yes? Every other engineers, yes or not? We just prefer tea. This 850, it's not. PQ is how much? I haven't written PQ actually. PQ is 930. PR is 1010. No. Oh my god, how come? Nowadays engineer has stopped. T only for us. Although we shouldn't, but we did that. NQ I have written correctly. NQ is 850. This is PQ and PR. This is PQ and PR. I have written it wrong. PQ and PR. We only take green tea. Wow. Nowadays engineers are, you can say, very much good with their calories. Great. In our time when we used to go to coaching, we are like tapra mein, we used to drink the tea. PS, you have to calculate. NS, it is 980. How much it is coming? PS 104. Swapnil, is it correct? I don't think so. 930 divided by 850, and here already you know this precipitation at P is 860. I don't think you made mistake. गंदा कर रहे हो मेरी स्लाइड को तुम लोग गलत गलत बताते हो. T has everywhere in India T has another fan base. 1076. Just let me check it out then. 860. No, but this is the correct one, Rahul. This is the correct one. Where you have done like this, this is the correct one. Minus 930 divided by 850 minus 1010. 1093.43. You guys make me do it. हाँ मैम से करवाएंगे. मैम को बिना कैलकुलेटर के देखेंगे ही नहीं. हाँ. Fine. This question is a simple one. 4 rain gauges are installed. Depth is given to you. It is asking rainfall at station 3. Here you have to check it out. 60 centimeter. 2 it is 75. 3 it is 90. 110. So we have to rainfall at station 3. So in this, see, in the previous question, I saw it normal ratio method was written. Here normal ratio method is not written. So first we have to check it whether to use arithmetic or whether to use normal ratio. 90 into 0.9, 81 centimeter. 90 into 1.1, 99 centimeter. 110, 60 are away, so we will use this range. It doesn't fall in this range, so we will use normal ratio method. When you talk continuously, sometimes the words get swaddled out. Plus P2 N2 plus P4 N. 90 by 3. Remaining stations. 90 by 60 plus 70 by 75 plus 80 by 110. Come on, guys. 94.8 centimeter. Okay, you guys can calculate, simple calculation. Now, what are the methods? This is the last part I get, right? The last part, yeah. Methods to find average precipitation. You have arithmetic mean method. You have Thiesen's polygon method. If here, let us suppose, not let us suppose, let us know that Sachin is a very rich person. He is a millionaire. So he will take me because I am his ma'am. So he'll take me, ma'am, this area, you know, this is my whole acres of land, hectares of land. So at this portion, Sachin will tell me, ma'am, precipitation is P1. Because obviously the point where you will install rain gauge, there only you will get what? Rainfall data. This point the rainfall is P2. This point the rainfall is P3. And all those portion Sachin will be taking me because he has acres of land and he will tell me the precipitation. So I will tell to Sachin that don't tell me at individual positions. Tell me the average. So the arithmetic mean method, if he wants to tell me the average, so what he can do is simply if he wants to calculate the average, he will add the precipitation at all the points. But remember, he can do this only when there is almost even distribution of rainfall taking place. However, it cannot be used for any rain gauges which are located outside the catchment area. And if you compare all the three methods, the method with least accuracy is arithmetic mean method. Second is we have Thiesen's polygon method. In this, weighted, or you call it as weighted area method, because we give the weightage to the area enclosed to that rain gauge station. So you know the formula. If this P1 is precipitation is in A1 area, P2 precipitation is in A2 area, P3 precipitation is in A3 area. So average will be P1 A1 plus P2 A2 total area A. Okay, so this and remember, this is accurate as compared to arithmetic mean method. The rain gauges located outside the catchment area is also considered. While the third one, if I talk about isohydral method, I will draw it here. Isohydrals are line joining points of equal magnitude of rainfall. Here, here, here. If you see that equal magnitude of rainfall is there, you will join this. And let us suppose the precipitation is P1. So it's P1. This is P2. This is P0, P3. And with the planning meter, you will calculate the area. You can find it out. A4. So it will be like at A1, the arithmetic sum of the rainfall is taking place, P0 plus P1 by 2. Divided by the total area A1 plus A2 plus A3 plus A4. Out of all the most accurate one is the isohydral method. The rain gauges, see, all these are statement wise questions. The rain gauges outside the catchment area is not considered an isohydral method. Firstly, isohydral method is a costly one. It requires skilled supervision, and the more the number of isohydrals, more the accuracy. Okay, so now let's solve question. Let's solve this question, guys. Come on. Solve this question fast. Fastly. I'm not going to do it first. You will be the one who will be solving it. Come on, fast. Faster, faster. See, in the one question which was asked in GATE, that was asked. So in that question, what was there? In that only square was there. Here I have considered a triangle also with it. So that in one question, multiple number of concepts are clear. Fast. What is the first rule? Join all the rain gauge stations such that they form non-intersecting triangles. This has to be in the center. I'll take the other side of it. See, I'm drawing it freehand. So let me join it first. How much it was? 4.5, 1.6, 2.4. 4.5, 1.6, 2.4. Ready, Swapnil, Devanshu, everybody with your calculator. Huh? We will be doing the calculations fast. 1.3, 9.4. Now what you will do? What you will be doing? We'll calculate the perpendicular. We will plot the perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Similarly, here perpendicular bisector, here perpendicular bisector, which divides into two equal halves. So it will become like this. This is the figure which you will be getting. Okay, so you can say this is A1. You can name it accordingly yourself. A3. Okay, then A4, A5, A6, A7, and this one as A8. I have named it accordingly. Okay, now you know when it divides it, basically this will become an equilateral. It is already an equilateral triangle. You can see this area of the square plus equilateral triangle plot. Everybody has the size of 4 kilometers. Okay, so if I want to calculate the area, A1, A2, A3 will be the same. How much it will be? The area of equilateral triangle is root 3 by 4 A square, side square. And what you will do? 1 by 3. How much it will come? 4 by root 3 kilometers square. Now, what about the area of A4, A5, A6, A7? Every area is same. If this is 4 kilometer, half of it will be how much? 2 kilometers. Here also half of 4 kilometer will be 2 kilometers. And when you calculate by Pythagoras theorem, because this is a right angle triangle here. So you will get it here 2 square plus 2 square and root over it. 2 root 2. So area A8. 2 root 2 into 2 root 2. 4 2 is a root 2, 8 kilometers. So out of remaining will be how much? A4, A5, A6, A7. Area of whole square, that is 4 into 4, 16 square, minus the middle one, that is 8, divided by 4 for getting the individual. How much you will get? 16 minus 8, 8 by 4 is 2 kilometers square. Okay, this you got. Now you have to just calculate the average precipitation. How much it will be coming? 1.6, 4 root 3. 4.5 precipitation is there for how much? It is there for A3 and A7. A3 and A7. A3 is 4 root 3. A7 is 2. 2.4 precipitation is there for 4 by root 3 plus 2. 8, it is there for A6. 1.3 is there. What else is left? 9.4 is there for 8. Divided by whole. Whole will be area of square 4 into 4 plus area of triangle root 3 by 4 a square. Don't waste your time 4 root 3 typing it 3 times, then 2 writing it 4 times and 8 writing it 1 time. Okay, just do it like this because the total area will remain same. You can do it like this, or some people waste their time writing it like this. 4 root 3, 4 root 3, 4 root 3 plus 8 plus 2 plus 2 plus 2 plus 2. It will come this only. Okay, so roundabout value approximately you can check it out. I have told you the method 5.5 it comes in. You guys can check it out also. Okay, so clear? Sachin, Rahul, Prince, everybody, Swapnil, clear? So in the GATE question, it was given square. I have enhanced it square plus triangle. Okay. Now, this is an isoheight question with you. This is an isoheight question with you. This question I have taken because this word station is written. Many people do it what? Many people do it what? They write 0, 12 and they write 12 plus 0 by 2. And they take average precipitation, which is wrong. When it is written station, generally it means like this. Two options are not there. Na? A option is 3.6 centimeter and B option is 7.6. If it is getting hidden, I have told you the options. Okay, so it's like 12 is here, then 10, then 8, then 6, then 4. It is like this. Okay, 20. This is the isoheights. Let us suppose in kilometers square. 120. This is here. This is 20, 120, 60, 170, 30. This is the meaning of this. Here nothing is there. Here nothing is there. Okay. So that's it. Calculate it, very simple. 12 into 20 plus 12 plus 10 by 2 into 120 plus 10 plus 8 by 2 into 60 plus 8 plus 6 by 2 into 170 plus 6 plus 4 by 2 into 30. Divided by the total area. Total area is 20, 120, 140, 140, 60, 200, 200, 170, 370, 370, 34. So solve this, how much you will get? 8.6 centimeters. Very good, Alec. This time Alec did the correct calculations. Okay. So this was regarding Thiesen's polygon again. 10 raised to power 4, you don't have to take it. This question was there. Fine. This is again a question of Thiesen's polygon. 470. P1, A1, P2, A2. This only you have to do it. 470 into 95. 465 into 100. 435. Don't worry. 10 raised to power from the top and the bottom will get cancelled out. 98. 525. Guys, calculate. I don't have the answer with me. How much it is coming? The answer will come in mm. The answer will come in mm. You guys want to calculate or shall I leave this? You guys can calculate, simple it is there, right? 53.5, 33.63. See, I don't have the answer. Just check it out. 479. Two people, two different answers. Mohini, this time you are wrong, beta. This time it is coming how much? 479.09. Very good, Alec. But maintain this, don't make mistakes in calculations. Fine. Now coming to evaporation. Shall we start, guys? Shall we start? Devanshu, everybody. Shall we start now? Evaporation. You know, evaporation is a surface phenomena. Generally, we say the process of conversion of liquid into vapors, but it's not the correct definition. The process of conversion of liquid to vapor at the free surface. Free surface means there is a liquid flowing and the interface of it there is another fluid which exerts constant atmospheric pressure. Okay. Now what happens is whenever you know that evaporation is a cooling process, boiling is a heating process. Boiling requires a temperature of 100 degrees Celsius while evaporation does not require 100 degrees Celsius temperature for evaporating or for the process of conversion of liquid to vapor state. Moreover, those molecules which have a kinetic energy greater than the critical kinetic energy will at the free surface convert into the vapor state. You know that. Now, the question comes, what are the factors which affect evaporation? Again, these can be asked in statement wise. That's what I'm telling you. When we talk about factors affecting evaporation, you know that the rate of evaporation is CEW minus EA. C is a constant. EW is saturation evaporation. In some books, you can find it instead of EW, they write it ES. That's also correct. EA is the actual evaporation. What happens when there is a conversion? Here water is there. When there is a conversion of liquid into the vapor state, these vapors will exert pressure on the free surface. So the pressure which is exerted by the vapors at free surface is known as vapor pressure. If the vapors which are there, they are fully saturated, the voids are fully saturated, then you call it as saturation vapor pressure. And EA is the present actual pressure we are getting. Ma'am, probability what concept बता देना please. Probability वाला हाँ बता दूंगी. Probability what concept? You're talking about probability chapter ना हाँ. So this is, you should know this relation. And EW minus EA, if they give you somewhere, this is saturation deficit. Okay. Now, what is the relation between temperature and evaporation? They are directly proportional. However, there is no mathematical relationship between them. But if you talk it about, then you can say that the temperature and evaporation are directly proportional to each other. However, there is no mathematical relationship between them. Okay. Next, coming further. Wind. Tell me. I'm not going to tell you first. Tell me. Wind, effect of wind. Effect of wind on evaporation. Initially, it's more. Okay, as the wind speed is there, evaporation will increase. Why it will increase? Because here the molecules are there, the vapors are there, wind will take them off. Okay, so with a rapid rate, evaporation will take place. Otherwise, these vapors will exert pressure. So initially, with the increase in wind speed, the evaporation increases. After a certain time, even if you increase the speed of the wind, the rate of evaporation will remain as it is. Why it will remain as it is? Why? Because if 100 km per hour was the speed of the wind, let us suppose all the vapors were going. So even if you make it 120, 140, doesn't matter because at 100 km only the vapors went. So initially it will increase. After a certain time, even if you increase the wind, there will be no effect. Okay? Okay. Atmospheric pressure. More the pressure of the atmosphere, lesser will be the evaporation. So inversely proportional. Okay. Then soluble salts. if salts are there, like in oceans, you see that salts are there, then first there is a bond between salt, like there is a bond between you and me. But afterwards, what will happen when you will get good rank in GATE? I also want. Then eventually, with some students, my bond will break because they'll be busy, and with some students will stay connected. So our bond will be strong. So like this, soluble salts are also bonded with the water molecule. When you supply energy, firstly, energy is required to break the bond between salt and water, and then only the vaporization of that water will take place. So that's the reason when soluble salts are there, the rate of evaporation will be low, because additional energy is required for first breaking the bond. Okay, so rate of evaporation like for oceans is less as compared to that of rivers. How much? 2 to 3% we call it. Okay, now depth of water body. Generally, we talk it, but we should talk it in detail. In summers, generally we talk it in terms of seasons. But if it's not given and it is talking about depth of water body, so you can say for shallow depth, rate of evaporation is more. For you can say larger depth, you can say the rate of evaporation is less. But if they specify summer more in winters, okay, but if the season is also given and depth is also given, like summer season is there, this is the depth and this is the, what you can see in summer season, all the water will be hotter, but here the large depth of water, here it will be hotter, while this portion will be colder. So you can say in summer season, shallow depth of water will be having more rate of evaporation. Correct? In winter season, this hole will become colder, while during the summer season large depth of water has stored some amount of energy. So what will be here? It will be colder and here it will be hotter. So you will see that in winter season evaporation will be more for large depth of water. Colder, deeper, more evaporation. Correct. Surface area, more the surface area, and this you know. Okay, fine. Who said Ursulan? Somebody said na, that they drink green tea. I assume everybody drinks milk. So what happens, guys? Everybody have done it. What happens when you drink it in glass? It is what, it's very much hot, warm. But when you take a plate or when you take a saucer and what you spread it, what happens? Eventually, it becomes what? Cool. What is this? You have increased the surface area. So when you increase the surface area, the rate of evaporation will increase. Okay. Now, how do we do the measurement of evaporation? More evaporation, more surface area. Absolutely correct, Ashish. Now, how do we do with the evaporation? We use the data, or basically we use pans. Okay, evaporimeters are basically what? They're pans, and basically we have all the calibrations done to it. So how much water is lost from that pan will tell me how much water is evaporated from the lakes. Okay, pan evaporimeters. Correct. So generally we have Class A, ISI standard pan, Colorado sunken pen, US Geological Survey pan. Okay, out of this, I'll tell you that remember the one Class A and ISI are almost same. Only difference is in the dimensions. And moreover, in ISI standard pan, we have provided a hexagonal wire netting also. Okay, so the one which I'm telling you is that remember the value of pan coefficient. Why? Because obviously how much evaporation is taking place from the pan, same amount of evaporation will not be taking place from the lake. Okay, because obviously there is a difference in the surface area, difference in the depth. So that is the reason you have to multiply with the pan coefficient. So there are various values, but remember the average values. This is important. Okay, because don't expect that they will give, if they are writing ISI pan, they assume that you should know at least the pan coefficient values. So at least this values you should remember. Okay, and there's questions like this statement as are been asked. For same amount of evaporation, ISI pan gives more evaporation as compared to Class A pan. Okay, so that is the reason. If you know the pan coefficient, multiply. Let us suppose take 100. So you will get 80 mm, 100 mm is there. So you will get 80 mm for ISI and 70 mm for class A pan. So you can say, yes, that's true. ISI gives more value of evaporation as compared to class A pan. If they ask you like this. Okay, I guess these pan coefficients are correct. Yes or no? So, and this is the density. Haven't asked, but if they can ask you like I did for hydrometeorological one. Arid zones, one station for every 30,000 kilometers. Humid area, one station for every 50,000 kilometers. Cold regions, 1 lakh kilometers square. Also, if you will put one pan or one station for evaporimeters and all, that's more than sufficient. Prepared for UPSC. Ankur, that I'll tell you better later. Okay. Now you know that if you want to minimize the loss, either reduce the surface area, use mechanical covers, or certain chemicals are used. What are those chemicals? Come on, guys. I guess you know the values. Methyl alcohol, cetyl, sterile. What are the ones? Cetyl alcohol and sterile alcohol. 2 and 3. Correct. 2 and 3. Okay, and you can provide the balls also in that. What else can you do it here? Mechanical covers, surface area, all those things you can do it. Okay, just do this question. Don't look at the options. You yourself tell me the option, but try to do this question fast. The water is installed corresponding to Indian standards. That means it is talking about ISI pan is there. Surface area, everything it has talked about. It is asking me the anticipated loss from the reservoir. Technically, it is asking me lake evaporation. So this will be 0.8 times the pan evaporation. Pan evaporation. How much is the pan evaporation? 4 centimeter is the evaporation loss. It is asking me in meter cube in terms of volume. What is your doubt, Alek? Ma'am, compared to pan, lake has more surface area. The lake should be more evaporation, but it is less. Alek, you are just taking only surface area into account, beta. What about the size of the water body? What about the depth of it? You just only took surface area, but there are other factors also. Not the depth is there, the size is there. Okay. So 4 centimeter, 4 into 10 raised to power minus 2 meter. This is the loss, evaporation loss. And the area is 100 hectares. That is 100 into 10 raised to power 4 meter square. And this is meter. How much it is coming? 8 4s are 32. 3.2. This 2 will go 10 raised to power 4 meter cube. So 3.2, it comes under. Generally, you guys won't be able to see option number C. The option number C is 3 to 3.25 into 10 raised to power 4. So option C will be the correct one. I should go like this, then you will see it. 3 to 3.25. Okay? Right. This is a good question. Come on, guys. Solve it. This is a challenging question. Swapnil, Arun, everybody, guys, solve this. No, this is a simple one. There's one more question. Oh, it's not there. What? This is a simple question. I thought that question was there. Okay, this is a simple. This is evaporation plus water budget equation mixed. Evaporation and water budget equation mixed. Come on, guys, solve this question fast. I won't be doing it first. You will be the one who will be solving it. The plain area is given to you. Water level is observed to decline. Decline means what? It is telling you that the storage is negative, delta S minus 20 centimeter. During that period, the reservoir receives an inflow of 10 hectometer. Fine. 20 hectometer is taken out. Okay. Pan evaporation and rainfall data is given to you. So we can calculate the lake evaporation from it. 0.7 into 12. So it will become how much? 8.4 centimeter. What else? Precipitation is given to me 3 centimeter. It is asking me the seepage loss, and that too in hectometer. So it's better to convert everything in hectometer. Okay, fine. No issues, Arun. You can do that. Inflow minus outflow is equal to change in storage. But if you have doubts, Arun, ask. Okay. Inflow is 10 hectometer. Precipitation, it is given 3 centimeter. Centimeter converted into meters. But I want it in hectometer. So this will be in meter and 1 kilometer square. Do you know the relation? 1 kilometer square is how many hectares? Is it correct? Is it correct? You know 1 hectare is equal to 10 raised to power 4 meter square. And you know meter is equal to 10 raised to power minus 3 whole square. So this will come out to be minus 2. Correct? Now understood? 1 hectare, 1 kilometer square is equal to 100 hectares. So you can just multiply it by 100. So you will get hectare meter. Then these are the inflow. Outflow is how much? Outflow is 20 hectare meter and 8.4 centimeter. Centimeter converted into meters and convert and multiply by hectare meter. Seepage is another an outflow. Change in storage, which is given minus 20. 20 into 10 raised to power minus 2 and again hectare. So everywhere you will be getting hectare meter. So when you solve this, how much you will get? You will get 2.4 hectometer. Okay. So concept of water budget and those. That's why I didn't do the water budget because it was used here. So you can see since the word decline, where it is written decline. So you know that the delta S will be negative. So they won't write directly. They will give you some sort of hints. Now, what is this equation known as Mayer's formula? Mayer's formula, this has been asked in your GATE examination. Empirical value. Okay, so here Km is its value is for shallow water body, deep water body given to you in the question. EW or EA saturation vapor pressure in mm of mercury. EA actual vapor pressure and V9 is the monthly velocity, mean velocity from the ground level 9 meter upwards, whatsoever is the value, that will be the VU9, or some books you will find they have written V9. Okay, so generally one thing only which they only do is they don't give you the wind velocity at 9 meter. They give you at 1 meter, 2 meter. So there is a relation 1 by 7th power law. So if you want to calculate wind velocity at any height, that is CH to the power 1 by 7. Okay. So guys, solve this question for me. Come on. Estimate the daily evaporation from the lake using Mayer's formula. Come on, solve this. I'm not going to do it. You will be the one who will be doing it. Fast. Fast. Saturation vapor pressure, actual vapor pressure, everything is given to you. 0.02. Calculate the wind velocity. Calculate the wind velocity fast. wind velocity UHCH to the power 1 by 7 at 1 meter. Wind velocity 16. Calculate and tell me. Calculate and tell me. 21.89. Km value is not given. You can take 0.36 or you can take 0.5. So let's take Km value as 0.36. Take it 0.36. 21.89. Come on. Calculate and tell me. Fast. 0.36 for large deep water, 0.56 for shallow water. 8.97. Is it? Everybody is getting this only? 8.97? 96897. Correct. Very good, Alik. Okay. So this is one more thing. This you'll be starting it in irrigation also. Apart from Mayer's method, there's another one which is, but this is based on evapotranspiration. So this is by Blaney Cradle method. We have to calculate evapotranspiration. First, let me tell you this evapotranspiration. Then we'll talk about it. What happens? Generally, you know that transpiration occurs during daytime. 95% of the transpiration takes place during daytime, but evaporation takes place throughout the day. That is for 24 hours. So what happens if the plant or the tree is in ground? Nearby to it, evaporation will be taking place and transpiration will be taking place to the plant. If the plant is in water, so the transpiration will be taking place to the plant, and nearby to it, the evaporation will be taking place from the rivers and all wherever the plant is there. So we clubbed it together and we call it as evapotranspiration. The amount of water required by the plants for the evaporation as well as for the transpiration, it is known as evapotranspiration. I'm telling it here. I won't tell you this in irrigation then. Okay, so listen to it. Evapotranspiration. Generally, you call evapotranspiration and consumptive use as the same. But if in the MSQ questions it comes and they write that consumptive use is evapotranspiration plus amount of water required by plant for building up new plant tissues. So that will be the consumptive use. However, the amount of water required by plant for building up new plant tissues is very less. So for calculation purpose, you assume that consumptive use and evapotranspiration is same. However, there is a slight difference between them. Okay. Now consumptive use, or you can call it as, there are two evapotranspiration. One is actual evapotranspiration. These are the official denotions. Don't expect that they will give you the full form of it. Actual evapotranspiration, potential evapotranspiration. Potential evapotranspiration, when sufficient moisture, how much is required, that much amount of water or moisture is available during that time. What is the evapotranspiration? That is known as potential evapotranspiration. It depends only on the climatic factors. While actual evapotranspiration, the amount of water used by plants for evaporation as well as transpiration based on the existing moisture conditions, that is known as actual evapotranspiration. Now, if you go by empirical methods, empirical formulas, they calculate only potential evapotranspiration. While if you want to calculate actual evapotranspiration, there is a device which is known as lysimeter. With the help of lysimeter, you can calculate actual evapotranspiration. If you want to calculate potential evapotranspiration or consumptive use, you can go by Blaney-Cradle method. Okay, what is the formula? You know that 2.54 temperature, you have to substitute it in degree Fahrenheit. Now 2.5400 crop consumptive use coefficient is given to you as 0.7 and percentage of sunshine hours. Let me tell you one thing. In the examination, you should know that this percentage sunshine hours depends upon latitude. So it might be possible for confusing you guys, they will write the latitude also. So based on the latitude, see how much percentage sunshine hours is there. Okay. And 100 is there already. Temperature, if you want to convert it into degree Fahrenheit, 1.8 T degree Celsius plus 32. How much it is coming? 1.8 temperature 12 plus 32. How much it is coming? So this 53.6 degree Fahrenheit. So 53.6. How much it is coming? Solve this. This is coming first for, it will come in centimeter per month. If you solve this first, it will come in centimeter per month. Is it? Month. Just check it out. Just check it out the calculation. So centimeter needs to convert it in month. November it is 30 days. How much it is coming? 686 it is coming. Or what? I don't know. You haven't divided by 100 or what? 0.7. 6.86 into 10 divided by 30. 2.28. 7. 287. Okay. 2.287. It should be actually 2.28. It's written 2.89. Is it coming this only? Around about to that, no? This is the option. Okay. So this is done. Now talking about infiltration. Shall we start infiltration now? Ready everybody? Infiltration. Okay. So now infiltration is what? Infiltration is what? When the rainfall takes place, when the precipitation occurs, you can see precipitation is occurring. Vertical movement of water into the soil is termed as infiltration. PT is Girish, potential evapotranspiration, the amount of water required by plants for meeting the needs of evaporation as well as transpiration under sufficient moisture conditions. It depends upon climatic factors. Okay. Now, infiltration, I told you, it is the vertical movement of water into the soil, Now, in this infiltration, we have two things. One is infiltration capacity. And F is the actual rate of infiltration. So, infiltration capacity is the maximum rate at which water will enter. Basically, after that, that's the maximum. Above it, there is nothing. Okay, so maximum rate at which water enters into the soil surface, that is the infiltration capacity. Now tell me, if intensity of rainfall, I is the intensity of rainfall. So if intensity of rainfall is less than the infiltration capacity, what will be the actual rate of infiltration? What will be the actual rate of infiltration? That will be equal to intensity of rainfall, because whatsoever water is coming, that will infiltrate. So if intensity of rainfall is less, so whatsoever water is coming, it will clear. Now, if intensity of rainfall is greater than the infiltration capacity, then actual rate of infiltration will be what? Whatsoever water is coming, out of that, the maximum water which can be infiltrated will go, and the rest amount of water will become runoff. So remember, if they ask you in which condition you get runoff, only when intensity of rainfall is more than the infiltration capacity. In that condition only you get the runoff. Now coming next, as I already told you, vertical movement of water into the ground. Now you know that if you go by Horton's curve, you know that very well. Initially, the infiltration capacity is very high if the soil is dry. Initially, when you guys already know that initially when the rainfall occurs, you are like, shit, man, what rainfall occurred, but you cannot see it anywhere on the ground. And the best example, guys, when large rainfall takes place, you are like, kal school nahi jana padega in your school time. But in the morning, you can't see it on the streets. And in the night, you're like, today rainfall is there, tomorrow the school will be closed. But when you wake up in the morning, khatam, tata, bye bye. No amount of water you can see it on the streets. So that's one of the reason that after a certain time, constant rate of infiltration is there. Okay. And the second thing is it drains also. Okay. Infiltration takes place, drainage takes place, every condition is responsible. So after a certain time, it never becomes zero. It will become constant. So this is F naught, initial rate of infiltration at T is equal to T naught, and FC is the final infiltration rate. Okay. Remember Horton's curve, because based on this question has been asked, is applied only when intensity of rainfall is greater than or equal to the come on guys, faster, infiltration capacity. Only in this condition. So what's it? Tell me. F naught or FC? F naught or FC? Come on, Swapnil, everybody. This is FP. This is FC. Final plus initial minus final. Actually, many students get confused. That's why I asked this. Okay. So this is the formula. If you want to calculate the cumulative, just integrate it. Just integrate this. But make sure that intensity of rainfall should be greater than the infiltration capacity. Then only you can apply Horton's curve. That's it. Okay. So solve this question. I know one mistake you will do. First you calculate, then I'll tell you the mistake. In this question, it has directly given me the infiltration equation. It has also given me that the rainfall intensity is greater than the infiltration rate. I have to calculate average infiltration rate for first 3 hours. Come on guys. Calculate it. Fast. Fast, I want fast. Is this the answer? Just tell me. See, calculation is not important for me. I want you to know the concept right now. Will this be the answer, whatsoever you are getting from here? Yes or no? Yes or no? I want the answer. 8 points. Very good, Lisa. Very good. Lisa answered correctly. Average word is written. Very good, Swapnil and all. You have to divide by 3. Because 3 hours it is there and average is given. Very good. So 1 by 3 will be there. How much it is coming? 8.67 centimeter. This will be the value. Yes. Very good, Girish. Come on, guys. In this question, it has not given me F naught FC. Just by looking it, can you tell me what is F naught and what is FC? I don't want the answer right now. Just tell me. What is F naught and FC? Because it's not necessary na, that every time they will spoon feed you. What is F naught and what is FC? F naught initial at t is equal to 0. I told you from the graph also. Okay, and FC is when constant rate of infiltration is there. So F naught, where is this? Very good, Divyanshu. Devanshu. 2. This is 0.4. So now solve it. 2 minus 0.4 e to the power minus 40. So 2 plus 1.6 e to the power minus 40. Now it is asking total infiltration capacity for the 8 hours. Simple. Now you can calculate and tell me. I don't have the answer with me. 2. Now you should be so pro that you don't need to do it every time. You can just directly substitute the limits. Get the infiltration capacity in centimeter. How much it is coming? How much it is coming? Oh, it was hidden or what? No, but you can see this. Solve this and tell me. Eight to some. Where's my calculator? 8 to the 16 plus 1.6 minus 4. 16.4. Correct. Correct, Anand. Very good. Girish, good. Okay. Last question, I guess. No, two questions are there. Solve this question first. Horton's curve, it is given to me. Rainfall intensity is given to me. Calculate the effective rainfall depth. See, when such question comes, now listen to me very carefully. When such question comes and nowhere it is written that intensity of rainfall is greater than the infiltration rate, because in the previous question it was written but here it is not written. So first you have to check it out that from where you can apply Horton's curve. Okay, so now this is given. Now what I'll do, at t is equal to 0, if I do, what is the infiltration? I will get it 6.8, 8.7, 7, 7, 14, 15.5. So what is happening? This is the infiltration I am getting. Okay. And the rainfall intensity is 10 mm per hour. Can I apply Horton's equation there? No. I can apply Horton's equation here because it is 20 mm of rainfall is taking place. But I should know at what instant of time, when this graph was there, at what instant of time, that is gone, at t is equal to 0. What is happening here? Just a minute. At t is equal to 0, infiltration will be 6.8 plus 8.7. This will be 15.5 mm per hour. Okay. Now what is happening? Only at 20. So I should know that at what time intensity of rainfall will be more than the infiltration capacity. So what I'll do, I'll check it 6.8 plus 8.7. I know that firstly it won't be valid because whatsoever rainfall is happening that will infiltrate. So I cannot apply Horton's equation there. So this is in mm per hour and let us check it for when the rainfall is 20 mm per hour. At what time the intensity of rainfall will become more than the infiltration capacity. So 20 minus 6.8 divided by 8.7, it becomes out to be how much? 1.517, and this is e to the power minus t. So when you want it minus t, log e base e will be 1, log e 1.517. Anything? 8.7. How much it is coming time? How much it is coming time? Guys, have you calculated it? Calculator. Oh. If you check it for 20, the time will come out to be 0.416 hours, which will be wrong. Why? Now let me tell you one thing. See, at 10, whatsoever water was there, that was infiltrating. So I want to know after 1 hour, or basically after that 10 mm, at what time I will see that the intensity of rainfall will be more. So don't do 20 here. Okay. 6.8 plus 8.7 e to the power minus t is equal to 10. This you have to do it. Correct. So when you will solve it, 10 minus 6.8, 10 minus 6.8 divided by 8.7, it will come out to be 0.367. If you take log answer, t will come out to be 1. Minus and minus will get cancelled out. Can we do it like by putting 0, 1, 2 and we can draw graph and yes, you can do that way also. But it takes time, beta. But if you want, you can do it. So this is 0, 1, 2, 3. So you know exactly at t is equal to 1 hour, whatsoever rainfall you are having, that will be more than the infiltration rate. Okay. So infiltration will come out to be how much now? Infiltration will come out to be how much now? 10 mm per hour. This rainfall is happening for 1 hour. This will infiltrate, plus from 1 hour till 3 hours, you can apply Horton's equation. Tell me the answer. Integrate and tell me the answer fast. Fast. Integrate and tell me the answer. I will add slide by that time. Have you guys, you are telling me the final answer? Arun? Infiltration will be how much it is there? 6.8 plus 8.7. This will be the infiltration. But it is not asking me in the question infiltration. It is asking me the effective rainfall. So the effective rainfall will be, by the time calculate total, very good, 2.367. So the effective rainfall will be total rainfall minus infiltration. Total rainfall is how much? 10 mm per hour, 20 mm, 10 mm of rainfall is happening for 1 hour, 20 mm is happening for 1 hour, again 10 mm is happening for 1 hour. So total rainfall is 40 mm. Out of 40 mm, 26.367 is infiltrating. Infiltration done by calculator. Okay. It's coming 13.64 mm. This is the effective rainfall. Okay, calculations, you guys can check it out. I told you the concept. Okay, now this last question regarding infiltration. The infiltration capacity of a soil follows the Horton's exponential model. It is given to you. Final infiltration capacity. Initial is given to you first of all 200 mm per hour, and after a long time it was reduced to 25 mm per hour. So the infiltration capacity after 1 hour it is given to you. So calculate the decay constant. Come on guys, simple question. FC 90 25. 200 minus 25 is 175 e to the power minus kh. From here you can calculate kh. How much it is coming? 90 minus 25 divided by 175. 0.99 it will come. Just take in the log of it then. Okay. So this will be the Horton's. You can guys can check it out also. This will be the Horton's decay constant. Okay. Now 0.99. Okay. Now hydrograph, you already know hydrograph is basically the representation of rainfall intensity. Rainfall intensity can mean mm per hour, can mean centimeter per hour with respect to time. Now the next important one is the infiltration indices. See, I don't want to know that at 1 hour what was the infiltration, at 2 hours what was the infiltration. I want to know the average infiltration. Okay, what is the average infiltration? Now, first of all, let me talk about W index. W index you don't have to do. That's the average infiltration rate over the entire storm period. Okay, average infiltration rate over the entire storm period. Now what happens? What happens? Very important thing. Generally, there are two types of losses. Two types of initial losses there. One is interception and the other one is depression. Okay. Interception and depression storage are initial loss. But W index told that I won't take W index told that I won't take initial losses with me. So whenever you calculate W index, however, till now in the numericals, they never give you initial loss. But if you mathematically write the expression, total precipitation minus runoff, this gives you the infiltration. But W index told initial losses like the water which gets stuck in the trees or in the rooftops, that is interception. You subtract that also. So there will be initial loss divided by the duration of entire storm. So precipitation P, runoff R and delta L are the initial losses. Remember, W index does not consider initial losses with it, while phi index considers initial losses. Now, why does phi index consider? Because beta, it's not possible practically to calculate how much interception or depression storage has taken place. That is the reason what phi index consider initial losses also as infiltration losses. So, losses are considered. That is the reason, that's also one of the reasons that the value of phi index comes out to be more than or equal to W index. Now, phi index told that I will take only those infiltration value. Phi index told that I will take only those infiltration value when the rainfall volume is more than the runoff volume. Or basically you can say I will consider only that infiltration during the time of rainfall which produces runoff. So that rainfall which produces runoff, I will take infiltration corresponding to it. Okay, so that's the reason this is phi index. Phi index more than W index because losses are considered as infiltration in phi index. So if you take phi index, it is basically PE minus R divided by T. that precipitation, that rainfall only which will be taken, which will produce runoff. Precipitation which produces runoff. Or you can call it as rainfall excess, or you can call it as effective rainfall. All the meaning are same. Excess rainfall, rainfall excess, effective rainfall, that rainfall which produces runoff. So precipitation which produces runoff, and TE is that duration where you are getting this runoff. So the duration of rainfall excess. Okay, this is the phi index. Only those precipitation which will produce runoff. Those precipitation which will infiltrate entirely and which will not produce runoff, that infiltration will not be taken into account. Okay, so guys, come on, solve this question of phi index. See, whenever such sort of questions are there, remember, and they're asking you phi index. First, you have to calculate W index, then you will be able to calculate phi index. So, since remember, firstly, 0.5 centimeter, 2.8 centimeter, 1.6 centimeter, it is occurring, but every 2 hours. So, when you will calculate W index will be infiltration over the entire storm period, total precipitation 0.5, 2.8, 1.6. Runoff is 3.2 and duration is 6 hours. How much we are getting? How much we are getting, guys? Calculate and tell me fast. Point 0.2833. Okay. So 0.2833 centimeter per hour. But if I want to compare which rainfall I should take or which rainfall I shouldn't, this is given for me for 2 hours. 0.5 centimeter is the intensity for 2 hours. So for 1 hour, if 0.2833 is the W index, for 2 hours, how much it will be there? For 2 hours, how much it will be there? 0.2833 into 2. So it comes out to be around 0.566 it will be there. 5666 centimeter in W index infiltration rate will be there for 2 hours. Now you can see that which one, this one will produce runoff. Why? Because it is more than 0.566. This one will produce runoff, but 0.5 will not produce runoff. This rainfall will not produce runoff. So when I will calculate phi index, I will not take that runoff. Because already told I will take only that rainfall which will produce runoff. So 2.8 plus 1.6 minus 3.2. And out of 6 hours, 2 hours will not produce runoff. So 4 hours. How much it will come? How much it will come? 0.3 centimeter. Okay. Go to the next question. It is asking me average infiltration rate. What is given to me? Volume is given to me. Okay, intensity of rainfall is given to me. The total runoff volume is given to me in terms of volume. First, I will calculate in terms of depth. So, runoff depth will come out to be how much? Depth 25.2 into 10 raised to power 6 meter cube, 320 kilometer square. That is 10 raised to power 6 meter square. Convert it into centimeter. This will give you the runoff depth. What else is given to me? Rainfall is given to me 3.2 centimeter. So for 4 hours it will become how much? 4, 8, 4, 3 is 12. This will be the. So how much you are getting? 25.2 divided by 320 into 100. 7.875. Correct. 7.875. So if you want to calculate average infiltration rate, not specified phi index, W index not needed also because no initial losses, nothing is mentioned. So it will be precipitation minus runoff divided by the duration. .23 centimeter. See, C 1.23 centimeter. Correct. Now, this two are the last questions. Okay. This question, you should know it. Very good question. Why? Because in this question, it has given us the accumulated rainfall. But whenever you want to calculate W index or phi index, you need to know the incremental rainfall. So in the question, it has given me accumulated rainfall. So first calculate the incremental rainfall. Come on guys, do this. Faster, faster, faster. Calculate the whenever, if they write accumulated or they write cumulative, whatsoever you write, first you have to calculate what? You have to calculate the incremental rainfall. Fastly, fastly. Done? Tea pillow, ma'am. This is my New Year resolution that I have left tea. Now let's see from how much time I'll leave. But this is my New Year resolution. Time from start. How much it is? 0 to 14. 0, 2, 4, 6, 8, 10, 12, 14. So this is the time. And rainfall 0, 6. 17 minus 6. Tell me the values of 57 minus 17. 70 minus 57. 81 minus 57. 87 minus 81. 90 minus 87. Come on guys. How much it will come? 3, 11, 40, 70, 57, 30, 81, 57, 24, 6, 3. So these are the incremental rainfall you got. Incremental rainfall. So first in the question it is asking you to calculate phi index, but first you have to calculate W index. First you also have to calculate the runoff because runoff is given in terms of volume. So guys, let's be quick. 12.1.2. 10 raised to power 6 meter cube. 30 kilometer square, 10 raised to power 6 meter square. Meter converted into mm. 1000 mm. 81 minus 70. I did what? Okay, 81 minus 70. Correct, correct. 81 minus 70. 11. Correct. Very good, Girish. Runoff depth, calculate mm. 40 mm. Okay. Now, first calculate W index. W index, average infiltration over the entire storm period. See, total precipitation, if you calculate also, you will get 90. Check it out once. If I made mistake there, Girish, I could have checked it. All these incremental rainfall, I would have got 90. Just check it, huh? And runoff, I'm getting 40 and the duration is 40. Calculate. .57 mm per hour. Now, when I will calculate phi index, this is for again for 1 hour. But it is given what? For 2 hours. So, for 2 hours, how much it will be? 3.57 into 3.57 into 2. 7.14 mm per mm of infiltration will be there for 2 hours. So, I will take only those rainfall which will have rainfall more than 7.41, which is not there. Let me cancel this. I'll cancel. This I'll cancel. This I'll cancel. This I'll cancel. Okay. So, what will be there? Those precipitation which produces runoff divided by T. So, which one I'll be taking? 11, 40, 13, 11. Correct? Just check the calculations, the concept I am teaching you. 2, 3, 4. Runoff is 40. 2 hours, 4 hours, 6 hours, 8 hours. Okay. From here, you will get the value in mm per hour. How much you are getting the value? 4.375 mm per hour. Correct. Okay. Last question. In this question, phi index is given to me. First, you can calculate the easy one. Total rainfall, you can calculate total rainfall. If it is hidden from my head, firstly, it is asking net runoff, and the second one, it is asking total rainfall. Total rainfall is very easy. Just add all of them. 2.5, 2.5, 10, 7.5, 1.25, 1.25, 5. This is the total rainfall in centimeter per hour. But these rainfall is happening for 20 minutes each. So 20 by 60 hours. From here you will get the total rainfall. How much it is coming? Calculate. Net runoff. Net runoff or rainfall excess, that runoff which is produced, that rainfall which produces runoff. So net runoff. It should write only runoff also. That's understood. So if 3.2 centimeter per hour of phi index is there, infiltration is there, 2.5 will not contribute. 2.5 will not contribute. Okay, this will not contribute because this will infiltrate. 1.25 will infiltrate. What else will infiltrate? 1.2. So you can calculate net runoff by two methods. 10 it is coming. Two methods. You can either do 10 centimeter per hour of rainfall was happening. 3.2 centimeter per hour of infiltration. Plus 7.5 was the rainfall happening. 3.2 is the infiltration. 5 centimeter per hour of rainfall was happening. 3.2 is the infiltration. Centimeter per hour, just every is 20 minutes duration. 20 by 60. Calculate. Either this way or you can go by the formula method also. Formula. Phi index is 3.2. 10, 7.5, 5. Runoff you have to calculate and the duration is 20 by 60, 20 by 60, 20 by 60. So if you are comfortable with the formula one, you can go by this method. If you want to go by the logical method, this is the logical. Tell me how much it is coming. I guess from both the ones you can calculate, you will get the same answer. 1 hour. 10, 7.5. 19.3, is it coming? Just check it out. I calculated from this one. From both you should get the same answer. Okay. Fine. So this completes only the simple formulas which you should know. That if you want to, from here we'll get the this one. No, we are talking about. Okay. So the formula for peak discharge, if they ask you ever, so the peak discharge and all. So if they ask you, you should know A is the catchment area. In this formula, the catchment area is in hectares or kilometers square. K is the runoff coefficient, which is runoff by rainfall. PC is the critical rainfall intensity in centimeter per hour. What is catchment area? Catchment area will be very good. It will be in hectares. Why I asked you know why? Because rational formula catchment area is in hectares. But when you see the empirical formulas, there the catchment area is in kilometers square. So Dickens formula CD a to the power 3 by 4 Rives a to the power 2 by 3 and English formula 123 root a. Okay, in all these catchment area is in kilometers square and the peak discharge will be in meter cube per second. So if they ask you the northern and central parts, go for Dickens formulas and southern parts Rice formula, eastern Ghats and all English formula. They'll mention which formula to use. Kilometer square. Remember, if you forget 3 by 4 is there or 2 by 3 is there, if you add 3 plus 4, 7. 7 is the alphabets for Dickens. 2 plus 3, 5. 5 is the alphabets for rhymes. Okay. So that's it. Now moving towards probability. Ready everybody? 2 chapters, that is probability and then hydrograph. That's it. Okay. When in the question they ask you, they give you so many discharges and they ask you to calculate the probability for 30 meter cube per second of discharge by California method and all. So what you have to do here, first arrange the discharges in decreasing order. So the highest value at the first, highest one is what? 50, then 30, then 20, 15, 12, 10. Okay. Now the number discharge formula. Now you will give them the numbering. This is order 1, 2, 3, 4, 5, 6. N is the number of events, which is 6. And this will be for 50 meter cube per second. M is the odd. So now you have to remember this. Either remember probability formula or remember the recurrence interval. Recurrence interval or return period, what you call, is the time during which, what you call it, return period, time interval during which the given storm is likely to be equaled or exceeded. If I say that the return period for 10 meter cube per second of discharge is 10 years, that means in 10 years, there might be an year where you will get 10 meter cube per second of discharge or more than that. It's not that only on 10th year it can happen. It will happen, it might happen on the first very year, second very year. So that is the meaning of recurrence interval. Okay. The time interval during which the given storm is likely to be equal, या तो उतना ही or exceeded, या उससे ज़्यादा हो सकता है. It might be on the very first year, second year, third year. It can happen on any year. Okay. So now probability is the inverse of recurrence interval, or you can say the return period. Now if you see, there are various formula, California formula, Weibull's method, US Cobb's method. So they have given the formula. So let's remember any one thing. Remember a recurrence interval, opposite will be the probability. You can do that. Okay. So P is equal to N by M. Let me do by this. Okay. So from here N will be 6 by 1. Here it will be 6 by 2, 3. 6 by 3, 2. 6 by 4, 1.5. 6 by 5, 6 by 6, that is 1. So probability will just be the reverse. 1 by 3, 1 by 2, 1 upon 1.5, 1 upon 5 by 6 is 1.2, no? Let's check it out. 1.2, correct. 1.2, this is 1, that is 100%. So you should know, lesser the discharge, more is the probability. Okay, because you know that much amount, 10 meter cube per second of discharge will come every time. Okay, so there is 100% probability but that discharge will come. So more the discharge, lesser the probability, lesser the discharge, more is the probability. Clear, Sachin? Sachin was the one who was asking, na? Clear? So these formulas you need to remember. Coming next is the probability. Okay. Again, take white pen. Okay. The probability of any event occurring r times out of n successive years. So out of n years, the probability of occurring r times. This is what? NCR, P to the power r, Q to the power n minus r. P is किसी चीज की होने की संभावना. किसी चीज की होने की संभावना means what? Probability of occurrence. Occurrence of flood. So probability of occurrence. Q means किसी चीज की ना होने की संभावना. Failure. Or you can say probability of non-occurrence of an event. You know, किसी चीज की होने की संभावना plus ना होने की संभावना is equal to 1. Okay, probability of occurrence plus non-occurrence is equal to 1. So you can say Q is equal to 1 minus 2. Okay. Now binomial distribution, correct. Now first case which I say, if I say is the that the flood does not occur at all. Probability that, I'm writing it in simple words, probability that flood does not occur. If it is not occurring, doesn't occur at all. That means structure is reliable. If it is reliable, that means you call it as reliability. If it is not occurring, so NC is 0, P to the power 0, Q to the power N minus 0. If you solve it, you know now computation, I'm saying combination, N factorial, N minus R factorial, R factorial. So this will come out to be only Q to the power N. Or you can write it as 1 minus P to the power N. Or you can write it as this is the reliability. Okay, you can say that the structure is reliable. Okay. Number 2, special case 2, that the flood occurs at least once. At least once. फ्लड ऑकर्स एटलीस्ट मतलब कम से कम एक बार ऑकर करे, ज्यादा से ज्यादा तो कितनी बार भी ऑकर कर सकता है. सो मिनिमम इट शुड ऑकर वन एंड एट मोस्ट इट कैन ऑकर एनी टाइम, बट कम से कम एक बार तो होगा ही होगा. सो यू नो रिस्क प्लस रिलायबिलिटी इज इक्वल टू 1. So at least once it is asking, that means it is asking about risk. Risk means 1 minus किसी चीज की होने की ना होने की होता है 1. तो 1 minus reliability मतलब जब कभी ना हो उसको अगर 1 से माइनस कर दोगे तो बाकी बचे हुए टाइम flood will occur. So the remaining time flood will occur. Okay. So 1 minus reliability. This is the risk. This is the risk. Okay. Come on, guys. Now, if they ask you sometimes what is the safety factor, because you know now when the engineer makes the hydraulic structures, they basically takes the safety factor while designing. So the design value divided by the estimated value will give you the safety factor. And if you talk about the safety margin, that is the design value minus the estimated value. Okay. Now, come on guys, solve the question. The probability that a 100-year flood during 50-year life of the project will not occur at all. Not occur means what it is asking, reliability or risk? Right, RE for reliability, RI for risk. Not at all occur. Reliability. Clear? During a 50 years life. Reliability. Correct. 0.90. It is coming. I haven't done the calculations. You are telling me? Why you deleted? Is it wrong or what? 0.99 to the power 50. 0.605. You didn't do the power, Alek. 0.605. Power is also there. Okay. Now, probability a 10-year flood to occur at least once in the coming next 4 years. It can occur once, second, third, fourth, but at least once it should occur. So this time it will be risk. Risk will be 1 minus reliability. How much it is coming? 1 minus 9. 0.3439. 0.3439. So if you talk 34.39%, round about to 35%. Okay. This one you don't even need to calculate also. It is asking the risk. Risk 1 minus reliability. Reliability is Q to the power N. How many years? 50 years. 0.9950. So A will be the correct option. If it asks percentage, multiply by 100, Ashish, for the previous one. Okay? Simple questions. Okay. So then when we move towards theoretical probability method when the sample size is very high. Okay, so then we go for Gumbel's method. Gumbel's method, when it talks about the return period is 500 years, the return period is 1000 years, then we go for Gumbel's method. The formula for Gumbel's method is x bar plus kt sigma. In some books, instead of sigma, they write sigma n minus 1. No issues. K is the frequency factor, yt minus yn bar by Sn. Yt, all these formulas you have to remember. Okay, all these formulas you have to remember. And yn, when the sample size is very large, then the mean reduced variate value, generally they can ask you these values. It's not necessary that they will give this value. If they will say the sample size is very large and they will ask you to calculate the peak discharge for 400 meter cube, 400 years return period, 500 years return period. So that in that case, what you have to do, the reduced mean variate will be 0.77. The standard deviation of the reduced variate will be 1.2825. Okay, so these are the simple formulas you need to remember. And if in case, however, this is just the topic of ESE, they haven't asked, but since it is there in your syllabus of GATE, if they ask you, so the values, confidence limit is, let us suppose, as I always tell, generally it happens to boys, as we make fun, but that's the truth. Generally it happens to boys. You guys tell me, when the boys come and they tell that how was the paper, 50 से 70 तो आ जाएंगे. What they say, 50 to 70 तो आ ही जाएंगे पेपर में. So they give you a lower limit and they give us the upper limit. Generally girls don't see. Even if somebody asks us whether it is correct or not, Lisa, tell me. Even if girls, somebody asks that how was the paper, we are like, ठीक था, okay, we say like this. We never say it was outstanding. We never say like that. So what happens? Generally there is a confidence limit. Okay, there is a confidence limit. 50 से 70 आ जाएंगे. So that's the same. When you calculate discharge by Gumbel's method, whatsoever value which you are getting, so what is the confidence limit? What is the range of it? So that is the reason you can have two limits. One is the upper limit and another one is the lower limit. So xt, what you got from Gumbel's method, plus FSC SE. FC is the confidence probability. So for different percentage of confidence, you have the confidence probability. Okay, SE is the probable error. Most probably this chart will be given to you, so you don't have to worry. SE is the probable error. The formula is B sigma root n. Root n is the sample size, and B formula you have to again remember. This is totally, remember, empirical based. So you have to remember it. Yeah, that's true. We girls always do this. Even I did that same. Even you call me a night before the examination, I'll be like, oh my god, my preparation is not yet done. I'm so tensed. Every girl does that. I know that. Okay, this is that inherent features in girls. So this is B value. Substitute it, you will get the probable error. Okay, nothing more than that. Simple data-based questions are this. That's why I have not done. That's the just you can do it yourself also. If you have doubts, you can ask me. But that's the fact. Even only data-based questions are there. Okay. Generally, what they will do for 100 years, they will give you the peak discharge value for 100 years. T is equal to 100 years. They will give it. T is equal to 500 years. They will give it, and they will ask you for T is equal to 1000 years. So two equations, you will calculate x bar. Eventually x bar also they will give you, mean also they will give you. So you need to calculate what? Sigma n minus 1. Generally they ask you this. Okay, so you need to calculate sigma n minus 1 by Sn. Two equations are there, and x bar, if they don't give you, x bar also you have to calculate. Two equations, two unknowns. You can get x bar a sigma n minus 1 substituted here. That's it. If you want, like for 100 years, they have given. So x 100, x bar plus instead of kt, you will write yt minus yn bar sigma n minus 1 Sn. Okay. For 500 years, this value will be given, x bar plus yt minus yn sigma n minus 1 Sn. Yt, return period, you can calculate minus log 100 upon 100 minus 1. For this one, minus log 500 upon 500 minus 1. So Yt you will be given, Yn you will be given. So from two equations, two unknowns. X bar, sigma n minus 1 Sn you will calculate. And if it is asking for 1000 years of return period, what is the peak discharge? X bar you already know. Yt minus Yn sigma n minus 1 Sn. You know x bar, you know sigma n minus 1 Sn. Yt you can calculate 1000 minus 1. You will get the answer. Clear? So Gumbel's method, when you have what? When the large data size is there, then you use this. Okay? Now, coming to the hydrograph. Ready? Come on. Ready, everybody? Faster. Fine. So the last chapter, hydrograph. Hydrograph is the graph between discharge and time. Oh, Faria is also there today. Oh, hydrograph is the graph between discharge and time. You know that, simple. Now, why we need to plot it? Generally, see, whenever you are a field in charge, when you will go and you will see it, if they will give you the data, you're like, okay, this year, this month, this year, this month data, it becomes practically difficult to visualize. But if a graph is given to me, automatically, okay, fine, on this year, the value of rainfall was more, the discharge was more. So it becomes comparatively easier to analyze and to visualize. Okay, so we have different types of graphs. You have annual graphs, you have seasonal graphs, you have monthly hydrographs, you have n types of hydrographs. Now what happens is here we will be talking about the various parts of hydrographs, or you can say the components of hydrograph. So let's talk about it. You can see, since it is white, I will take red pen. AB portion. Okay, AB portion is the rising limb. AB portion is what? AB is the rising limb. Remember, these are the statement wise question. Rising limb depends upon the catchment characteristics. It depends upon the storm characteristics. Catchment and the storm characteristics. While the falling limb, this is the falling limb. Here the rainfall was occurring, it was rising. Here the falling limb depends only on the basin characteristics, or you call it as the catchment characteristics. Okay, now B and D are point of inflection. Like you would have studied it in SOM. When you talk about inflection, the point where the curvature changes from convex to concave or concave to convex. So B and D are the point of inflection where you will see the curvature is changing. C is the point, or you can say the point of maximum discharge, or you can say the peak discharge. Okay. Next, if we talk about, this is the base flow, because it's the component of flood hydrograph is there. Then there are two things. Lag time. Lag time is the difference between the CG of rainfall, because here we mentioned the duration of rainfall. So the difference between duration of rainfall to the CG of the hydrograph. Now see, very important. In maximum of the cases, the CG of hydrograph and peak discharge is the same. That's why you call lag time as the difference or the distance between the centroid of the duration of rainfall to the peak discharge. But when the graph is unsymmetrical, during unsymmetrical case, it will not be the condition. So the actual definition is lag time is the time from the CG of the rainfall duration to the CG of the hydro. That is the lag time. Okay. Now, talking about what are the factors which affect hydrograph. What are the factors? Because these they can ask you in statement wise. So what are the factors which affect hydrograph? First is the shape of basin or the catchment. So if this is one of the catchment and here is the outlet, and if this is the catchment and this is the outlet. Okay. So in which case you will get peak discharge early? The first case or the second case? Tell me guys. First case or second case? In which one you will get it early? First case or second case? In which you will get peak discharge early in lesser time? Very good. Second case. Why? Because maximum rainfall is accumulated here. It will directly go to the outlet. So here and here it will be delayed. So the shape of the basin affects it. Not in the first. No, Lisa, no, Deepak. Why? Because maximum water is away from the outlet, so it takes times to reach to the outlet. That's why you will get the peak discharge, but after a certain interval of time. Here maximum discharge is close to the outlet, so you will get the discharge in a lesser time. Form factor. Compactness coefficient. You know form factor? Average width to the axial length. This is known as the form factor. So generally you know area is equal to width into length. So you write it as AL square. This is the form factor. Then compactness coefficient guys. Compactness coefficient. Okay. Before dealing compactness, let's talk about the simple one. Like let's talk about the stream density. What is stream density? What is drainage density? Come on guys, faster. At least I think you guys know this one. Stream density, drainage density. They can ask you this. That's why I'm asking you. Stream density, drainage density. Size of basin, that's simple. More is the size, more amount of rainfall will be coming, which will produce what? Runoff. So size, obviously. But if the size of the basin is more, so the base period will be more. Base period will become more. What about stream density? What about stream density? Just tell me that. And drainage density. Come on, guys. Number of streams per unit area. Very good. Devanshu. Stream density, number of streams per unit area. So, if the number of streams from where the water goes into the catchment area is more, so the peak discharge will be more. Drainage density is total channel length upon catchment area. So, if you have like more number of channels, and this is a lesser number of channels. So when more number of channels will be there, the peak discharge will be more for the first one and it will be less for the second one. Okay, simple. Now, effect of wind. What will be the effect of wind? Come on guys, faster, faster. Not everything I'll answer. You will be the one who will be also telling. Effect of wind. Fast. Effect of wind. Nobody, Deepak, Girish. And moreover, one more thing. If it is same, then it's okay. But if we are talking about different catchment areas, and even for the same catchment area, if the drainage length is less, that peak will also be different. If I want to draw it, depends if direction of wind, then early. That is the direction of storm, basically. See. First, let me tell you about this drainage density. For the first one, early peak, lesser time base. For the second one, delayed peak, more time base. This is QP1. This is QP2. Because they can ask you in statement wise. So, more the channel length, peak discharge early. And QP2, lesser the channel length, peak discharge will be delayed. Okay. Peak reduce. Correct. Now, wind effect will also be there. It will depend, correct. It will depend the direction also, as you said. Okay. Direction of storm. Direction of storm. Direction of storm, guys. Direction of storm. Tell me fast. These are the simple ones. Direction of storm. Like if this is the catchment area, if this is the outlet, and here the direction of storm and direction of outlet both are in the same direction, or the direction of rainfall and the direction of outlet both are in the same direction, you will get peak discharge early. Okay, you will get peak discharge early. But if they are in the opposite direction, if again same diagram will be there, but this time the direction of storm is in opposite direction, then you will get the peak delayed peak. Okay. Now, talking about intensity of rainfall. Intensity of rainfall, if intensity duration is same. See, when you compare things, you have to make other thing as constant. So, if duration is same and intensity of rainfall is more. For same duration, if rainfall intensity is more, peak discharge will be more. For same duration. Then in that case, peak will be more. Duration of rainfall, if for same intensity is same, but duration is more, so peak discharge will be, or basically you can say the length of the time base will be. Okay. Now talking about soil moisture condition, or you can say vegetation. If vegetation is there, what will happen? If vegetation is there, a part will infiltrate, or basically obstructions will be there. So more time will be taken by the water to reach to the outlet. And if more time is taken, or basically some amount of water can absorb also, basically the time base will increase. Okay. So I'll write it also for more vegetation. More time for water to reach the outlet. This all can be asked in statement wise. That's why I told you. Okay, any doubts? Anybody, Lisa, Arun, anybody, any doubts? Fast. Nobody, any doubts? Nobody. Fine. No doubts. Peak reduce. No doubts. Fine. Okay. What is compactness coefficient? You guys haven't told me. Compactness coefficient, guys. I'm not going to tell you. What is compactness coefficient? Is it this? I'm writing, I might write wrong also. Girish, everybody. Where it is gone. Compactness coefficient, perimeter of the basin divided by perimeter of the basin of Guys, you know or you don't know, this is the formula perimeter of that particular basin, and if same is the circular perimeter of catchment to the perimeter of equivalent circle. Very good. Perimeter made of the whatsoever is the perimeter, you are making the circle same. Circle shape. Correct. So the perimeter is A is equal to pi r square. Perimeter, you know it is 2 pi r. So you know the r from here will come A by pi. You will substitute the perimeter of the circular catchment A by pi. So from here it will come 2 root over A by pi. So perimeter of the basin to the perimeter of the circle. Okay. Got this. Fine. Lastly, we have simple things. You know this, right? Direct runoff hydrograph plus base flow gives you flood hydrograph. You know that. Okay. Flood hydrograph, that is the total runoff. That is the total runoff. Now, if you want to calculate direct runoff hydrograph, see there are two methods that depends upon you. Either plot at every point, subtract base flow, plot at every point. T1 the discharge is Q1, T2 the discharge is Q2, T3 the discharge is Q3, and so on. You should know that area under direct runoff hydrograph gives direct runoff volume. So either you calculate the area, you will get the volume, you divide by catchment area, that is direct runoff volume divided by the catchment area will give direct runoff depth. So either you do in this manner, or I'm telling you the simplest formula, but only one mistake you guys can do. N is equal to 0.36 sigma Qt by A. Remember, this come from this area calculation only. Maximum number of times they will give you the catchment area in kilometer square, discharge in meter cube per second, time in hours. And they will ask you the runoff depth in centimeter. Even if they ask you in mm, calculate here, get the answer in centimeter, multiply by 10. Okay. But one mistake which you guys do. Sigma Qt is area under the curve. Now, why you told this? Because beta, sometimes they will say trapezoidal. So you have to calculate area of trapezium. If they say triangular, you have to calculate the area of triangle. So this is area under. Okay, this you don't make mistake. Now, this is the question which is given to you. In this question, flood hydrograph is given to you and it is asking me direct runoff depth. It is asking me direct runoff depth. So flood hydrograph is given to me, base flow is given to me. First I will calculate direct runoff hydrograph. So guys, 14 minus 14 is 0, 25 minus 12, 13, 40, 55, 43, 15, 0. This is the direct runoff hydrograph values. It is asking me what direct runoff depth. So what I have to do? N is equal to 0.36 sigma Qt by A. Okay. 0.36 catchment area is already given to me in kilometers square. Discharge, just add the discharge, just check it out. Everywhere it should be 3 hours difference. 11, 11, 3, 3, 6, 7, 8. Otherwise you have to add individual. So what you will do, just plus the ordinates. 13, 40, 55. Calculations also check it, huh? Girish, everybody. And what is the time? Every time it is 3 hours. So directly you will get the answer in centimeter. Where it is gone? Some sort of jadoo is going on or what? Okay. What is the value? What is the value of direct runoff depth which we are getting? Anybody solve it? Or shall I solve it only? 13, 40, 5.976. Fine. So this will be the answer. Okay. Now, coming next to unit hydrograph. Very simple. Anything 1 unit. Basically, from flood hydrograph, you subtract base flow, you will get direct runoff hydrograph. Okay, this concept of unit hydrograph was given by whom? Mr. L.K. Sherman. Okay, so you should remember that. So what happens? You got direct runoff hydrograph. Unit hydrograph is also a direct runoff hydrograph only. The only difference is the value of rainfall excess, that is N, which you get is 1 centimeter, or you call it as 1 unit. That's it. That's why it comes under specific categorization, that is unit hydrograph. Ankit, missed session. You haven't, beta. I'll be starting irrigation. You can continue from here or you can join from irrigation. Okay. Now there are some things which you should know. There are two. There are many assumptions. Intensity is constant. This is constant. Unit hydrograph you can use when the area is greater than 2 kilometers square and less than 100 or less than 500 or 5,000 kilometers square. Come on, tell me. Unit hydrograph gives you good results, reliable results when area is less than 2 kilometers square, when area is more than 2 kilometers square and less than 500 or 5,000 kilometers square. Which one? Tell me fast. 5,000. Okay. Now, talking about two basic assumptions. Remember, time invariance, linear response. Time invariance we talk about. Let us suppose in the morning 6 a.m. to 8 a.m. rainfall happened and this was the hydrograph. In the same day rainfall happened from 3 p.m. to 5 p.m. So time invariance says the hydrograph which will be formed will be exactly same irrespective of the time of occurrence. Doesn't bother if it occurs from 3 to 5 or if it occurs from 9 to 11. No. The hydrograph will remain same as it is. However, you also know it's not necessary, but this is the assumption. If you won't take the assumption, you won't be able to solve questions. So this is 2 hours. Next, this is delayed 2 hours. Next is same graph. This is n is equal to 1 centimeter. This is again n is equal to 1 centimeter. So the graph is same irrespective of the time of occurrence. Linear responses. Let us suppose for 3 hours 1 centimeter is the rainfall excess. This is the graph. So if for 3 hours 2 centimeter, just multiply the ordinates by 2. That's the linear response. Okay, so if this is 3-hour unit hydrograph, since now it is N2, so it will become 3-hour direct runoff hydrograph with N is equal to 2 centimeter. Okay, so this is the time. First one was the time invariance and this one is the linear response. These two assumptions. Now simple. First you talk about uses of unit hydrograph. From unit hydrograph, you can calculate direct runoff hydrograph and you can calculate flood hydrograph. So things becomes very easy to calculate. Next coming, you can see it. 6 hour it is given to you and it is asking you 6 hours when n is equal to 1 centimeter and it is asking you duration is same but it is asking you n is equal to 3 centimeter. What you will do? Multiply by which assumption? Linear response. 0. 20 into 3, 60. 30 into 3, 90. 120, 90. 75, 0 meter cube per second. These are the discharge and if you want just add base flow. So simply you can solve this. One thing which I'll tell you, very important. Peak of unit hydrograph, this is used in maximum of the cases, is equal to peak of direct runoff hydrograph. This is in meter cube per second. This is in meter cube per second divided by rainfall excess in centimeter. Okay. So if any value they'll ask you peak, just divide by the rainfall axis. That's it. Peak of DRH divided by the rainfall axis. As simple as. Okay. Now if let us suppose 4-hour unit hydrograph or 2-hour unit hydrograph is given to you, and it is asking you to calculate 4-hour unit hydrograph. This is asked. So what is happening in this, you can write, or in this format, T is equal to ND. 4 hour it has asked and 2 hours it is given. N is equal to 2. When you get an integer value, okay, so here you can apply method of superposition. Here you can apply method of superposition. Now, example, 2 hour is given to you and it requires 4 hours unit hydrograph. So first 2 hours of rainfall will end, then another 2 hour of rainfall will start, then another 2 hours of rainfall will start. Okay, so when you add both of them, I'll draw it here. See, if let us suppose this is 2 hour of rainfall, this is the hydrograph, you want 4 hours, so lag it by another 2 hours, it will become what? 2 hours. So when you add both of them, this is n1 centimeter, this is n1 centimeter. When you will add both the ordinates, you will get 4 hours of direct runoff hydrograph. Why? Because 1 centimeter and 1 centimeter will make it what? 2 centimeter. So now when you will divide each of the ordinates by 2, you will get what? You will get 4 hour of unit hydrograph. So this will be 4 hour of unit hydrograph. So 4 hour of unit hydrograph will be what? 4 hour of direct runoff hydrograph divided by 2 by the concept of linear response. So you have divided the ordinates by 2. So you have got the unit hydrograph. Simple. So remember, you can use S-curve method also here, but it is always advisable whenever it is method of superposition. Whenever n is an integer, go by method of superposition. It becomes very easy and it becomes very handy. Okay. Now, talking about S-curve. But before that, let's do some questions. Too much of theory. Now let's start some questions. Come on, guys. This is a simple question. Don't look at the solutions. Tell me the catchment area. Don't look at the options. Tell me the catchment area. See, either you can use the conventional method or the formula which I told you. Now, some people do what? They take area of trapezium as 2 triangles and 1 rectangle. I just directly take the area of trapezium. Whenever unit is written, by default it is 1 centimeter. Sigma QT, remember area, half sum of parallel sides. Parallel sides is 28 and 4. And the distance between them is 24. Catchment area, just calculate. Directly you will get it. How much it is coming? How much it is coming catchment area, guys? 138.28, 138.24. Fine. So, but only remember sigma QT is the area under the curve. That's it. Now, tell me this question. A storm hydrograph due to 3-hour effective rainfall, it contains 6 centimeter of direct runoff. So that means it is a 3-hour direct runoff hydrograph with n is equal to 6 centimeter. The ordinates of direct runoff hydrograph of this storm. Come on, guys. What it will be? Are you guys don't able to see it? Okay, fine. Let me tell you. From 3-hour direct runoff hydrograph is there with n is equal to 6 centimeter. If you want to get a 3-hour unit hydrograph, what you have to do? If you want to get 3-hour direct runoff hydrograph is given to you. If you want to get 3-hour of unit hydrograph, what you have to do? Divide all the ordinates by 6 centimeter. So when divided by 6 gives the ordinate of 3-hour unit hydrograph. Okay, as simple as that. Okay. The basic assumptions of unit hydrograph theory, you already know it. Time invariance and linear response. Actually, in the examination, all options appear same. So that's the reason. Time invariance and linear response. Fine. So let's talk about this. Divide. Correct. So this is common database question. First question, it is very easy. What is given to you? A triangular unit hydrograph is given to us. 30 hours is the base time. Peak occurs at 10 hours. What is the value of peak is 60 meter cube per second. Okay. First you have to calculate the catchment area. This is very simple. N is equal to 0.36 sigma QT by A. So this is 1.36 area half base to height. Area. Calculate how much it is coming. 30 into 30. 324. 324 kilometers square is the area coming. Yes. Now the second part of it. Is the one which I wanted to tell you. If there is a rainfall of 5.4 centimeter, just one more thing. Sometimes you guys have confusion that you are not able to understand whether in the question it has asked you flood hydrograph or whether it has asked you direct runoff hydrograph, even though in the question it has not mentioned. So remember, if it is telling you rainfall axis or if it is giving you infiltration rate and moreover it has given you the base flow. So if in the question they haven't specified whether they want flood hydrograph or whether you want to calculate direct runoff hydrograph, but they are giving you the base flow, that means you have to calculate the flood hydrograph. Okay, so don't be in the confusion for that one. Now solve this. What it is there, the peak ordinate at the ordinate at 15th hour it is talking about. So this is the 10th hour and it is asking you the ordinate at 15th hour. So first of all, this is a unit hydrograph. So first you have to calculate the peak of unit hydrograph. The diagram is not symmetrical. So this is 15 hour. This is 15 hour. You can go for similar triangles. So if you go by similar triangles, can you calculate the peak and tell me? Here if it is 60, so the base is 20. Here the peak you have to calculate at 15th hour. So here it will be 15. How much is the peak coming? 2, this is 345 meter cube per second. 45 meter cube per second. Yes, it is the peak discharge for unit hydrograph. I already told you peak of unit hydrograph is equal to peak of direct runoff hydrograph divided by rainfall axis. So reverse also you can do if you want to calculate the peak of direct runoff hydrograph. It is peak of unit hydrograph into rainfall axis. 5.4 centimeter rainfall was happening. Out of this, 0.4 centimeter rainfall was infiltrating. This was happening for how many hours? 1 hour. So the rainfall axis will be 5 centimeter. And then what you will do? You will add base flow to it. How much it is? 50. So you will get the peak of unit hydrograph. How much you are getting? Plus 15. That is 240. Clear? Simple questions are there. Hydrograph, there is nothing much. Only just let me tell you about hydrograph. S-curve. S-curve, let me talk it about. When you talk about the second case, T is equal to ND. This is the last topic. Then we have irrigation. So T is equal to ND. When N is, you get like 3 by 4, you get rational numbers and all. Then you go for what? Then you go for S-curve method. What is S-curve? When you see that continuous, later suppose if you want to create S-curve for 2 hours. So what will happen? You will say 2 hours of rainfall is produced, then 2 hours of rainfall, then 2 hours of rainfall. When this goes on producing for an infinite period, and the summation of it will come out to be this, when you start to get a constant discharge. So this is known as the equilibrium discharge, or you can say the peak discharge, and this is known as, you see, the S curve is formed. So S curve is produced by constant and continuous rainfall for an infinite period. Okay, so what you have to do, if they are asking you to create an S curve for 3 hours, what you have to do? 3 hours, lag by 3 hours, lag by 3 hours, lag by 3 hours. You keep on lagging it by 3 hours, so that when you add them, you should get a constant discharge. And one more formula which they can ask you in 1 marks if they want. The formula for equilibrium discharge is 2.78 A by D. In some books they write 2.778 also. So if they ask you equilibrium discharge in meter cube per second, the duration is in hours, the catchment area is in kilometers square. So this is the formula for equilibrium discharge. Clear? Clear, guys? So you can use this method to calculate. Very simple as that. Next, yes or no, first tell me. Yeah. Now, let us suppose if 2 hours of unit hydrograph is given to you and 3 hours of unit hydrograph is asked. The one which is asked is capital T. The one which is given is D. Okay. So from here, what will the value of N come out to be? 3, 1.5. So here you can use S curve method. I'll tell you the procedure. First, for 2 hour unit hydrograph, you will construct an S curve. 2 hour, lag by 2 hours, lag by 2 hours. Go on doing it till you get a constant rate. Okay, you call it as SA. So you will plot it SA. Now, जो पूछा गया है, which is asked, उतने से आप इस S curve को lag करा दो. The one which is asked, lag by that amount. 3 hours से पूछा है, 3 hours से lag करा दो. And replicate कर दो same S curve. And call it as SP. Calculate the difference delta Y, which is equal to SA minus SP. Now, if you want to get the ordinates of 3 hour unit hydrograph, what you have to do? Delta Y divided by T by D or D by T? So multiply by बता दो. Have I written correctly? Come on guys, have I written correctly? Nobody is even responding also. Correctly. Where it has gone, yeah? It goes automatically what? D by T. D by T. T by D is here. Here multiply जो given है divided by जो पूछा गया है. Okay. Clear? What Girish, what you are saying, it will be delta Y T by D. If we do it like this, it will be here. But if you multiply, what is happening here? It will go on the top. So it will become D by T. Okay. जो given है divided by जो पूछा गया. Okay. Clear Girish? So with the help of this, you solve questions. Okay. So this completes your entire hydrology. Any doubts? Say, otherwise we'll start irrigation. Shall we start irrigation? Shall we start irrigation? Great. Fine. Too good with your energy. Let's start it. Break you want now? Lunch break. Everybody wants break? Why this life becomes still? Everybody wants break? Okay. So, lunch break. How much? For how many time? Means for how many minutes? Tell me the time also. Tell me the time at least. 15 minutes. What about others? Lisa, Devanshu, how much time? 1 hour 45. That will be too much. Um, 15. Okay, fine. Girish is telling. First, I will give a break till this time. Only when you promise me that that you will be coming back. First, promise me and go. Otherwise, then I'll stop. I won't be taking irrigation. Why will I take irrigation if you guys don't want to arrange? Uh, tell me. Promise me and go. Then only I'll give till 1:45. First, promise me faster, faster. Okay. Promise. Very bad at commitment engineers, is it? Fine. So actually, Ankit, some people have to go and take the lunch, no? So that's why we have to take care of everybody else also. Fine. So guys, you all can go. We'll meet at 1:45. Okay? Hello, Swapnil. Okay, guys, so join the session fast. Be fast in joining the session. So that we can start. Hello, Alec, everybody. Welcome back again. Had your lunch, everybody? Okay. So, I'm audible, visible, correct? Yeah, I also had my lunch. Okay. So, guys, we'll be starting irrigation. Good afternoon, Madasir. So, now let's start again. Okay. So, shall we start? Everybody back? Shall we start? Okay. Shall we, Swapnil, everybody? Okay. Other people, when they'll come, they'll join us. No issues regarding that. Okay. So, fine. So, let's be quick. Fine. So, now we'll be starting irrigation. Irrigation, we know irrigation is when we artificially apply water for a definite time throughout the entire growth period of the crop, or you can say till the crop attains its full maturity, that is known as irrigation. Now, first the question comes that why there is a need for applying water, why don't we depend only on the rainwater? So, you know that if you talk about Indian subcontinent, the climate, the temperature, so it's not that you get the rainfall every time, every year. It's not that mandatory also. That every year at this point you will get this amount of rainfall. No, it's not like that. Okay, so what happens? You have to artificially provide water. Why? Because obviously food you have it for all through the year. So for that food, for that crops has to be grown, and for the growth of that crops, water is required, and water will be provided by constructing canals, dams, so that from there water can be supplied to the fields, crops, then it will come to us also. Okay, so basically since you know that rainfall takes place for 3 to 4 months, obviously I know that because of global warming right now, rainfall happens in any month, but generalized if I talk about, the rainy season occurs for generally we take it from June to August, June, July, August, 3 months. So you cannot basically get dependent only on the 3 months for the growth of crops. So that is the reason artificially what you have to do, apply water. Now comes generally this few topics, like when you talk about mixed cropping, you guys know the meaning of mix, and you can see it from the images also. Like what is this? This is cabbage, cauliflowers. They are grown, and simultaneously other crops is also grown. So what happens when you're very much uncertain and when you're only dependent upon basically the rainfall? So what happens? Sometimes the rainfall will be good in a significant amount. Sometimes it won't be there. So what will happen? So to eliminate that, इससे better कि कुछ ना मिले से तो अच्छा है कुछ तो मिले. Instead of not getting anything, it's better to get something. So what you do is you do mixed cropping. Mixed cropping, you two or more crops, you just basically what you do, you just use it for the growth of crops. 2 or 3 crops are there. Okay, so you just sow the seeds in the farm so that कोई एक तो ग्रो करेगा. इट्स लाइक यू कैन से ना कोई कुछ ना कुछ तो ग्रो करेगा, ये नहीं तो ये नहीं तो ये. सो यू आर गिविंग दैट ऑप्शन, दिस और दिस विल ग्रो. So that is basically what is mixed cropping. But the thing is, there are certain drawbacks of it. The drawbacks are like you are not able to get the yield which is required. Yield is cultivation per unit area. so you're not able to get that yield also. Moreover, let us suppose you are dependent on a particular rainfall, and it's not possible also, okay, because you are not using any canal system, no artificial irrigation, you are just dependent upon rainfall. So that is the reason what you have done, 2 or 3 crops you have sown in the farm or in the field. But the problem is, since you are not getting a full yield, so this becomes a major drawback in the mixed cropping. Okay, it's better you can also go for crop rotations and all also. That also I'll tell you in the upcoming class only, or not in the upcoming class, in this class only. So now let's talk about the type of irrigation. Irrigation is broader of two types, surface and subsurface. Surface means when you apply water on the surface of the land. In surface irrigation, you have flow irrigation, lift irrigation. Flow irrigation means the water will flow under the action of gravity. You are not applying any pumps, nothing you are doing. Water is flowing under the action of gravity. Why water will flow under the action of gravity? When there is a difference in head. Okay, when sloping land is there, then only water will flow under the action of gravity. Lift irrigation, when you pump water with the help of pumps and all, then you go for lift irrigation. Now in flow irrigation, you have perennial irrigation and you have flood irrigation. Perennial means that the flow is taking place continuously throughout the year. Now in this perennial irrigation, what you have, either the river is there, from the river you are just diverting the flow of water. Okay, you are just constructing diversion headworks and you are diverting the flow of water. So that is direct irrigation you are doing. Secondly, what you can do is you can construct a dam, or what dams like structures you can construct, so that you can store the water. So that is termed as storage irrigation. That is termed as storage irrigation. When you talk about flood irrigation, in that the floods which will occur, so what you do, that amount of water is flooded to the fields and all. So that by that method, if you irrigate, that is known as flood irrigation. So if you want to see the photo, see, you are irrigating it on the surface. You can see it. This is surface irrigation. These are the photos. Secondly, if you talk about flow irrigation, water is flowing under the action of its own weight. There is no artificial means which has been applied. Then lift irrigation, see, pumped, then. Okay, so this is lift irrigation. Perennial irrigation, dams you can construct or weir or barrages. Next, if I talk about like direct, I already told you, weirs you have constructed, Okay, so or barrage also you can construct. Storage irrigation, dams is constructed. So this is it is a perennial irrigation, but it comes under storage irrigation. Okay, if you further bifurcate it. And flood inundation canal, the flood water is flooded into the fields. You can see it. You guys have seen it quite often. This is the flood irrigation, or you call it as inundation irrigation. Next, if I talk about subsurface irrigation, below the ground in the roots, you can apply water. Now, it can be naturally also, it can be artificially also. Naturally, when you see ground, I told you initially also, when the water infiltrates, you see seepage takes place. Naturally, seepage takes place. So, movement of water is there. So, it might be possible that due to seepage, the water goes to the roots. That is natural. Artificial is when there are networks of pipes which you have installed, and artificially you are supplying water to the root zone of the crop. So there is natural, or see, these pipes are there through which you are supplying water. So either due to seepage, water will seep and go, or due to the network of pipes which you have installed. So the one which you install, that is artificially. The one which occurs naturally on nature, that's natural subsurface irrigation. Simple. Okay. Now let's be quick in these techniques. Just know the briefing part of it. When you talk about the techniques of irrigation, techniques is free flooding, or you call it as ordinary flooding. Nothing you have to do. No land preparation, nothing. Just construct the ditches. Free flooding, you are not at all controlling the flow of water. Nothing. Just you have constructed the ditches, water is flowing. There is no control, no labor cost, no land preparation. However, the application efficiency of water also comes out to be. Okay, do it for close growing crops, but this is also done when there is sufficient amount of water available. But to be true, the efficiency comes out to be very less. Coming next to the border flooding. Border flooding is what you construct leaves. Leaves is basically like embankments, chabutra, which we say, no? Leaves which we construct. So now you have constructed leaves here, and then you do what? Then you supply water. Okay, so here first construct the leaves, and then through proper operation you supply water. So here basically, as compared to the wild flooding, you control the flow. Now, when you see in the field, it's very difficult to discriminate the border flooding and check flooding. It becomes very difficult. Why? Because when you talk about border flooding, there also leaves is there, check flooding leaves are there. But the only difference which you will see is in the case of, before moving it, in the case of check flooding, cross connecting leaves are also provided to check the flow of water. So it's not that only in the previous case in the border flooding leaves was provided along the contours, while in the case of check flooding cross connecting leaves are provided. Okay, so that is the only difference between border flooding and check flooding. Now, coming further, now there is a famous, you can say, relationship, the formula. When the discharge is given to you, infiltration capacity of the soil is given to you, depth of flow is given to you, how much time is required to irrigate the whole area. So the formula comes out to be 2.303 y by f log base 10 Q upon Q minus FA. There's no hard and fast unit. You have to substitute the units in a manner that if the time is asked in days, you should get it in days. If it is asked in hour, you should get it in hours. Y is the depth, F is the infiltration rate of the soil. Everything is mentioned to you. So this is the formula. Derivation is not important. If you want to go by natural log, just eliminate 2.303. That's it. Okay. Now solve this question, guys. Solve this question. And the maximum area which can be irrigated. So A max is equal to Q by F. So these are the two formulas. So let's solve this. .303 average average depth. Let me take everything in meter. 0.41. This comes out to be infiltration capacity. Where it is? It is 5 centimeter per hour. So I will take it as 0.05 meter per hour. Discharge is given to me in meter cube per second. So let us convert discharge 0.02 meter cube per second convert it into hours. So seconds, if I convert it into hours, I'll multiply by 3600. So I will get 72 meter cube per hour. Just check the calculations, huh? Swapnil, everybody. Devanshu. 72. This is 72. Catchment area is given to me 0.04 hectare. So this will be 0.04 into 10 raised to power 4. Come on guys, solve it. You will get the time in hours. Get the time in hours. It will come out to be, just check it out the calculations. Here log base 10. It will come out to be 0.65 hours, or if you do it in minutes, 0.65 into, it comes out to be 39 minutes. Okay, so this is the time required, and if it has asked you to calculate the maximum area will be what? Q by F. Q is 72 meter cube per hour. F is how much? F is 5. Let me take it as 0.05 meter per hour. So from here you will get it as 1440 meters square. This will be the area which can be irrigated. Okay, simple question, but they can ask you these questions. Okay, now Moving toward basin flooding or ring basin method, it's like check flooding also only, but but you can say the difference is basically you use it for plants and all, like orchid trees and all. You use this method of basin flooding. So you guys would have seen it in your roads also. Nearby to the roads, you see that there is a ring type structure is there, and basically a tree is there. So this is the basin flooding, you can say. Correct, Devanshu? Okay. So this is the basin flooding method. Furrow irrigation, here the basic difference is, in the previous one you were flooding the entire area. Here you don't flood the entire area. 1/5 to 1/2 part of the area is flooded with water. Okay. So here the initial cost of preparation of the land also comes out to be less. Moreover, the losses like evaporation and all in the case of furrow irrigation comes out to be less. Okay, so this is regarding furrow irrigation. Just briefing is required, nothing more than that. Okay, now sprinkler irrigation. Nowadays, the most prominent one, whether you travel through the highways and all, and you see lands on both the sides of the road, generally the maximum case you see sprinkler irrigation. This has many advantages obviously, but obviously with many advantages it comes with many constraints also. It comes like, ma'am, like you can see these are like artificially rainfall. Their perforations are there, with the help of which what is happening, you are supplying the water. So it's like an artificially rainfall you are creating. But the point is, first of all, you cannot use for those crops which requires water on everyday basis. Moreover, you use this sprinkler irrigation when the water table is very high. Okay. Plus, when you install these sprinklers, basically that is a cost. The cost will come. See, while flooding and all water, just you are just supplying the water. That's it. No labor cost, nothing you are doing. You are just constructed the ditches. That's it. But when you talk about sprinkler irrigation, sufficient water should be there. Moreover, if a particular crop requires frequent watering and large amount of water, you cannot use this. Okay, installation of it is also a costly process. Yeah, but the point is here, the water application efficiency comes out to be very good. Okay, best suitable for light soil. Yeah, but the point is it has a greater application efficiency. If you talk about all the surface irrigation, the one which gives you a maximum efficiency, that is the sprinkler irrigation. Okay, now talking about drip irrigation. Generally you use it, the another name for it is trickle irrigation. Whenever I dealt the objective part, many students don't know what is trickle irrigation. That is drip irrigation only. So as I told you, through a network of pipes, the water directly goes into the root zone of the crops. And if you guys remember in Sunday Ka Funda, you can yourself create a drip irrigation sort of equipment for your plants and all. If you are going for a long time, let us for 3-4 days, if you are going and you want that my plant should be there as it is, so you can opt for drip irrigation. That is very simple, but not that network of pipes you have to do. By simple plastic bottle also you can do this drip irrigation for your plants. Okay, but on larger basis, trickle irrigation, drip irrigation, proper network of pipes. See, this is a brainy thing. Brainy thing, ma'am. Brainy thing in a sense, what should be the energy of water at this point? What should be the energy of water at this point? All the points you have to first calculate the energy or the head, so that if supply this much water, at what time it will go and how much amount of water will go. So all those calculations needs to be done in the case of drip irrigation, or you can say trickle irrigation. Okay. Orchids also you can use, or you can use for those plants which gives you a higher value, means cost value. Okay, so these were the subsurface irrigations. Now talking about quality, if you want to calculate know the quality of irrigation water. So first in this, let's come towards the ask. Rahul, ask. First comes about the sediments. Now if you doubt, you're asking or you're not asking, tell me fast. Okay, so if you talk about sediments, see, if let us suppose, you know what, now this I'll be telling you in canals also. Initially if you northern place you see, एक समय पर वो एक depression हुआ करता था. Initially it used to be a depression, but what happens over the time when river was flowing, Okay, river obviously carries sediments with it. Now sediments aate kahan se? When there is breaking of, or you can say weathering of rocks takes place. Okay, when the weathering of rocks takes place, so river carries those sediments with it. Over the time sediments deposit हो जाते हैं, फिर उस area को, आप उस soil को, या उस वो plain area बन जाता है. Initially it used to be a depression, now it has become a plain area. और it's not that अभी हो रहा, 5,000 साल, 5,000 years, it took a period of time to take place. Okay, now when you talk about sediments, okay, so here those water, river water was carrying sediments with it. Okay, now if the fine sediments are there, fine sediments, when you get it, when the weathering of sedimentary rocks takes place. Okay, so when sedimentary rocks weathering takes place, then you get fine sediments. These fine sediments have nitrogen. Fine sediments have elements like nitrogen, phosphorus, sulfates. These elements are required for the growth of crops. Okay, now what will happen? Can we expect complicated questions from Thiesen's polygon method? No, the complicated one I told you. If they'll ask you, they can ask you a lengthy one, but not that complicated. Okay, now if you talk about fine sediments which came from sedimentary rocks, it consists of elements. These makes the soil fertile. So if basically that river water, see, river water, you divert it into the canals and then you supply it to the, or give the farmers for irrigation. So that water will contain sediments, and if the sediments are fine in nature, so this will improve the fertility of the soil. However, if the sediments are coarse sediments, you get coarse sediments due to the weathering of igneous rock. So if such water is supplied which has coarse sediments, it reduces the fertility of soil. It reduces the fertility of soil. Okay, it reduces it. Next, coming further, when you talk about concentration of salts, actually, you know, we don't have problem with the water in which salts are there. The problem starts when, see, a water was there in which salts were there. You supplied that water. Plants will use the water how much is required. After that, the salts which are left in the field, that poses problem. Now, how do you calculate it? So the salinity concentration, if you want to calculate, so if how much salinity is present in the entire water, divided by the quantity of irrigation water you applied, the minus the quantity of water which was used by the plants. And if in case effective rainfall takes place, you add that water. So total salts used divided by how much quantity of water, irrigation water you supplied, minus the amount of water which was used by the crop. And in case if any rainfall takes place, that rainfall also you are applying it. So technically it is like this: Q minus Cu plus Re. That rainfall you are. Okay, so in this way you calculate the salinity concentration. Now coming further, these values, however, they don't ask you, but if they want, they can ask you in match the following, or they will ask you to calculate salinity concentration, and they will ask you identify the type of saline water. So in this case, you should know, generally salt concentration we measure in the form of electrical conductivity in micromole per centimeter. Whenever you measure electrical conductivity, it is very much important that you should know the temperature, because electrical conductivity is dependent upon temperature. Okay, so if low saline water less than 25 will be the electrical conductivity, you can use that water for all crops and on every soil. Medium saline water 250 to 750, high saline water 750 to 2250. So these values, brief values, you should remember. Okay, now this one, sodium absorption ratio. How much is the sodium salt present as compared to the other cations? Because we have studied this in environment. Whenever the water comes, it consists of many cations, but there are most prominent bases. If you look at the multivalent cations, the ones which are present on prominent bases is calcium and magnesium. So sodium divided by calcium, magnesium by 2. So, but remember, very important thing. All these values are in milli equivalents per liter. Okay, ppm you already know that is mg per liter divided by equivalent weight, that is only known as milli equivalents per liter. So they can ask you this question in 1 mark. So make sure that if they are giving you the basically giving you the data in mg per liter, convert it into milli equivalents per liter. Let's solve question. But yeah, see, that was saline water for sodium concentration one. Here, when you are talking about sodium absorption ratio, so here 0 to 10, 10 to 18, 18 to 26, greater than 26. Why I'm telling you? Because if, see, this question, where is the question? See, this question is there. So first, this question is very simple, no issues. But the second question which comes, they will ask you identify the type of water. In this case, you should remember the table. If you don't remember the table, you won't be able to solve this. Okay, that's why a brief, you can say a brief knowledge of the table is necessary. That's it. So first, let us solve this only. Sodium absorption ratio. Come on, guys. Be ready with your calculator. Na plus Ca2 plus Mg2 plus by 2. 24, 3.6 plus 2 by 2. How much it is coming? How much it is coming? Do it fast. Nobody is doing a what? 24. 24 is a bit larger value. 14.34. 14.3. B is the correct. Similarly, this is same question. Only thing is, remember the range of it. Come on, solve it. You see, it's already given in milliequivalent, so we don't need to convert it. 3. So from here you will get 10. Now what is this? Low, medium, high or very high? Just look at this. 10. So what do you call it as? It will be, just a minute, 3 plus 1. It's not 3. Just a minute. Correct the data. This is 2. This is 2. Now tell me. This is 2. It is 2 coming. So 16.329. 16.329. That means it falls under 16.329. That means it falls under medium sodium water. Okay. Now, next moving further. Bicarbonate, if you talk about bicarbonate ion concentration, see, if bicarbonate anion is there, it combines with calcium and magnesium. If it combines with calcium and magnesium, it will precipitate out. Okay, let me tell you. See, bicarbonate combines with calcium and magnesium, and if it combines with calcium and magnesium, it will precipitate out. If this will precipitate, the value will decrease. If the value of calcium and magnesium will decrease, obviously the value of sodium absorption ratio will increase. Okay, so obviously bicarbonate ion concentration are there, it will increase in the sodium absorption value. Thus they can ask you statement wise, so you should know this. Okay, this boron obviously it is a toxic element. So if it is present in 0.3 ppm, it's good. It is essential for plant growth. But 2 ppm if it is there, see किसी भी चीज के बोलते हैं ना अति harmful है. So that's same for here. Boron if 0.3 ppm good. 2 ppm harmful for some crops. 3 ppm harmful for all crops. Similarly, if selenium is present, that is harmful for all crops. Okay, now similarly, if you know guys, nowadays the water which is irrigated, the crops irrigated with the water, and if that water is highly contaminated, contaminated means that water contains pathogens. Pathogens means disease causing microorganisms. If that water is used for the irrigation of crops and you do not, basically what happens, you eat that directly without you are washing it, then it causes health problems. Just you guys would have seen that sometimes some vegetables are there which you can eat it raw, and you, every Indian has this habit. Tell me, Swapnil leaves everybody taja hai, he says it fresh, and what do? You bite it. That's the wrong thing, because you have not gone into the field and see that which water they have used it for irrigating the crops. So don't do that thing. That's it. Say now, wash the vegetables, wash the vegetables. But we do. It's not you I'm telling, it's me also. Taja hai. And then what we tell? Oh, it's fresh. Eat them. That's not the thing you have to do. It poses health problems. Okay, when if the crop which is irrigated by contaminated water. Okay. Now, now next coming further. Charts I was not able to see. Okay. Now coming to the next, that is the soil moisture. Okay. So first what happens is, that soil is there. In soil, soil consists of voids in which you can say soil solids is there and voids is there. In voids, water can be there. In voids, air can be there. Now, what is happening? If above groundwater table in the soil, if the voids means empty spaces, if water is held, so in the soil, whatsoever empty space is there, if in that water is held, you call it as soil moisture. You call it as soil moisture. Now, how much is the water holding capacity of soil? It will depend upon the porosity of the soil and the size of the void. Porosity means water holding capacity of soil. Okay. Porosity, if you talk about, you should know that porosity of clay, or you can say porosity of fine grained soil, is more than that of coarse grained soil. Always remember, porosity comes out to be more for fine grained soil. Permeability comes out to be more for coarse grained soil. So porosity is more for fine grained soil, example clay. So that is the reason if you look at clay, the water holding capacity of it is more. Moreover, it also depends upon the size of voids. Voids means empty spaces. So if you talk about the size of voids, you divide it into two parts. One is capillary voids and the other one is non-capillary voids. In clay, the void size is small. Okay, so it will tend to greater water holding capacity. When you talk about sand, the voids are comparatively bigger, so the interconnecting of water is good, but it does not hold the water. Okay, holding capacity is less. So this if you talk about now, the water which is there present in the soil, it can be divided into three parts. But before moving towards this, let me tell you one thing. Generally, below the earth's crust, the entire Earth's crust, below the Earth's crust, the entire area is divided into broadly two parts. One is zone of rock fracture and the other one is zone of rock fluids. However, zone of rock fluid is not at all any use for us. There is no engineering significance of it. Okay, we call it as internal water zone also, because this water we cannot extract it by any engineering means. So this is of no use for us. We'll talk about zone of rock fracture. In zone of rock fracture, again it is divided into two parts. This is zone of saturation. I have not written zone of, and this is zone of aeration. See, for diagram, it appears to you that the zone of aeration is has a greater depth and zone of saturation is of lesser depth. Let me tell you, the truth is approximately 90 to 92%, or in some books you will find 90 to 95% of zone of rock fracture is zone of saturation. Okay. Now, zone of aeration is further divided into three parts. Capillary water zone, this is gravity water. I'll explain you one by one, don't worry. This is capillary water. This is intermediate water zone. And this is soil roots. Now what happens exactly? When you talk about zone of saturation, water will flow under the action of gravity. And if you talk about, ma'am, from which of the zone we extract water, so we extract water from the zone of saturation. Here, the entire voids of the soil are completely saturated with water. You have to apply energy more than the weight of the soil, and then what you will do, you will be able to extract water. While you talk about capillary water, here also the degree of saturation is 1, but here the void, or you can say the voids in which water is there, are held by the force of surface tension. Surface tension is due to what? Cohesion as well as adhesion. Force of attraction between same type of water molecule, or basically same type of materials, that is cohesion. Force of attraction between different types of material, that is adhesion. So what happens in the case of capillary water zone? The water is present, the soil is fully saturated with water, but in this water is attached by the action of surface tension. Intermediate water zone, here also the water will come under capillary action, but the voids are not completely saturated with water. Soil root zone is that where the plants grow, so here you apply the water. Here you apply the water. So these are the various zones which exist. ब्लर तो नहीं दिख रहा है, साफ दिख रहा है, मैं भी मोबाइल में देख रही हूँ. नॉलेज, आपको ब्लर दिख रहा है बेटा, बाकी सबको सही दिख रहा है. क्वालिटी उसकी चेंज कर लो. Okay, so gravity water flows under the action of gravity. There is only, you have to apply force equal to the weight of the particle and you will extract water. Capillary water, if you talk about, here surface tension also acts it here. Okay, and that water is used by the plants also. Hygroscopic water, that water which is attached to the soil, and it is very much difficult to extract that water molecule, that is known as hygroscopic water. Now coming further, you can see this gravity water. Capillary water is there, soil particles is there. So technically what is happening in the soil particles, this water is attached to it by surface tension. Okay. Next, coming further, hygroscopic water, as I already told you, which it's very much difficult to extract it. Plants' roots cannot extract hygroscopic water. Now coming further, you all know this thing, soil moisture one. Okay, so let's provide a briefing of it. So what you can see it, when the entire voids of the soil are fully saturated with water, then the capacity corresponding to it is termed as saturation capacity. Now, when there is a fully, you can say saturated with water, some amount of water for 2-3 days, it will drain under the action of gravity. Okay, gravity water. After that, the amount of water which is retained on the soil particle, that is termed as the field capacity. That weight of the water which is retained. Now what will happen? Water has been there up to the field capacity. Now plants will be using the water, and there will be a point come where plant will no longer able to extract water. And then what is happening? Drying takes place. You say wilts up or dries. So that point from where plant can no longer extract water, that is known as the wilting point. The difference between the field capacity and the point where plant can no longer extract water, that is termed as the available moisture content. But we don't wait that the plant should dry and then we should supply water. We don't wait till there. Before that, there will be a point known as optimum moisture content, till where plant can easily extract water. It's not at all difficult for plants to extract water. To the point of optimum moisture content, plants can easily, or you can say readily, extract water. So the point it reaches to optimum moisture content, we again supply water. We don't wait for wilting of the plant and then we supply water. So from field capacity to optimum moisture content, this part is known as readily available moisture content. So generally, we don't wait till wilting point. Okay. Now, let's talk further. Field capacity already told you, wilting point told you. So now, if I talk further, one more thing, this soil moisture deficiency, or they can ask you field moisture deficiency. Soil moisture again. Soil moisture means in soil voids is there, खाली जगह होती है knowledge. अगर उन जगह पर पानी भरता है, ठीक है, उन empty spaces में पानी होता है, उसको आप बोलते हो soil moisture. Okay. Now, soil moisture deficiency is कितना कितना पानी सॉइल में ऐड करो ताकि वो फील्ड कैपेसिटी तक पहुंच जाए. इफ यू सी दिस डायग्राम, हाउ मच अमाउंट ऑफ वाटर विच इज एडेड टू द सॉइल मतलब वो वॉइड्स में जाएगा बाय डिफॉल्ट. यू शुड नो दिस. सो हाउ मच वाटर शुड बी एडेड टू द सॉइल दैट इट रीचेस टू द फील्ड कैपेसिटी. क्योंकि उतनी ही डेफिशिएंसी थी, जितनी कमी थी उतना सप्लाई कर दो. Okay, so that is known as what? That is known as soil moisture deficiency. Now, if you want to know the field capacity, how much water is retained? About the same volume of dry soil. Simple formula is there for this. Gamma W dW gamma D into D. Or you can say is FC is equal to gamma W gamma D into N. N is the porosity. So this is one formula. Derivation is not at all important. This is okay. Clear हो गया knowledge आपका soil moisture. So and frequency of irrigation. Frequency of irrigation in a sense, if this is the optimum moisture content and this is the field capacity. So initially we supply water. Initially what we do, we supply water. Water goes, plants use it. It comes to optimum moisture content. Again we supply water. Again it goes. Again we supply water. So this is the whole graph which you see, and that this portion is known as the frequency of irrigation, which is equal to how much depth is there of water required divided by the consumptive use. Consumptive use already told you, water required for evaporation and transpiration. Okay, so this will give you the frequency of irrigation. Now guys, solve this question. Come on, Swapnil, Knowledge, Mudasir, everybody solve this question. It is asking you what? It is asking you frequency of irrigation. Frequency of irrigation is dW upon Cu. Consumptive use is given 12 mm per day. dW you need to calculate. See, generally how much water is to be added? Field capacity minus permanent wilting point. Or you can call it as phi. Phi is basically permanent wilting point only. But in the question it has told you moisture content must not fall below 25%. Where is that diagram? From field capacity to permanent wilting point. If nothing was mentioned, you would have done it. But in the question, one thing is written, moisture content should not fall below 25% of the available moisture. This much was the available moisture. 25% से ज़्यादा fall नहीं करना चाहिए. That means 75%. फिर irrigation कर दो. So you will multiply by 0.7. That's it. Solve this, you will get dW. First I'll write it here. 0.75. Field capacity is 0.30. Permanent wilting point is 0.110. Gamma W 1000 kg rho G ले लेंगे. Gamma GG will get cancelled out. Gamma D 1300. dW depth of root zone 800 mm. It will come in mm. How much it is coming? So everybody, how much it is coming? How much it is coming? Mm. Let me check it out. 0.7510 kg per meter cube. Everything will get cancelled out. 148.2. Everybody is getting, why everybody is getting the different answer? I'm not able to understand why everybody is getting the different answer. 800 mm is there, no? 1300 into 800 into 0.75. 5000. 148.2, huh? 148.2. Correct. So 148.2 mm divided by 12. Frequency of irrigation comes out to be 12.35 days. So we don't round it off. Generally, we have the habit of rounding off to the higher side. Don't do it, because otherwise the chances that the plant will build up. So to be on the safer side, we round it off to the lower side. That is the 12 days. Okay. Now, talking about the water requirement of crops, here good questions are waiting for you guys. So when you talk about water requirement of crops, how much water is required for the plant to attain its full maturity? Okay, so the time you sow it to the time you harvest it. जब आप फसल को सो करते हो और जब आप कटाई करते हो, तो उस पूरी दौरान how much amount of water is required? Now that will depend what is the climate, what is the soil, what is the rainfall. It depends upon those things. Now, coming further, there are a few things which you already know. Let's be quick in this. Crop period, you know, the moment you sow it to the moment you harvest this, how much amount of water is required. Base period, so before sowing, you prepare the field, you water it. So the first watering before sowing and the last watering before harvesting, that is known as base period. But you know that crop period is slightly more than the base period, but for all the calculations purpose, you assume them as the same, but you also know that they are not the same. Okay. Next, coming further, delta. If we say for rice, delta is 120 centimeter, it means that throughout the growth from sowing till harvesting, the total quantity of water required for the growth of rice, that is for the growth of crop, is termed as delta. We represent delta in terms of centimeter. So how much total quantity of water which is required by the crop throughout the entire base period, that is termed as delta. Okay. Now, duty. Duty is how much hectares of land you will irrigate if 1 meter cube per second of discharge is supplied continuously throughout the base period. So the amount of land irrigated in hectares when 1 meter cube per second of discharge is supplied continuously throughout the base period. That is known as what? That is known as what? Duty. Now coming, this is the prominent relationship which you guys know. The relationship between duty and delta. No need for derivation. Delta will be in centimeter or meter. Base period in days. Duty unit is hectare per Q max. Delta will be centimeter or meter? Meter. If you take it 864 B by D, then delta will come out to be in centimeter. Meter. This one it is in meter. Know that, right? Meters, Alec. This one meters, this one centimeter. Okay. Now, find this. Simple question. This one is very simple. Find delta of crop. Base period 120. Duty is 1500 hectare per cube. How much it will come? 8.69 meter. We reported in centimeter, 69 centimeter. This will be the delta. mm कहाँ से आ गया? From where is coming? 8.64, 120 divided by 1500, 0.6912 meter. अरे बाप रे. I'll faint now. I'll faint. Delta is reported in terms of centimeter. I already told you. Where were you? Come on, guys, solve this. A canal was designed to supply the irrigation need of 1000 hectare of area. Rice was grown. Wheat was there. Rice has a base period of 140 days. Delta of rice is 130 centimeter. Same canal is there. Base period of wheat is 119 days. Delta of wheat is 59 centimeter. Area which can be irrigated. How much area can be irrigated? Area of rice is given to you as 1000 hectares. Okay. It is asking how much area of wheat can be irrigated. How can you do this? How can you do this? Discharge is same now because the canal is same. Discharge is same. 69 it is coming, Mudassir, beta. Okay. Okay. So the discharge is same. Discharge is equal to A by D. Yes or not? Or D by A? So if I say area of rice divided by duty of rice, because discharge is same, area of wheat divided by duty of wheat. Now see, 8.64 B by D. 8.64 from both the sides will cancel out. Base period of rice B by D. D will go up. Duty of rice. Can I do like this? Can I do like this? D will become 8.64 B by delta. Because duty is not given, I can write it as delta R by this relationship. Area of wheat into delta of wheat. This is very simple. Otherwise, you go on doing it. It just takes your time. That's it. Now see, area is given 1000 hectares. Delta is given how much? 130 centimeter. Base period is given 140 days. Area of wheat you have to calculate. Delta is given 59 centimeter. Base is given 190. Simply you can calculate. Very good, Alec. 2210. You already know that wheat, and you know, common sense thing, you already know that if you want to check it, if you get a lesser answer than 1000 hectares, that will be wrong also, because you can see rice requires more amount of water, wheat requires lesser amount of water. If wheat requires lesser amount of water for same discharge, obviously it will irrigate more area. So that's common sense. If you get an answer lesser than 1000 based on the given data, that means you have done some calculation mistake. Oh, shear scheme. Okay. Now talking about the duty. Duty at various places, like from river, we construct diversion headworks, weir or barrage. From there, water goes into main canal to branch to major distributary, minor distributary to water course. Now, let me tell you. Generally, you might have seen, just letting you tell you, generally what you have seen, that in state government the vacancy of irrigation department and all is more. Yes or no? You have it. Why? Because what happens is you are the ones, irrigation department, water sahi se ja raha hai ki nahi, how much water is supplied, all you have to monitor it because you are the engineer in charge. So till this outlet point, it is the responsibility of yours. You are the engineer in charge. Okay, you are the engineer in charge, joining 6 p.m. The class will end at 6 p.m. I guess we are 2-3 chapters are left now, sir, Arun. This is the outlet point. This is the outlet point. Till outlet point, it is the responsibility of the engineer. After this outlet point, farmer. Farmer, farmer has to bring water from here to the field. Then it is the responsibility of the farmer. But from the rivers, diversion, headworks, main canal, branch canal, distributaries till the outlet, this is the responsibility of you as an engineer. Okay, and the duty at the head of this water course is known as the outlet discharge factor. If they ever give you outlet discharge factor, don't say what they have given you. The duty at the head of water course is termed as outlet discharge factor. Now coming further, okay, just tell me one thing. As we move from main canal to branch canal, then from major distributary, duty increases or decreases? Duty increases or decreases? Come on, guys. We move from main canal towards the field. Duty increases or decreases? Increases. Why? Because when we go to main canal to branch canal, conveyance losses and all are there. Okay, so when we go towards the field, the duty is more. So the duty increases from main canal to the water course to the minor distributaries and all. Okay, from upstream to downstream. Now, this asked in your A level. If they want, they can ask you. So you should know. Kharif crops, the month is from April to September. What are the Kharif crops? You should know. Rabi crops, October to March. Wheat, gram, mustard. Perennial crops, which takes almost a year. That is 300 to 360 days. Zaid crops, fruits and vegetables. That is March to June. One more thing is there which you don't know. Cash crops. You know that? Cash crops. Guys, you know what is cash crops? Cash crops. Tell me, I'm not going to tell you. Inferior crops are there, cash crops are there. What is cash crops? See, which you cannot consume directly, which needs to be processed. Is it? Okay. Now talking about crop ratio. Crop ratio tells me that how much variation difference is there as compared to area irrigated in Kharif season to the area irrigated in Rabi season. This will give me what is the ratio of the crop. So that is the crop ratio. Talking about paleo irrigation. Now generally it's not that the field is there, you sow the crop. It's not like that. First, what you do, first you water it. Before the sowing of crops, you water it. This you do it in your homes also. Whenever it's Kharif to Rabi beta, knowledge adda. Secondly, let me tell you, आपने ये चीज घर में भी की होगी. Whenever you grow a plant, what you have seen is first ऐसी सूखी मिट्टी में डाल देते हो क्या? You just insert it in dry soil. No, first you do it what? You water it. Then what you do? Then you insert a plant and then you water it again. You do that. Similarly for crops also. So prior to the sowing of crops, what you do it because it's dry. So first you add water. Okay. Then you sow the seeds. So that irrigation, that water is known as paleo irrigation. That is known as. Then core watering, core depth. Let me tell you, after sowing of crops, when a crop has attained a certain height, okay, after that, when you water, that is known as core watering. Okay, the depth is known as the core depth. The period is known as the core period. Core watering is used for design purpose. Okay, and when you want to calculate design discharge, you calculate corresponding to core watering because you can use base period. Base period will give you the average discharge, but if you use core watering, it will give you the maximum discharge, or you can say the peak discharge. Now next thing, these values you should know. मैम दोनों सही है या एक ही कुछ एजुकेटर बोल रहे दोनों सही है, रेशियो टू खरीदी है. Generally knowledge, that's true. Some places you will have written Rabi to Kharif, some places they have written Kharif to Rabi. So there is not an official that Kharif to Rabi is only the correct one. That's true. Now, talking about capacity factor, and देख के समझ में आ जाता है generally in Kharif season and Rabi season, but yeah, that's true. Some places you find Rabi to Kharif and some places Kharif to Rabi. Now, talking about capacity factor, let me tell you one truth. It's never ever the thing that every time a certain field gets the water. No. You would have seen it na, sarkar ne koi yojana nikali, some yojanas are there so that these 20 villages will get water. So 20 villages will get water for irrigation every day. No, it's not like that. Time is there. For this village, 10 days in a month will get water. This village will get 5 days a month water. So actually what happens, you think that water is supplied throughout the entire base period, but there is a certain frequency, like if 7.5 centimeter is water of supplied, then after 10 days 7.5 centimeter water is supplied, then after 10 days 7.5 centimeter, and so on. Okay, so if you talk about capacity factor, so capacity factor is mean supply, okay, divided by the maximum discharge, and maximum discharge you obtain during the case of core water. Next, time factors. As I already told you, irrigation doesn't take place throughout the entire base period. It takes place for a certain interval of time. Okay, so for that reason, you calculate the time factor, number of days the canal has run, and how much was the irrigation period. This will give you how much time factor is there, because see, if you're operating the canals, it might be possible. If you say that, ma'am, why you are doing so much of discrimination, let the farmer get the water for all days in a month, there are chances that water logging will take place. Water logging means, see, the soil is saturated with water. If the groundwater table level increases, you know that the plants require both water as well as air. So the voids will be completely saturated with water, air will not be there, water logging can take place. Okay, so that is the reason we don't supply or we do not transfer water for the entire 30 days in a month. Okay, for certain duration of times, the irrigation period is allotted to each and every fields. Now, coming to the commanded areas, coming to the time factor, yes, you can say that. Coming to the areas, gross commanded area, cultivable commanded area. Gross commanded area, total area. Like if your city is there, total area you call it as gross commanded area. But can you do irrigation in the roads, basically in the houses and all? No. So that portion of the gross commanded area which can be irrigated, that is known as cultivable command area. But you also know very well that we don't irrigate the cultivable commanded area at a single stretch. Okay, so we have a term that is intensity of irrigation. So it's like we irrigate a part of the cultivable commanded area as per the requirement. Okay, now talking about efficiency, listen to this very carefully because you will be solving question in this. So there are various efficiency for calculating how much losses is there. What are the efficiency? First is water conveyance efficiency. From the main canal, you have seen there is a main canal, from there the water comes into the field. So from the rivers, whatsoever water is released and whatsoever water comes to the field, that will tell you what is the conveyance efficiency. But remember, conveyance efficiency, in this losses are there. Conveyance, you call it as transit also. Synonyms also you should know. Losses like evaporation and all are there when the water moves from main canal towards a field canal. In diagram, it appears to be short, but in actual, it has to travel kilometers of distance. So during this time, there is a loss of seepage. There will be the loss of evaporation which is taking place. So that is the conveyance efficiency. Water application efficiency. So how much water, when you apply the water in the field, how much water is stored in the root zone of the crop, that will tell you application efficiency. In application efficiency, losses like surface losses and all are included. Okay. Next, if we talk about water use efficiency, water which is used consumptively divided by water which is given to the field. Why water is used? See, leaching requirement means if excess salts are present, you need to supply water so that along with water, the salts are also carried out, and with the help of drains, they are gone. So that is the leaching requirement. Before you sow the crop, there's a pre-sowing requirement. Certain amount of water stored that will contribute to the water used consumptively. Then water storage efficiency. Water storage efficiency, the amount of water which is stored in the field to the water which is required prior to irrigation. Okay, before irrigation, obviously you need water. Why you need water? Because you want to increase the capacity. So the water stored in the field to the water required prior to irrigation. Next, water distribution efficiency. Obviously, you know that obviously we want that uniform distribution of water should take place, but it doesn't take place. Okay, लीचिंग रिक्वायरमेंट को एक्सप्लेन कर दो. नॉलेज क्या होता है कि जब आप आई टेल यू इन हिंदी इफ यू आर कंफर्टेबल विद दैट, यू आर बिकॉज यू आर राइटिंग इट इन हिंदी. जब आप पानी सप्लाई करते हो उसमें सॉल्ट्स होते हैं और ये सॉल्ट्स जब सॉइल में जाते हैं तो जो ये सॉल्ट्स है ये रह जाते हैं. एंड इफ दीज सॉल्ट्स आर देयर, आपने एक हिंदी में वर्ड बोलते हो सॉल्ट्स के कारण जो सॉइल है वो अब बंजर हो गई, बंजर जमीन हो गई. So actually if you go in detail there are two types of alkali. Black alkali होती है जिसकी वजह से what you see the blackness you see and you call it that soil बंजर हो गई. Okay, so we don't want that condition to come. So what we do is we apply water, a significant amount of water, so that salts उसमें soluble होके drains के through निकल जाए. उस पानी की requirement को leaching requirement बोलते हैं. Clear knowledge? Clear? Now, talking about water distribution efficiency, actually we want that even distribution of water should be there, but it doesn't happen. Initially, the depth of penetration of water is more, and as we proceed, the depth decreases. Okay, so what we do, we calculate if this is D1, it is D2, D3, D4, D5. So we will calculate the average depth of penetration, D5 by 5, and then we will calculate how much deviation of individual depth is there with respect to the average depth. Like D1 minus D, we will take the mod, otherwise negative and positive will get cancelled out. Like this, divide by 5. So this will tell me the water distribution efficiency. Whatsoever water is supplied, is it distributed evenly or not? Okay. So now solve this question, guys. First solve this question, then the next one is efficiency question. Come on, guys, solve this. Solve this fast. Watercourse commands an irrigated area of 1000 hectares. Intensity of irrigation of rice in the area is 70%. So you can say the area which is being used is 700 hectares. Now the rice crop requires 15 days. Base period is 15 days. And during transplant, oh, not the base period, it requires transplantation of rice requires 15 days. And during that period, the depth of water which is required is 500 mm. This is the quantity of water which is required by the crop. Now, it requires 500 mm, but during that period, rainfall of 120 mm occurred. Okay, so first it is asking you find the duty of irrigation water. So delta is equal to 8.64 B by D. It is asking me to calculate the duty. How will I calculate? Duty is 8.64 B by delta. See, delta don't substitute 500 mm because now it does not require 500 mm. Why? Because 120 mm is satisfied. Satisfied by what? Satisfied by the rainfall. How much it will come? 380 mm. Substituted 8.64, base period 15 days only we will take it. Delta it requires in hectares per Qmax. This is 0.38. How much we are getting? How much is the duty which we are getting? 341.05. Is it? So we can say 341 hectares. This is getting. Also determine the discharge required at the head of the water course if loss is 20%. So if loss is taking place, what should be the discharge? Discharge, you know, Q is equal to A by D. So 700 hectares and D is 341. How much should be the discharge if this would have not been mentioned? 700 divided by 341. So the discharge should be 2.05 meter cube per second. But loss is taking place. If loss is taking place, we need to supply more amount of discharge. So what will be the discharge? 2.05 divided by 82. When you will supply 2.56 meter cube per second of discharge, then only the requirements will be fulfilled, because the efficiency is not 100%, a certain amount of water is lost. Okay, correct. Very good, smart tricks. Now this question. In this question, data is given to you. It has asked you what are conveyance application, distribution, storage efficiency. Come on, guys. Then you have consumptive use. Okay. Solve this fast. At least conveyance is a simpler one. You guys can calculate conveyance at least. Is it? Water conveyance efficiency you guys can calculate. Water delivered to the field to the one which is diverted. How much? How much is supplied to the fields? 120 liters. How much is diverted? 150 liters. You can calculate this. 120, 150 into 100. 80%. Very good. That is conveyance efficiency. Application efficiency, water stored in the root zone of the crop to the water delivered in the field. Now, water stored in the root zone of the crop. Now, how much water is stored? Basically there, 120 liters was delivered to the field. Okay. So, if we talk in terms of volume, how many liters was delivered? Liters per second. 8 hours. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Solve this. How much you are getting? And convert it into meter cube. So divide by 10 raised to power 3. How much meter cube is the water which is supplied to the field? You told the direct answer. 120 into 8 into 3600 divided by 1000. 3, 4, 5, 6 meter cube water was supplied. Remember, irrigation is not for all the time, 8 hours. Now in this, the losses in the field was there. So out of 3, 4, 5, 6 meter cube which was supplied, the loss was 400 meter cube. So how much water was stored in the root zone of the crop? 3, 4, 5, 6 minus 400. So it will become 3056 meter. So what you can say, water stored in the root zone of the crop to the water applied in the field into 100. 3056 divided by 3456 into 100. 88.42 it is coming. Mudasir, just check it once. 88.425 it is coming. This will be the water application efficiency. Now, water storage efficiency. Water stored in the root zone, water required prior to irrigation. You made mistake. So, water storage efficiency, water stored in the root zone, water required prior to irrigation. Okay, into 100. So, water stored in the root zone, how much it is there? 3056, already calculated. This much water is stored. How much water is required prior to irrigation? Now see. Where it is there. moisture holding capacity of soil is 200 mm per meter depth of soil. Okay. Moisture holding capacity. How much it is there? 200 mm. So I can write it as 20 centimeter per meter depth of soil. How much is the depth of soil? It is given to us the effective depth is 1.7 meter. So how much is the moisture holding capacity? This comes out to be the 34 centimeter is the moisture holding capacity. Now what it is telling me? That moisture extraction level was 40% of available moisture. So that means the moisture hold before was how much? How much moisture was holded? This would have been the condition when 100% would have been given, but it is given what? 40%. 40% was the moisture extraction level was 40% of available moisture. So it will become here 60. So 34 into 0.6, that is 20.4 centimeter. This much amount of water is required prior to irrigation. So if you calculate the volume, 20.4, 10 raised to power minus 2 meter. And what is the area? Area, 1.5 hectares. 1.5 into 10 raised to power 4 meter square. How much it will come? Guys, calculate. I am the one who is doing calculation. You should do it, but I am doing 3060 meter. How much it is coming? 99.869. This is the storage efficiency. Last one, very simple. It is the distribution efficiency. If you look at here, initially varies 1.7 meter at the head of field to 1 meter at the tail of field. So 1.7 meter and here it becomes 1.1 meter. This is the distribution. So first, or you can write it like this, or you can write it as capital D. So capital D will be the average of it. So 2.8 divided by 2, 1.4. And the penetration, deviation, mod, otherwise negative positive will get cancelled out. How much this is coming? How much this is coming? This is 1 meter or 1.1 meter. 1 meter. By mistake I have written 1.1. This is 1 meter. 1. Only 1 is there. 1.0. So this will become 1.35. And this will become how much? This will become how much? 0.35. So D, or you can write it as small y. That's up to you. Because in some books you will find they have written it like this. Or in some books they write it like this. So that's your call. Whatsoever denotions you want, you can use that. 1 minus 0.35 divided by 1.35 into 5. So you get 74.07%. Fine. Clear, Girish? Everybody? Okay. So this was regarding the efficiency. Now coming to the consumptive use. Already told you this. You want me to repeat? Plants when prepare their own food during the opening and closing of stomata, certain amount of water is lost. That process is known as transpiration. Evaporation already we discussed in detail. Okay. PET, AET also told you. Yeah. This was the formula. You can go for 2.541 or you can write it in this manner. Both are the same. Okay. Now there's one more question regarding consumptive use that I'll tell you. Oh, fine. Let's do the question first. But I have to do 2-3 more things I teach you. Wait. So this is the Blaney Cradle formula which you can use. Good question is waiting for you again. Then you have methods. These are the methods to find the consumptive use, that is the evapotranspiration. One is Blaney-Criddle method. Next one is Hargreaves class A pan. So it's again it's a pan where you put the water and you see how much water is lost by evaporation and transpiration. The diameter of it is given to you 120 centimeter, or you can call it as 1.2 meter, and the depth which it can accumulate it is 25 centimeter. Okay, generally you maintain a depth of 2 to 7 inches. Okay, and what else? 7, if you maintain 1 centimeter is equal to 7 into 2.5, 17.7, correct, maintain. And here the same thing, the only difference is consumptive use. In the previous one you were saying lake evaporation is equal to pan coefficient into pan evaporation. Here consumptive use is equal to K into pan evaporation. Okay, if they ask you sometimes Harvey's class A pan, then you have to tell. Penman's equation, there is AHN plus EA by gamma upon A plus gamma. That's a complicated equation based on energy balance and mass transfer approach. Okay, but that is, you name at least you should know Penman's, Blaney-Criddle, Hargreaves, because if they give you 4 options and they ask you which of the following is not a method to find consumptive use, so at least you should remember the name. Okay, that you should know. Now, coming further, when you talk about irrigation requirement of the crops, you have consumptive, net, field, gross irrigation requirements. So consumptive irrigation requirement is that requirement which needs to be satisfied, that is the evaporation and transpiration requirements. That means the consumptive use needs to be satisfied. But if during the consumptive irrigation requirement, if what happens, if rainfall is taking place, so that has to be subtracted. Now, when you talk about net irrigation requirement, this will be consumptive irrigation requirement plus if leaching salts and all are also present. So for removing them, water is there. So that is the leaching requirement also. Requirement. Okay. Now, when you talk about field irrigation requirement, field, what's the amount of water to be supplied in field? That is the net irrigation requirement plus conveyance loss, because when water travels from one place to another, there will be evaporation loss, there will be seepage loss which will be taking place. So, transit loss, or you can say conveyance loss will be taking place. Okay. Transit, or you can call it as conveyance loss. When you talk about gross irrigation requirement, field irrigation requirement plus. One mistake I did, nobody told it. Girish, Lisa, one thing I have written it wrong. Come on guys, tell me the mistake. Intentionally. Had your lunch and now you guys are sleepy. When you talk about field irrigation requirement, there are runoff losses. When you talk about gross irrigation requirement, there are conveyance losses. Nobody told that. So here there will be runoff losses when you talk about field. When you talk about gross irrigation, there are the conveyance, or you can say the transit losses will be there. Clear? फिर मैं application losses लेंगे. हाँ, correct. Now there are two things which you get it here: application efficiency and conveyance efficiency. So application efficiency which will be what? GIR by FIR, NIR by FIR. Tell me. Application, when you talk about, it will be NIR by FIR into 100. Conveyance efficiency, if you talk it about, FIR by GIR into 100. Clear? This you should know. This you should. Okay? Now, based on this question is there. Monthly mean percentage, everything is mentioned to you. It is asking you how much value is required for evapotranspiration. Okay, evapotranspiration and the irrigation requirement of crops. That means you need to calculate net irrigation, field irrigation, gross irrigation. Come on, guys. Same column is made here. So first calculate the consumptive use. First thing is you have to do is calculate consumptive use. Everything is given to you. Come on, calculate fast. K is given to you. P is given to you. Temperature is given to you. Here you have to substitute temperature in degrees Celsius. Everything is given to you. Calculate fastly. Substitute the values and calculate fast. Come on, tell me fast, fast. Lisa, Swapnil, everybody. Tell me fast, fast. Just substitute the values and tell me the values. Just substitute the values and tell me the values. That's it. Fast. Substitute the values and fastly. Swapnil, you calculate last two. Giri's, Lisa, calculate the first two. You're telling me the first value? First value 6.723. So let me take 6.72. Then first. Then just check it out. This is the consumptive use. Calculate the total of it. Just check the values. Devanshu, everybody calculate the values. Check it out. The total consumptive use comes out to be 24.76 centimeter and the total effective rainfall comes out to be how much? Temperature is in degrees Celsius. Temperature is given now. Oh, temperature you cannot see. January temperature is 13.5 degrees Celsius. February temperature is 14.5 degrees Celsius. December temperature is 15 degrees Celsius. Okay. Rainfall, if you calculate the rainfall, 8, 6, 14, comes out to be 10.9. 10.9 centimeters. That's it. Now you have to use it. First comes consumptive irrigation requirement. Consumptive, you have to calculate all types of irrigation requirement. Consumptive irrigation requirement is CU minus RE. CU is 24.76 minus 10.9. How much is consumptive irrigation requirement coming out to be? 13.86 centimeter. This is the consumptive irrigation requirement. Next comes out. Oh, this is the canals which have come. Let's do it here first. Consumptive irrigation requirement. Then we have net irrigation requirement. So let me do it here only. Net irrigation requirement will come out to be how much? Net irrigation requirement will come out to be how much? Or I'll insert. You guys can calculate till that time. Is leaching requirement given to you in the question? Is leaching requirement mentioned to you in the question? No. Since no leaching requirement is mentioned to you in the question, net irrigation requirement and consumptive irrigation requirement will become same. Why? Because since it is not given, so we will take it as 0. So the net irrigation requirement will be 13.86 centimeter. Here, now talking about field irrigation requirement. Already told you water application efficiency is NIR by FIR. I want to calculate field irrigation requirement. This will be net irrigation requirement divided by water application efficiency. Given to us as 65%. So 13.86 divided by 65. How much it is coming? 21.32. 21.32 centimeter. Now, if you talk about the gross irrigation requirement, field irrigation requirement, conveyance efficiency 21.32, and how much is the conveyance efficiency? 70%, 0.70. How much it is coming? 30.46 cent. So all the irrigation requirement clear? Understood this concept? Understood this concept? Everybody clear? So now we'll be moving towards canals. Channels, canals we'll be moving towards. So in this, various types of canals are there. Rigid boundary canals are there, mobile boundary canals are there. Rigid boundary canals or channels are cross section, shape, size, everything is regular. Only, or you can say there is only one degree of freedom, that is the depth of flow, while the cross section, shape, size, everything is constant throughout the length of the channel. So now when you talk about channels, canals, there are two things. One is unlined canals and lined canals. In India, mostly basis what you will see is unlined canals you will see. Ma'am, why? Because the cost of constructing lined canals is 2 to 2.5 times more as compared to that of the unlined canals. Okay. Now what happens? This is the unlined one, and basically our designing and all will be basically regarding unlined channels. And whatsoever studies we are doing it in the alluvial soils. I already told you initially it used to be a depression long time back. Over the flow of water, the water carried sediments with it, okay, due to the weathering of rocks. Now there is a soil, that is the alluvial soil. So then the water flows, it flows through the alluvial soil. So now when the water is flowing, it carries silt particles with it. Now if the velocity of the water is very less, the particles which are there, they will settle, they will deposit, and deposition is known by a name silting. Secondly, if what will happen, if the water is flowing with a large velocity, the particles of the channel bed, they will be carried away. So they are carried away, that means scouring is taking place, or you can say erosion. Now, there are two theories based on the design of regime channels, or you called it stable channels. Now, first is Kennedy's theory, the old one, then the modification of it is the Lacey's theory. Now, if you go by Kennedy's theories, Kennedy's, he was an executive engineer in the Upper Bury Doab. Doab means दो rivers को जब आप join करते जो area से पंजाब में 5 rivers को join होती है, ठीक है. So, Kennedy's theory, basically long back, more than hundreds of years now. So he was an executive engineer in Upper Bury Doab Canal, Upper Bury Doab region. So now what happens? He did his studies there. Okay. Afterwards, he introduced some factors, and it was been applicable to all other regions also. But he constructed his studies for the alluvial soil in the Upper Bury region. Now, what things which he told Kennedy? He told the eddies. Eddies are generated due to vertical currents. Now, you will say, ma'am, what is vertical currents? Actually, water flows in three directions: longitudinal, normal, and lateral. But the amount, or you can say the significant quantity, flows in the longitudinal direction. So, we may assume water to be unidirectional. But actually, it flows in three directions. So the water which is flowing in normal direction, the eddies are generated due to that. Now, when eddies are generated due to the channel is there, and whenever cuts, boundaries and all are there, there will be the formation of eddies. So now Kennedy told that here silts are there. Silts are there. Now the silts, the weight of the silt will try to settle it downward. The vertical component, basically the weight of the silt, will try to bring it down, but there will be a formation of eddies on the channel bed, and the vertical component of the eddies will try to lift it. If it was going down due to the weight, there would have been the deposition. But it is telling that because of the formation of eddies on the channel beds, what will happen? What will happen? It won't settle down. It will remain in suspension. So you will say that eddies might be generated from the sides. He said that no, they are not generated. And the silt supporting power is entirely on the eddies which are generated from the channel bed. The weight of the sediments will try to put it down, but the vertical component of it will keep it in suspension. So because of that, there will be no silting and no scouring. Okay, and that he called it as a stable channel, or you can say regime channel. Now, Kennedy did what? He introduced a critical velocity. This formula you have to remember. 0.55 m y to the power 0.64, where m is the critical velocity ratio. Now, he told what? First of all, before moving towards this, tell me this one. The critical velocity ratio which you used in Kennedy's theory. It is less than 1, more than 1, equal to 1. Come on guys, tell me. He introduced this factor. What is critical velocity ratio? Less than 1, more than 1, whatever is this. Come on guys, faster, faster. It can be less, it can be more, it can be equal. All. Why, Vivek? It cannot be equal to 1. It can be. So all of the above. M, it is asking about critical velocity ratio, beta. M. Shears. Okay. Now you can calculate the velocity also, but wait, let me tell you the procedure first. Okay, so it can be less, equal, everything. M is equal to 1. Already we have taken it so many times. Okay. Now, this procedure is not at all required, but just understand it. Now he told that you can assume a trial depth. Discharge is given to you. Range is given to you. So based on the discharge for which you have to design a canal, you can take a trial depth. Calculate the velocity from this equation. Depth you have taken. Critical velocity ratio is defined. You can take that. So velocity you got. The discharge you know for which you are designing the canal. Discharge by velocity will give you area. Now we design a trapezoidal channel section and we assume the side slope to be 0.5 horizontal is to 1 vertical. Okay, or you call it as 1 is to n, or you can call it as 1 is to x. That depends upon you. Now based on that, if you calculate area of trapezium, you can write b plus xy into y. And the perimeter is the wetted perimeter. This area, this area, this area. This will be the perimeter. You can calculate the hydraulic gradient. Now what will happen? What will happen is you will calculate the velocity. Manning's equation I have given to you, but let me tell you, Kennedy G has not used Manning's equation. He has used Chase's equation for calculating the velocity. If the velocity which comes by Chase's equation is equal to the velocity which you calculated initially, the depth which you assumed is correct. If not, then you have to change the value of depth. Now C value, this given by Cutter's coefficient. This is the Cutter's formula. This is the Chase's equation basically. This is the Chase's equation. And this is the Cutter's velocity coefficient. I know this is tough, but if they want, they can ask you, so you should know this. Now, if the values comes out to be same, that's true. Otherwise, you have to assume a different trial depth. Now, what is happening? Bed slope, he has given the range 13500 to 1 by 5000. And the value of n also, Chase's formula, you used it. And if you want to use Manning's equation, everything is given by Kennedy. Now, the main drawbacks of Kennedy was root over 8g by f. Here, that is Chase's constant. But the main drawbacks which knowledge told us right now. Firstly, if I asked you out of Manning's and Chase's what you will say Manning's. Why? Because Manning's is more observation based. Chase's was something which was derived on pen and paper. So all the drawbacks of Chase's theory went into the Kennedy's theory. And then for calculating Chase's constant, you use the Cutter's equation. Okay, so all the drawbacks went here. Moreover, you said that eddies are generated from the channel bed. You neglected the eddies generated from the sides. So that is also a drawback. You didn't give a formula for calculating slope. Okay, so all these were some of the drawbacks which you can say of Kennedy's theory. Moreover, the structures also started to fail. So now what we did, we go for Lacey's theory. But before that, do this question. Aditya Rajput. I don't remember, beta. Okay. Sorry, but I don't remember. You might be there then. Okay. So calculate the critical velocity as per Kennedy's method from here, guys. Calculate the critical velocity. Now see, here M is given to you as 1.1. Some places they give you 1, some places they give you 1.1. And what is the depth? Depth is given to you 1.5 to the power 0.64. How much it comes? How much this value comes? Solve this fast. Or I should only solve it. Calculator is not working enough. 0.784. 0.784 meter per second. The value. Now, Lacey give a modified version of it. It says that although when there is no silting or no scouring, it's not at all necessary, it's not at all mandatory that the channel is stable channel. Even though there is no silting, no scouring, then also it's not mandatory. It might be possible that the channel is not stable as well. Okay, so now what he said, what is he given? He gave the 3 regime conditions: true regime, initial regime, final regime. Now, what is said when you construct, here we are talking about artificial channels, that whenever you construct a channel, okay, it has a certain fixed sections, it has a certain bed slope. Okay, now when you are talking about true regime conditions, make sure that the discharge is constant, the flow is uniform, silt charge, silt grade is constant, and canal is flowing through incoherent alluvium. That means it is flowing through cohesionless soil. All these conditions needs to be satisfied when you talk about true regime, which you also know, silt charge, silt grade throughout the section to be should be same. All these conditions should be satisfied, then only you will call it as a true regime condition. Initial regime, it says when the longitudinal slope remains constant, you call it as because first the cross section should remain constant. Initial regime, the slope should remain constant. And when you talk about initial regime and true regime, if you add it, it will become final regime condition. All the theories which is applicable only for final regime condition. Now, the shape was also given to you. If it consists of a medium silt, this will be the shape of the structure. This is the channel. If it carries fine silt, this will be the structure if it carries coarse silt. Now, okay. So now if you talk about, there are 3 equations. Based on this, other equations are being calculated. So there is this equation, silt factor. All these equations you have to remember. Don't wait that you will do the derivation and do it. It's just a wastage of time. So silt factor is 1.76 root dmm, where this is the particle size in mm. Velocity is qf square upon 140 to the power 1 by 6. All these formulas, hydraulic radius, wetted perimeter, bed slope, all the formulas. See, Lacey has given the formula for bed slope, while Kennedy just assumed the value of bed slope. Okay, scow depth formula, everything was given by Lacey, already mentioned to you guys. So now what you have to do, if you calculate the design steps for this, okay, Lacey's theory is valid, correct. Now first you calculate silt factor, you calculate velocity, area. There will be 2 equations, area and wetted perimeter. With the help of it, you will get what? Width and depth of flow. So this appears to be quite easy, but some cases in some questions you need to do iterations also. Basically not iterations, you can say trial and error method. If width and depth are there and some other values are not given, then you have to go for iterations. Okay, now solve this question. This question, solve it. Then we will move to the sediment transport one. Solve this question, guys, fast. See, what you can calculate mean spaces on the. You can calculate wheel velocity qf square upon 140 to the power 1 by 6. 35 into 0.9 square 140 to the power 1 by 6. From here, calculate the velocity will come out to be 0.766 meter per second. You got the velocity. Okay, discharge is already given to you. Discharge by velocity. Guys, check out the calculations. 35 velocity is 0.76. How much will be the area coming? 45.69 meters square. You know, we take a trapezoidal channel section. Half horizontal is to 1 vertical. Already told you area, we write it as b plus xy into y, or you can write it as b ny into y. Area is given to you 45.69. Width you have to calculate. N is 0.5y. Depth also you have to calculate. Similarly, perimeter, if you calculate, this is b. Here wetted perimeter, here this portion. So it will become b plus 2y root over 1 plus n square. So perimeter also you need to calculate. Perimeter is given by the formula 4.75 root q. How much is the perimeter coming? Just check it out. The values and all. Width plus 2y root over 1 plus 0.5 square. Now solve this. 1 plus 0.5 square, if I take the root into 2. This will give me 2.236. So this will be 2.236y. Okay. So now what you can do, you can take the value of b from here and substitute it here. Okay. So take the value of b from here, and this is first equation, this is second equation. So take the value of b from here. What is this? B is 28.10 minus 2.236y. Okay, this is the value. Take this value and substitute it here. 45.69, 28.10 minus 2.236y plus 0.5y into y. Solve this, you will get the value of y. You will get the value of y. Substitute it here, you will get the value of width. You can solve it out. 1.83 meter will be the depth and 24 meter. You guys can check it out. This will be the one. Okay. So such simple questions are there. The lengthy it might be there, but such simple questions can be asked in Leahy's equation. Okay. Now, let's talk about sediment transport mechanism. Ready everybody? Now sediment transport is left. Then we have that Khosla's theory 1, Bleek's theory 1 left. Then the cross drainage zones. 2-3 topics more. Ready? It will complete in 1.5 hours, max 2 hours. Ready everybody? Come on, only knowledge is ready. What about others, guys? Yes, ready. Okay. So now we'll be talking about sediment transport mechanism. We are talking about alluvial channels and all. Generally from the sides of the channel and all, what happens, there are sediments which are present and they move and they are carried out, or they are detached from there and they move in the stream. So this phenomena is known as what? Sediment transport. You can see that these sediments are detaching from the channel. Now basically we have two types of sediments. Sediments load is that amount of burden, because load is that burden. So that burden which the water carries in a channel. Now there are two types of load. One is bed load and the other one is suspended load. Bed load is that load which moves along the bed. Okay. Suspended load is that load which remains in suspension. Name only you can say suspended load. It remains in suspension. Turbulence will be there, and because of that it does not settle down. It will remain in suspension. That is what? Suspended load. Now, let me tell you, this you would have studied in your open channel flow also. We calculated the average shear stress, that is gamma WRS. Except for the case of wide rectangular channel where R is equal to Y, hydraulic radius is equal to depth of channel. For any other shape of the channel, the distribution of shear stress is not uniform. You can see it at the bottom of this trapezoidal channel. You will see the shear stress is gamma WRS, while on the sides you will see the distribution is 0.75 gamma WRS. Okay, it becomes 0 here, and the maximum value which you will get it is 0.75 gamma WRS. So this you should know in case if they ask you in the sides or in the bottom channel bed. Okay, now so the equation which is given, this is equation is given by Shields. Shields equation is given for the sediment transport. The end results you should know. The critical tractive stress which is required so that the movement of sediment particles can take place in the channel bed for those sediments whose diameter is 6 mm is given by this formula. Tractive stress. Critical tractive stress. Okay, now generally when you see the specific gravity is 2.65 around, so when you substitute it, the critical tractive stress which you get, it is gamma WD by 11. You should remember this. Now, you don't want that erosion should take place. You don't want the scouring to take place from the bed. So, if you don't want that to take place, so the tau C, that is the critical tractive stress, should be greater than the tau naught. That is the shear stress when the flow of water is taking place. It should not be greater, or it should not be less than the critical tractive stress, and other way you can say critical tractive stress should be more than tau. So D should be greater than or equal to 11 hours if you don't want any scouring from the bed. Similarly, if you don't want scouring from the sides, make sure that here firstly tau C dash should be greater than or equal to 0.75 gamma W. Okay, tau C dash value is given to you. Tau C dash should be greater than tau C, and tau C is 1 minus sine square theta by sine square phi. Theta is the frictional angle, phi is the friction angle, and theta is the angle between the channel and the horizontal plane. Okay, so these are just the formulas. You can derive it, but these are very simple. You should remember the end result. That's more than enough. So if you don't want the scouring from the sides, you have to follow this one. If you don't want to follow, basically need scouring from the bed, you should know this one. Both the conditions you should know it. Okay. So guys, solve this question. It is asking you the minimum width. Okay, you don't want scouring to take place. What should be the minimum width should be provided for a wide rectangular channel? When it is talking about a wide rectangular channel, you know width is very high as compared to the depth. So when you calculate wetted area by wetted perimeter, which is by upon b plus 2y, you know this is approximately y. So this will become r will be equal to the depth of flow. Come on guys, calculate. This is a good question. Come on, solve it. Solve it fast. If you want no scouring to take place, so for no scouring, D is equal to 11 RS. R is equal to Y. Dia is given to you. How you will calculate? How you will calculate? हाँ, open channel flow, correct. मैम open channel flow आप ही लेंगी ना, पता नहीं कौन लेगा अभी तो. D11S. Now what is D? D. What is D here? 0.5 meter. Slope is given to you 11 into 0.01. How much it is coming? How much it is coming, guys? Solve this. 0.45 meter. This will be also equal to the depth of flow. Now in the question it is asking me the width. How will I calculate the width? If I calculate the area, I will be able to calculate the width. But how can I calculate the area? Guys, how can I calculate the area? Anybody? Anybody, how can I calculate the area? I can use the formula velocity is equal to 1 by n r to the power 2 by 3 s to the power half. What the things I know? R I know 0.45 to the power 2 by 3. Slope I know how much is the slope? 0.01 to the power half. But I don't know n. Remember in open channel flow there was one thing, one question has been also asked. Strickler's equation. What was that Strickler's equation? N d50 to the power 1 by 6 divided by 24. So you can use this. D should be in meters. 0.05 to the power 1 by 6 divided by 24. How much you are getting? Point 0.025 you are getting? 0.25. 0.25. How much it will come? Calculate the but mera here ma'am, this how she's expression valid. It is in centimeter, 5 centimeters, so it will become 50 mm na Devanshu. It is centimeter. Getting? Sometimes, in this one. Environment also, the die of the particle is not less than 0.1 mm, but they will write assume laminar flow to be valid, assume Stokes law to be valid. So they do like that. Okay. Calculate the velocity. मुदासिर बड़े comment कर रहे हैं. Calculate the velocity. Calculate the velocity. So discharge is equal to area into velocity. Area will be discharged by velocity. Calculate area. Nobody is calculating fast also. So got the area, substitute it here, and they can ask you such set of questions in GATE. So don't you think that they can't ask you. Depth 0.4. So 1.269. So the width will be 2.82 meter. This will be the minimum width. Clear? Clear everybody? Devanshu everybody? Okay. So just simple thing, lining when you do it, you can see these are the unlined canals. There is no lining which is provided along the wetted perimeter. But here you can see the lined canals are there. When you talk about lined canals, there are various advantages of it, like the seepage will be reduced, and you can say the losses, because seepage loss, evaporation loss, they contribute to 25% of the losses. So it's not a minor loss. Okay, canal capacity increases, flood danger is reduced. So all these are advantages. But paisa, money is honey. So money, it requires 2 to 2.5 times more cost as compared to unlined canals. So that is the reason in India you see maximum canals are unlined, and if you want that lining of canal is done, you have to justify that the benefit which you get in proportion to the cost should be greater than 1. If such is the case, then go for lining. Otherwise, lining should not be done. Okay. Now talking. Oh my god, dam was also there. I forgot dam. I thought. Shall we start now, dams? And dam is also there. We don't need to do any derivations. Dam is basically what? An obstruction barrier which is there so that it stores water. It stores water. So the pool of water which is stored, this is known as the reservoir. This is known as the, in my plan, money is temporary for me. Oh my God. Then give the excess money to everybody present here. Okay, if you have excess money, give it to everybody. Okay, and do spend it on good deeds. Now, we will be focusing on gravity dams. Gravity dams are masonry structures, and the main thing is whenever you talk about gravity dam, it resists the force based on its own weight. Okay, now you can see generally it is triangular in shape. This is the 3D diagram which you can see of the gravity dam. And if you want to see, anybody who is living in Himachal Pradesh would be knowing that the Bhagra Satluj dam, that is a gravity dam. If you can see it, you can see it from here. This is a gravity dams which is constructed, and you should know that it's not a lakhs project. It's like crores, 500 crores, 200 crores of project. Okay, so such projects are there. So whenever you design dam, it is very important. It is very important that all the components of forces, every type of failure is analyzed properly in the manual calculations. Now you can see the cross section of the dam also here. Okay, now what are the forces which are acting on the gravity dam? Weight, water force, everything is mentioned to you here. Okay. Now talking about the weight of the dam. Weight of the dam is the only one which will resist the other forces. So you can see this is the weight, this is the weight, this is the heel, this is the toe. So all these weight is there. Weight is equal to what? Gamma into volume. Okay, so you will every calculations which you do it for per meter length of the dam. Okay, and the gamma value of concrete which you will be taking, that will be 24 kilonewton per meter cube if it is not mentioned. Now water force, you know that the hydrostatic force, that is the water which is there on the upstream side, and if water is there on the downstream side, they will be exerting pressure on the dam. Okay, so this water on the downstream side is known as the tail water depth, and this is the water which is present on the upstream side. Okay, now if you want to calculate this, you might have studied in your soil mechanics also, that the base is known as gamma WH, and you can calculate the area. The CG, if you calculate from the base, it acts as this force acts as H by 3 from the base. Now these are the simple forces which you get. Then you have uplift forces. What happens? Water, water seeps, and from here this water exerts pressure on from to the base of the dam. So in the base of the dam there will be pressure exerted, and that is known as the uplift pressure. So here you will see the magnitude is same that of the hydrostatic gamma WH, and here you will be getting gamma W small h, that is the tail water depth. Now what will be through the pores, through the voids. Now what will be happening if you want if you want that this uplift pressure should not be there, because it may lead to the failure of the dam if uplift pressure is present in a significant amount. So what you will do, you will provide a drainage gallery. With the help of drainage gallery, the uplift pressure gets reduced. So the magnitude of a drainage gallery at this position is gamma WH plus 1 by 3 gamma W capital H minus small h. This is the value. So when you provide drainage gallery, the uplift pressure reduces. Now what happens? There is another force, that is the earthquake force. What happens? During the movement of tectonic plates, when the tectonic plates movement take place, during that waves are generated, which leads to the formation of earthquake. In short, so now the place from where it's originate, that is known as the focus, and on the ground surface that point is known as the epicenter. Okay, we say the epicenter for this earthquake is at this position. So now if you want to, actually the waves are generated in n number of places, n number of directions you can say, but for analysis purpose, for designing purpose, we will take that acceleration in two directions, that is horizontal acceleration and vertical acceleration. Now when you talk about vertical acceleration, see, acceleration and inertia force are opposite to each other. Like you guys will be telling me, if you're moving with a small speed in a bike, now if you accelerate, आप आगे की तरफ गिरते हो कि पीछे की तरफ, forward or backward? If you accelerate the bike, if you increase the speed, you will move forward or backward? Forward or backward, guys? पीछे की तरफ. Very good knowledge. तो आप move करोगे पीछे की तरफ. So what will happen? That is why, that is due to inertia. Inertia will resist the motion. Inertia will resist the motion. पीछे की तरफ move करेंगे. So यहाँ पर भी acceleration and inertia will be in opposite direction. Now, here the effect of acceleration can be positive, can be negative. Now the critical condition will be, what will be happening? The acceleration will be acting downward. If acceleration acts in the downward direction, inertia force will act in the upward direction. Yes or no? If yes or no, first tell me. If inertia force will be acting in upward direction, it will reduce the weight. And if it will reduce the weight, it will lead to what? Danger in the stability of that. Clear? Now the vertical acceleration. This is the formula, but horizontal acceleration is caused due to two impacts. One is horizontal inertia force, another one is the hydrodynamic force. Now, horizontal inertia force value, that depends upon two things, when the reservoir is empty and when the reservoir is full. Now, you guys will be telling me firstly, this is the heel and the toe. Okay. Now, when the earthquake, see, listen to it very carefully, everybody, Mudassir and everybody, Shias, everybody. When the earthquake moves from downstream to upstream, it is moving from downstream to upstream. Inertia force will be moving from upstream to downstream. This is the inertia force. Okay, the acceleration is from downstream to, what this comes here. So now what happens? When earthquake is going from downstream to upstream, inertia is just opposite in direction to the acceleration. It will be going from upstream to downstream. Water pressure which is applied is also from upstream to downstream. This is the critical condition. Yes or no? Knowledge, Mudassir, Shias, everybody. Why? Because water pressure is also acting from upstream to downstream. Inertia force is also acting from upstream to downstream. So what are they? They are the major components of destabilizing the dam. So the critical condition when reservoir is full will be because they will overturn towards the toe. So the critical condition will be towards the reservoir or away from the reservoir. When reservoir is full, the critical condition for earthquake towards the reservoir or away from the reservoir. Towards the reservoir, away from the reservoir. Guys, faster. Towards the reservoir. Earthquake force to downstream से upstream जा रहा है ना, towards the reservoir. Now, when reservoir is empty, what will happen? Upstream to downstream earthquake force is there. Okay. From downstream to upstream, inertia force will be there. Opposite. Inertia force will be there. Water is moving again from upstream to downstream only. This is the water pressure. Water is moving again. Overturning in this case will take place about heel. You know, when the reservoir is full, overturning about toe takes place. When the reservoir is empty, overturning about heel takes place. So this will be a critical condition. This will be the critical condition. Clear? ये कौन आ गया भाई? Fine. Overturning about heel. And here it was overturning about toe. Okay. Now, next talking about hydrodynamic forces. So, there is a formula by von Karman's equation which you need to remember. 0.555 kH gamma WH square, and this acts at 4H by 3 pi from the base. This you need to remember. Okay. Next, coming for the silt pressure. Silt pressure, the silts which are deposited, they also helps in minimizing the uplift pressure. So this is similar, again, your soil mechanics concept, half Ka, the height of the silt. Okay, don't take the height of, this is the mistake you guys do, don't take the height of the water, take the height of the depth of the silt. Okay, and it acts again h by 3 from the base. This is simple, nothing. एक बार हम okay. Now talking about wave pressure. You guys were asking na, in some books actually it is written 1 by 4, Devanshu, Swapnil, everybody, and in some books it is written 3 by 4. So, but in general majority I've seen PN Modi, in that it is written 1 by 4. Okay, but it's written, it's 1972 base. So it might be possible that the provisions have been updated. So the new one which we use is the 3 by 4. So, you know, waves are generated on the surface of the reservoir, and these wave pressure, okay, these waves which are generated, they will create a pressure on the downstream side. So if the fetch length, you can see the length or the wave height from the crest to the trough, if it is less than 32 kilometers, use this formula. However, never ever they have asked, but I can't say whether they will ask or not. And if the fetch length is greater than 32 kilometers, then this is the formula. Okay. Again, the wave pressure at various points mentioned. This is more prominent for ESC, but as I told you, we cannot predict. But yeah, this is the pressure at every point which is mentioned. Now, talking about ice pressure, wind pressure, actually, when they ask gravity dams in designing in ESC conventional, these all things becomes important in those conditions, but at least you should know the names of the forces which are acting. So wind pressure 1 to 1.5 kilonewton per meter square. Ice pressure generally a value of 500 kilonewton per meter square on the face of the dam, where it is in contact, ice is in contact with the dam face. Okay, so these basic things you should know. Now, this is the one which you have to know. Just remember the basic things, the formulas, because if you have time, you can derive it. Otherwise, I will say that remember the formulas. So, the modes of failure of dam is sliding, overturning, crushing, tension. If you see it, you might have not seen a dam failing and overturning. Rarest of the rare case it is possible. You know, no. You can say the point is, we design, it is a gravity dam. We design the dam for compression, and the dam fails in compression only. So whenever, if you Google it and you see the gravity dams, मतलब क्या आइडियोलॉजी है when you think about it. हमने डैम को डिजाइन किया कंप्रेशन के लिए, बट वो हमेशा कंप्रेशन में ही फेल करता है. You never see maximum cases, you never see the dam failing in tension. Neither the dam fails in overturning. In maximum times it will fail. If it will fail, it will fail in compression. Okay, but it happens. So now, when you talk about it, there are these modes of failures. When you talk about sliding, you should know that the vertical summation of vertical forces into mu, they should be greater than the horizontal forces if you want no sliding. And the factor of safety should be greater than 1. Okay. Now, if you talk about sliding, but if the shear strength, generally we provide shear strength of the joints also has to be taken into account when you're talking about high dams or very dams of high economic value. In that summation of vertical forces to, yes, correct. Okay, so resisting forces, because the vertical forces are the one which are stabilizing forces, also you can call it mu sigma v plus shear strength of the joint. This will be also acting in vertically downward direction. So if Q is the average shear strength and B is the width, multiply divided by the total horizontal force will give you shear strength factor, or you call it factor of safety. Now for overturning, obviously you want that if you don't want overturning, resisting moment should be greater than the overturning moment. And I already told you, you would have never ever, basically maximum cases overturning, it's not there. It's other types of failures which occurs. Cracking might take place, any other thing will take place. So if other than that, if the dam is safe in other components, there are maximum chances that the dam is safe in overturning also. Okay, crushing, or you can say compression failure. So you have here two components. One is the direct stress, another one is the bending stress. So the stress which you get it in toe is given to you. The stress which you get it at heel is given to you. Reservoir full condition, critical point is the toe point. Okay. Now, if you want no crushing to take place, I told you sigma T, stress at the toe should be less than the allowable stress of concrete. But sigma T is not the maximum stress. Okay, why? Because there is a component of shear stress also. So if you want to determine the maximum stress, take a small element and do all the calculations, not at all important. End results you should know that the major principal stress is equal to the toe what you get the stress sec square alpha minus sigma 2 tan square alpha. If there is no sigma 2 can be 0 also. So in that case, if tailwater depth is not present, the sigma 2 will become 0. So in that case, the principal stress which you will get is sigma t sec square alpha. Okay. Similarly, you can calculate shear stress also. And remember, if you don't want any crushing failure to take place, the strength of concrete should be more than the major principal stress. Okay, that you should remember. So these formulas you should remember, that's more than sufficient, no need for derivation. Similarly, if you want that tension should not take place, tension failure should not take place, whatsoever construction you have done dam, the resultant of it should lie in the middle. Or you can say the eccentricity should be less than B by 6. This is important. I think you guys already know regarding it. Okay, now the last thing only, the elementary profile. If you see you have top 0 and here the width is equal to the base width of the dam. Here the formulas, here three forces will be only acting. One is the weight of the dam, the water force and the uplift force. Only this force. Now remember, this is very important. Devanshu, everybody listen to it. If the reservoir is full, if they are mentioning anywhere that the reservoir is full, take C is equal to 1. It's not that don't, if nothing is given, I will take C as 0. No. If they are mentioning that full reservoir, take C as 1. If they are mentioning empty reservoir, take C as 0. Okay. Now you have again the same things we will be doing it. For no tension condition, the width comes out to be this. This is the other important for no tension conditions. Okay. Then for no sliding condition, width should be greater than mu Gc, the specific gravity minus the uplift pressure coefficient. Okay, right angle triangular section, correct. Then principal stress for no tension, already told you. And this one, principal stress, this is the formula for calculating the limiting height of the dam. Okay, this formulas you should know. Other than that, there is no requirement of derivation. That's for your understanding purpose. But in exam, if you have time, you can go the derivation. Otherwise, go through the formula. That's it. The shear stress. Shear stress not that important, but remember it. Come on, guys. Solve it. River training work to ESC का part है ना? Calculate this. Maximum height of elementary profile made of concrete. Come on, guys, solve it. Yes, very good. Told the formula, now solve it also. F 3.87, GC 2.5 plus 1. This is 9.81. The maximum height. Clear, Mudasir, everybody? So this is the formula with which you calculated the maximum height. So remember this formulas and all, this is very much important. Okay. Now coming to the seepage part. Ready? 113, 119. Right? Different answers. 112. three people, three different answers. It comes out to be 112.71. So it's rounded off to 113. Ready? Fine. So when you talk about hydraulic structures, like you talk about weirs or barrages, you see what that there is seepage which is taking place. The water seeps from the bottom, and that reduces the stability of the structure. It is a destabilizing force. Now, it is due to that the failure can take place. As I already told you, when the water seeps, there will be uplift pressure which will be there. So there can be chances that overturning and all can also take place. Secondly, if you talk about piping failure is there, what happens if this is a dam and from here the water is seeping? So it might possible that it will carry the solids with it, and so here along a pipe like hollow structure will be created, and the structure will sink. Okay, due to this seepage is not, इसको हल्के में नहीं ले सकते बाबू भैया. This is not a thing which you can take it lightly. So this seepage is there and you have not designed it properly. What will happen is sinking of the structure can also take place. Okay. So now that's a tough thing. So that's the reason different people have given different theories. Like Bleak has given Bleak's creep theory. Anybody knows what is Bleak's creep theory? He has told what? Firstly, he has told that loss of head is directly proportional to the hydraulic gradient. Yes or no? Have you guys know this Bleak's theory? First tell me that. Anybody knows Bleak theory, or I have to deal that also? I'm just asking. No. Okay. Now, what Bleak said that is directly proportional to the creep length. This creep is not the creep which you have studied in your strength of materials. Here the creep is how much length the water has traveled, that is known as creep length. Now you can see the water has gone here D1, here also D1. Then this is L1. Then here also D2, here also D2. So it will become 2D2. Then LT. Then it moves here D3, here also moves D3. So it is 2D3. 2D3. So this is the creep length. So it's not that creep which you have studied there. Okay. Length of flow or creep length you can say. Proportion to length of flow. You are asking shears or telling beta. Head loss per unit length, which is there to given to you. Okay, or you can call it as the hydraulic gradient. Okay, and it has told us that it is constant, whether you can call the flow as horizontal, whether the flow is vertical, whatsoever it is there. Okay, now loss of head, when it has talked about, Bleak has told us that if you don't want any piping to take place, provide sufficient creep length, that is, allow the water to travel sufficient distance. Now can you tell me one thing? If you don't want piping to take place, you provide sheet pile walls. You provide it on the upstream side or downstream side? Sheet walls you provided on the upstream side or downstream side? Come on guys, faster. Upstream side or downstream side? Downstream. Everybody. Upstream, downstream. What about else? What everybody else? First, by that time you decide, let me write it. Loss of head is not to the hydraulic gradient. The loss of head is directly proportional to the length of creep. This is the, I said hydraulic gradient by mistake. Sorry for that. Loss of head is directly proportional to the length of creep. Nahi pata. Okay. You know this, that for both for the case of piping and uplift pressure, upstream or downstream, दोनों में sheet pile while provide कर दो. ठीक है? Generally you say, okay, piping is there, uplift pressure is taking place, provide sheet pile walls. Why? So that the water has to travel more amount of distance, and the failure by piping or uplift can be eliminated. Now what is happening? As per Bleak, loss of head is directly proportional to length of creep. Creep is the distance traveled Already you know that. Now what happens? He gave all those things. He gave the value of C and all. Whenever you talk about it, loss of head is directly proportional to length of creeps. So when you remove the proportionality sign, you will get a constant which is known as Bleek's creep constant. Okay. Now this value of C is given by it. It depends upon the type of soil. Every value is given to it. Now the thing is, when Bleek gave you this theory, he didn't take in the effect of intermediate sheet pile wall. He didn't take in the effect of the effectiveness of outer sheet pile wall as compared to the inner sheet pile wall. Moreover, he is saying that the water or basically the flow is taking place in this direction, which is not the condition. So there were n number of drawbacks. So whenever you design the structure by Bleek's method, eventually the structure started to fail. Okay, so then we move towards Khosala's theory, but before that there was Lame's theory which also came into picture. Okay, so first solve this question, then we will go to Lame's theory. Come on guys, solve this question fast. Solve this question fast. I want the answers fast. Everybody, I'm seeing your comments fast. Everybody, I want the answer. And you guys know that if you want to prevent uplift pressure failure, you know that, right? T should be greater than H G minus 1, and for designing you take it as 4 by 3 H G minus 1. Just making you remember the formula. Come on guys, faster solve this. Now see, what is given to us? While designing a hydraulic structures, you got it also. 8.89, wrong. While designing a hydraulic structure, the piezometric head at the bottom of the floor. This is the bottom of the floor. The piezometric head at the bottom of the floor is 10 meters. Datum is 3 meter below floor bottom. Okay. And the standing water depth above the floor top is 2 meters. So standing water depth is 2 meter. This is 2 meter. ये 2 meter हो गया. Okay. Now what is telling here, if you calculate the pressure, okay, it is 3 meter below the floor bottom. So यहाँ से यहाँ तक अगर मैं करूँ, so here you will get 7 meters. 3 meter below the floor bottom. So here if you will put piezometer, you will get 7 meter as the head. Okay. Now it has asked you to calculate the thickness of the flow. How you will calculate? Simple, here the concept of fluid mechanics will be applied, nothing else. So what you can do? Gamma W, what you will do it here? Into 7 into 1. This will be equal to what? Gamma W 2 into 1 plus G gamma W 1 into T. Okay. So when you substitute, gamma W will get cancelled out. When you substitute the value of GC, what you will get? You will get the thickness as 2 meter. So if directly formula based question is there, you can go for this. But here since piezometer and all things were mentioned, you have to go by this method. Okay. So Bleek's theory, loss of head is directly proportional to length of creep. He hasn't mentioned about the intermediate sheet pile wall, the effectiveness of the outer sheet pile wall as compared to the inner sheet pile wall. All these things were not being mentioned or not encountered in Bleek's theory. Okay. Now there is a Lane's wetted creep theory. कुछ नहीं किया. जो Bleek's theory थी, everything was same. Only thing what he has told is wherever you can say whenever vertical distance is there, okay, you will give a factor 1. Wherever horizontal distance is there, you will give a factor 1 by 3. So if this diagram is there or what? No, it's not there. So let me tell you. See, vertical distance D1 only, and wherever horizontal distance, L1 is the horizontal, write 1 by 3 to it. L2 is the horizontal, write 1 by 3 to it. Nothing more than that. Only that was the only thing which was given by Lane. Okay. Now talking about Khosala's theory. This is the theory which we use for the economic structures and all. He told that what this league was telling, that the water is moving like this along the sheet pile walls and all, okay, along the bottom of the floor. But he told, Khoslaji told, that here the water does not move like that, which is told by Bleak. It moves in the form of streamlines. Okay. Now, whatsoever formulas which Khosla sir has given, he has given based on Laplace equation. Okay, Laplace equation, based on that he has given the equations. What are those equations? Generally it can be divided into multiple, you can say multiple, like this is upstream, here this is downstreams. You can do it like this. Here this is one figure, then the other figure comes out to be like this. This is the downstream sheet pile wall, and so I have just clubbed it up. Okay, I have just clubbed it up. So phi is the residual head which you get, residual seepage head to be precise, residual seepage head. H, that is the total head, and phi is the residual seepage head which you get. So H is the residual seepage. Okay, so from here residual seepage at any point is equal to phi into capital H. This happens. Now this were the at various points solving Laplace equation del 2 phi upon del x square plus del 2 phi upon del y square. By that Laplace equation, this was given by Khosla sir. Okay, he has given the formula at every point. Phi d1 is given to you, phi c1 is given to you. Every value at every point, this seepage value is given to you. Okay, he has also given the exit gradient, very important formula. Lambda value is given to you and alpha value is given to you. These are just the values which is given by him. Okay, just the values, but obviously solving Laplace equation, these are the very important values. If you want, you can see this. These are the relations. If you know phi e, you can calculate phi c. If you know phi d1, you can calculate phi d. So these were the relations which was given by Khosla sir. Now he told corrections, like if slope is there, then also you have to do correction. If floor thickness is there, then also correction will be applied based on the formulas which they has given out. Okay, then there will be what? Interference of pile, effect of one pile on the other. That also correction you need to apply. So in one pile there will be positive effect, on the other pile there will be a negative effect. So all these things will be encountered in Khosla's theories. All these corrections, nothing was being given by Bleach's theory. Okay, now tell me this question. Come on guys, tell me this question. You have to calculate uplift pressure at D1 and you have to calculate at C1. Simple. And now only I told you phi D1, phi D is equal to 100. So the residual seepage pressure at D1 will be 100 minus phi D, which is phi D is how much? 20%. This comes out to be 80%. What else? Phi C, uplift pressure at C1. So phi C1 plus phi E is 100. So phi C1 will come out to be how much? 100 minus 28, that is 72%. B will be the right option. Clear? Simple questions. Now this one. Here you have to calculate the exit gradient. This formula, remember it, they can ask you. So it's very much important that you remember the exit gradient formula. Lambda is 1 plus alpha square by 2. Alpha is B by D. Just calculate the values. Width is 10, depth is 4. So this will become how much? This is 2.5. 1 plus 2.5 square by 2. How much is lambda coming? Solve it guys. How much is lambda coming? This formula you should know. If you don't remember, practice this 2 to 3 times. Mudassir, Engineers Live, everybody. Practice this, you will get it. So this will come out to be 1 upon 3. So this exit gradient formula, this relation, these are simples. Okay, but I'll also advise that remember these values also. It's not that they cannot ask, they can ask. Okay, with the increasing competition, they can ask you. Okay, now last topic of this evening, that is the cross drainage works. Okay, now what are these cross drainage works? Basically, these are the structures which are constructed whenever there is, you can see the drains are there. What do you mean by drains? Any river is flowing, any streams is flowing, and you have to make a canal there. Okay, so in some condition it becomes unavoidable, and so we have to divert the canal or change the alignment of the canal, divert the river water. So for that reasons you have to make the drainage, cross drainage structures. Okay, now depending upon the you can say depending upon the relative position or the reduced level or the RS, we have different structures. If canal is there and drain is there, you can go for aqueduct and siphon aqueduct. Drain is at the top, canal is below, you can go for super passage or canal siphon. And drain and canal both are there, you can go for level crossings, inlets or outlets. Now, let's talk it about quickly. You can see these aqueducts which are formed. These are the natural streams or rivers, and there's a canal. You can see it here also. You can see this is the river and this is the canal which is there. So now what you can do? Now what you can do is here aqueduct when you talk about these are what happens. Obviously, when you talk about aqueduct or you talk about siphon aqueduct, canal is at the top, drain is at the bottom, which you can see it here. The only difference, if you want to distinguish, is when the bed level of the canal is sufficiently above the high flood level of drain, then you call it as the aqueduct. If you talk about siphon aqueduct, again canal is at the top, drain is at the bottom. But what happens here? The bed level of the, or you can say when the bed level of the canal is below the high flood level. When it was sufficiently high, then it was aqueduct. When it is below, it becomes the siphon aqueduct. Okay. Next, coming to super passage. When you talk about super passage, what happens here? The bed level here, the drain is at the top, the bed, or you can say the canal is at the bottom. Now here what will happen? When the bed level of the drain is sufficiently up as compared to the full supply level, it's significantly up, then you go known as that super passage. Reverse, canal siphon also, drain is at the top. But in this condition, what is happening? The bed level of the drain is below the full supply level of canal. So that is known as the canal siphon. So these things only you need to know, that's it, not much. However, if you talk about level crossings, what happens? When it's not possible to change the alignment, bed level, anything in this, what you do is drain water is, or you can say drain water is passed into a canal. Okay, it is passed into the canal and then it is taken back. That's it, passed, taken back. So this is done when it is not possible at all to make aqueducts, siphon aqueducts. So then we have to go for level crossing. Similarly, we have to go for inlets and outlets. What is happening? Inlets, from here we pass the drain water. Okay, there is an open cut which is made of pipe which is made. Okay, and outlet is what? From inlet the drain water enters, and from this outlet the drain water we just divert. So this is the inlets and outlets. Simple. Now guys, tell me, Swapnil, Mudasir, everybody tell me. Irrigation canal. Here the drain is at the top. Irrigation canal is here. The type of drainage structure. Drain is top, canal is bottom. The type of drainage structure. Which type of drainage structure is there? Level crossing cannot be there. Aqueduct happens when canal is at the top, drain is at the bottom. This will be super passage. Correct. Next. What type of canal cross drainage is provided when the canal runs below the drain with full supply level? For canal runs below the drain. Drain here, canal here. With full supply level of canal below the bed level of drain. बेड लेवल के बहुत नीचे है फुल सप्लाई लेवल केनाल का. अगेन ये सुपर पैसेज है. क्लियर? So these were the all things which you need to study. Scholarship test link is in the description, guys. और इसके साथ ही our irrigation is completed. Any doubts? Anybody ask? Otherwise, we'll wind up the class. So we completed it early. That's cool. Any doubts, guys? मेरा कमेंट रिवर ट्रेनिंग हो जाता तो कंप्लीट हाइड्रोलॉजी ये भी कंप्लीट हो जाता. Knowledge, I haven't included PPT of river training works. If you will say, I will take a class for river training also. Okay? Fine. So thank you everybody. Thank you so much for being with me from the morning 10 a.m. guys. And okay ma'am, thanks for the session. You are amazing. Thank you Mudassir. Thank you so much. Thank you Sapnil, Arun, Raju, everybody who are there, thank you very much, guys. If you have any doubts, I'll share my Telegram group also quickly. If you have any doubts, you can tag me. But don't expect that, like, see, like right now, if I'm taking class, then I won't be able to answer. Other than that, tag me whenever you ask any doubts. How gain my aim again? प्रेम कुमार, थोड़ा अपने आप को डराओ. अगर ये नहीं मिलेगा तो क्या करोगे? ठीक है? If you won't get this, what you will do? This will automatically, अगर नहीं हुआ तो थोड़ा डर होना चाहिए. ठीक है? फेलियर से थोड़ा तो डर होना चाहिए. What you will do? यार ड्रॉप लेना पड़ेगा, साल बर्बाद, all these things. Then you will study. You will focus more. So that you have to do. Okay? So guys, that's all for today. Take care of yourself, and any doubts you can message me. I'm from Kashmir, ma'am. Mudassir. I was knowing somewhere you would mean from the name I was seeing. Okay, Kash. कश्मीर के वो बहुत अच्छे है ना यार, क्या बोलते हैं उसको, सैफरन. मैं मेन आर लूज. प्रेम कुमार, थोड़ा अच्छे से बताओ ना, मेरे को रीड बिटवीन द लाइंस हो रहा है. मुदासिर मेरे लिए बोले क्या ना, क्या बोला मैंने अभी, सैफरन. पीडीएफ प्रिंटेबल फॉर्मेट में पीडीएफ दीजिएगा ना, ताकि प्रिंट करवा लूं. अरुण सबने मुझे बोला कि ब्लू में करना, तो मैंने ब्लू में कर दिया है. अब मैं एनोटेशन सेव कर दूंगी और मैं ये पीडीएफ आपको प्रोवाइड कर दूंगी. Come here. Mudassir, when you will get AIR1 and when I take your interview, na, that time bring it. Okay? आ जाऊंगी. Because of an accident. Prem Kumar, you message me personally on Telegram. I'll do your counseling. ठीक है? चलो. और कोई doubt? You message me बेटा. Okay? So, बिहार से हूँ आदित्य. बिहार से. Okay. चलो. सब पूरे सब जगह से लोग आए, सब स्टेट सिटीज के. गुड. ओके गाइस, थैंक यू सो मच. टेक केयर ऑफ योरसेल्फ. ऑल द बेस्ट फॉर योर प्रिपरेशन. कहीं पर भी कोई प्रॉब्लम हो, देन टॉक टू मी. गाइस, डोंट गेट डिसहार्टेंड एंड डोंट एवर टेक अ रॉन्ग स्टेप. So that's all for today. Take care of yourself. Bye bye and steady heart.